Ted to switch on his camera.
Okay. For everyone who's just arriving, we're still getting some of the AV stuff set up. Be another minute or two. All right. Good to go. All right. Welcome, everyone. I've got lights in my eyes, so I actually can't really see you all very well. So, but I think you can see me. I'm glad to see everyone show up. I know Sunday morning at 10 a.m. it's tough. I feel like I just rolled out of bed and stumbled over here. So, but I think I've got it together. I've got a couple cups of coffee in me at this point. I try to generally keep things kind of loose so I don't have problems with people asking questions during the presentation. I will stop a couple of times as well, so conversation is good. I'm almost as interested in answering questions as I am about talking about any particular thing, so don't hesitate to stop. Like I said, a couple of times I'll actually pause and give people who are interested a chance to ask questions. The room is small enough that I think we shouldn't have any problem with that, so just speak up, we should be good. Yep, I will repeat the questions though, so everyone can hear what everyone else had to say. So a couple of things before I get going. I will not be reliving my experiences on Lambda Mu. There's plenty of time for that, I guess, later. And I'm also going to avoid, even though I spent a lot of time obviously writing code and changing code and programming, I'm not going to spend a lot of time talking in depth about actually how to program or any of the really deep technical aspects of what I did. What I'm going to really focus on is hopefully kind of the intersection of the community and how that impacts technology and what that means for code that actually is pretty dang old. It's the first version of Lambda Mu was released in 1991, which is 20 plus years now that has been around. So it brings with it the community that exists and the length at that time that code has been around brings kind of an interesting spin to what otherwise might be just kind of a maintenance project. So without further ado, let's get rolling. Let me check and make sure it's still works. Awesome. So the first thing I wanted to do before I kind of get into talking about Lambda Mu in general, I wanted to talk about where it came from. So who here has heard of Xerox's Palo Alto Research Center? A good number of folks. Excellent. So this is relevant because a number of things rolled out of PARC over the years, and they all kind of impinge on this talk in interesting ways. So one of the things that came out was a language called Smalltalk, which was an early object-oriented language with a particular environment and a particular style, not only of programming, but of interacting with a machine, essentially. A little bit later, the graphical user interface came out as well. This is something you might have seen downstairs on the second floor. This is actually the Apple Lisa, so Steve Jobs was inspired by looking at the Park Alto, I think, which was an early GUI-based machine that was being designed at Park. There was another language that came out of Xerox PARC that is probably even more relevant than Smalltalk, and that's a language called Self. And we'll talk about why that's important in a little bit. Self, some of the early developers of Self, if you pay attention to these things, actually wound up working for Sun and developed the hotspot virtual machine, which is a big chunk of Java technology now as well. And then, of course, to get to the point, LambdaMoo came out roughly around 1991. So a researcher named Pavel Curtis, who was employed at Park, built this with inspiration from a number of the other languages, not so much the GUI piece of it, but some of the other languages that had come out of Park as well, and that play into the design that he implemented. Some other interesting things, I guess, that came out of Park as well. Ethernet, obviously, laser printers, some other cool stuff. So it was a thing. All right, so very quickly, what I want to do is get into, I guess, what the purpose of the talk is about. So I'm not, this is obviously Sunday morning, somewhat more lightweight session than what was going on midday yesterday, but I do have kind of 3 points that I wanted to kind of emphasize as I talk about technology and community and maintaining old code. One of the interesting ones for me is that text is still relevant. I think it's somewhat underrated, especially if you spend a lot of time playing online games. You may not think about it, but in fact, text is still very much with us. Related to that, and I think that ties into kind of the DIY ethic that a lot of the talks today or this weekend are about, easy to build is actually very important as well. So text is still relevant, easy to build is important. And then tying back to some of what I talked about what was going on at Park, immersive needs another chance. And I think you'll see how these all tie together as I get rolling along. All right, so a little background, just to help me calibrate a little bit so I understand kind of what the audience knows and doesn't know. Who knows what a MUD is? Okay, about half of the audience. Okay, excellent. So the word MUD, M-U-D, actually is an acronym for multi-user dungeon, and it was kind of a descendant of early single-player kind of online adventure-type games that actually ran on big servers, not so much PCs, and ultimately was the precursor to what we have as massively multiplayer online role-playing games, the graphical versions. So a MUD was actually a multi-user environment, virtual reality. Most of them, kind of had a kind of an adventure D&D style theme to them or whatever, hence the dungeon aspect of it as well. So, and Moo, which we're going to talk about in the form of LambdaMoo, actually stands for MUD, object-oriented. So it was a specific MUD engine or MUD server that had an object-oriented set of underpinnings, which makes sense, I guess, given, once again, its genealogy. Another background question, what is LambdaMoo? Who knows what LambdaMoo is? Who's actually interacted with it? Okay, great. So LambdaMoo is actually a particular kind of MUD. It's simultaneously a couple of things. So here's LambdaMoo. And actually, this is a recent screenshot from a week ago or something like that. So by and large, it looks a lot like it did back in the day. I've actually got it connected up via Telnet on my laptop, but at this point I won't try to switch the screen over to that. But basically, it's a text-based environment. And if you log in, it simulates in its virtual reality this mansion and the grounds around the mansion, and you can move from room to room, right? So it was, so LambdaMoo in the biggest sense is actually kind of three simultaneous things, right? Most people, I think about LambdaMoo, they think about the online community because that's the piece that got the most attention, right? So there's this online community called LambdaMoo. It was launched in 1991 and still going today, and if you log in, you'll still find people on there interacting and doing things. It's probably not as popular as it once was, but it's actually still surprisingly very popular. And not in a bad way. I think that's actually tremendously interesting. LambdaMoo is also simultaneously a database of information that constructs that world, right? So there's a LambdaMoo core or a LambdaMoo database that implements that virtual reality. And the third thing, and the thing that I'm mostly going to talk about or talk around, is a server. So Pavel Curtis actually created a piece of code called Lambda Mu that actually runs, it's a server, and it runs and implements that virtual reality. It's the thing that you connect to and that's running it. It's also the piece that people extended, people actually downloaded, set up their own worlds on top of, et cetera. Okay, so once again, that piece of it specifically is what I'm interested in. We'll talk a little bit about the core itself, but I want to talk about the server primarily. All right, so as I said, online community, text-based virtual world. It's the database that describes that virtual world, and it's the server software that runs that virtual world. So Lambda Mu, the community, was interesting for a number of reasons. So this is all still background, right? I just want to kind of get to the point eventually here. So there were a couple of things, and those of you who interacted with this or spent time on the community will probably remember some of these things. It had a very flexible gender-based pronoun type system, right? And so we'll talk about that a little bit more. A very liberal attitude toward building and programming. So users were in many ways encouraged to contribute by building and extending that environment. It had a petition, kind of a popular petition ballot-based system for actually running it. And for a period of time, the users were actually in charge of that, rather than, in the case of most MUDs at that time, a group of people called wizards who had kind of super user powers. And then, of course, there was a vast amount of associated literature that came out of that whole thing as well, both scholarly literature, popular press, et cetera, all covering that. So I wanted to drop into the gender thing. So this was very interesting, right? If you look at many online games today, especially the graphical ones, it's actually pretty hard to think in terms of gender, right? What gender there is probably reflects what a 15-year-old boy would consider idealized versions of gender. And because you're dealing with a graphical environment, it's actually pretty hard, other than some kind of crazy, body morph type of thing. It's hard to convey gender in an interesting way that works with us in a linguistic sense. And what Lambda Mu had actually done was implemented this very flexible gender system. Honestly, out of this list, if you couldn't find something, I don't know what to say, right? I don't even know what some of these are. But it was very interesting anyway. There was a lot of text as well, so I went and grabbed a couple of things. If you even just literally go to Google, type in Lambda Mu, you're going to find these in the top set of hits, right? It's just a variety of different things. People were writing about the notion of being online and in a virtual community at that point in time. What's even more interesting about it, and I haven't found anything similar for code that came out around this time, earlier this year there was even a play that was put together literally in February of this year about the rape in cyberspace episode, turned into a play where people kind of revisit that piece. So nothing else from that time frame I'm aware of has been made into a play, certainly not Mosaic or early browsers or whatever. So anyway, I find this amazing. So even I didn't have a chance, unfortunately, to see this play. The friend of mine who told me about it, unfortunately told me about it later than I could have actually done anything about it. So it may still be going, I haven't taken a look. But I find it very interesting that from a popular culture perspective, people are still finding a way to relate to all this. So on the server side, the server was actually interesting for a number of reasons as well. It had a persistent object database. So you built in terms of objects, you thought in terms of objects. This was very definitely part of the small talk and self heritage. It was a prototype-based object-oriented language, which is very similar to what self provided, and not like prototype in terms of JavaScript. I mean, it was probably a more proper prototype-based language as opposed to something that was class-based. It supported simple cooperative multitasking. So this was actually very important. So the vision for Lambda Mu was that people would get in there and program. And so they took that into account when they built it. It wasn't just a group of builders who built it offline and fired it up. It was people logging in and having the potential to interact and change that system as it was running. So it had to support kind of a simple cooperative multitasking environment and a simple permissions-based security model so that users couldn't screw with what other users were actually creating. It's not perfect, but it was reasonably good for the time for sure. More interesting, I guess, depending on your interest in kind of the popularity of programming languages, the data model was largely immutable. So if you created a list of values and you essentially couldn't mutate that, the operations in the language actually created, new instances of that, which harkens to kind of the resurgence of interest in languages like Haskell, which make immutable data essentially a hallmark of that language. So they understood even at that point in time that immutable data made certain kinds of multitasking code or distributed parallel code safer to write. So the Lambda Mu, I guess the point is, had a reasonably solid theoretical underpinning that came out of its time at Park, and I think it's part of the reason why it still continues to be popular.
So it's based on lambda calculus?
Not really. Lambda was the alias of Pavel Curtis. And so that's how they got the lambda piece. But yeah, not really. I mean, if you looked at Scheme or something, you'd see obviously the lambda calculus in there, not so much. So I'll show a snippet of code, and actually it looks very much like kind of very simple code and not at all like Scheme. Now, there we go. There's the code. So this is a little chunk of code from the package system that I built, and basically just a little chunk of code that recursively deletes some stuff inside of a package. I'm only throwing it up there just to give everyone a sense of what the code looks like inside of Lambda Mu. It's a very, very, very simple little language, but you know, sufficient. You can see method calls and things like that in there. All right, so I've been talking about Lambda Mu. If you actually look me up on the internet, you won't find my name stuck in with a lot of Lambda Mu stuff, primarily because what I'm working on is something called Stunt. And they're very closely related, but I wanted to make sure everyone understands the distinction as well. I'm going to talk a little bit about Stunt, but actually talking about that, other than the changes that I made to Lambda Mu to create the thing called Stunt, it's not really the centerpiece exactly of what I'm talking about. So if you think back to the slide of the text-based environment for Lambda Mu, this is the contrast. So Stunt is basically Lambda Mu reimagined for the web. It has been updated in some areas, some new functionality has been added, actually considerable new functionality. But the basic metaphor is, let's get Lambda Mu, let's get that mud code up to something that you could actually hit inside of a browser in a meaningful way in an easy fashion. Okay, so at some level it's not particularly revolutionary. On the other hand, I think from an accessibility perspective, it's actually very, very, very important. So that is Stunt. Some of the things I guess I just wanted to point out very quickly about it. And I guess the question too is, you know, what was my interest? So what I was trying to do at the time, I loved the notion of Lambda Mu's kind of immersive environment for programming. I wanted to build some simple immersive experiments. I love the idea of people being able to interact with something that you've created and extend it and via programming, right? To me, that's been the holy grail as long as I can remember, right? Programming and creating were tied together. It was very hard to do, and without some kind of web-based accessibility, it was essentially not going to be reachable to a large number of people. So I had been involved with Lambda Mu. I'd been on it. I discovered it when I was in graduate school, within a couple years when they released it, in fact, and had started playing with it. So I had a sense of it at that time, and just kind of maintained this ephemeral attachment over time. Came back to wanting to design these immersive kind of experimental things. And so I wanted to pick up something I was familiar with and extend it in interesting ways. So some of the things, just very quickly, and I'll talk about this in a little bit more detail, that I did. I obviously added HTTP support, which is probably the most visible one. There was, because ultimately no one, outside of this group, if you go down to the street outside, no one knows what Telnet is. They don't know how to get one. You know, they're not going to be able to do anything useful with that. There were some limitations in the code base. MD5, for instance, from a hashing perspective, from a security perspective, is effectively broken. And that's the only hashing tool you've got inside of the server. It didn't have certain data types. There was no map-based data type. You had a list, but no map. I think people kind of expect that now, especially if you're going to be talking JSON or something like that. And ultimately, Lambda Mu, like Smalltalk and a lot of early object-oriented environments, had a very deep inheritance hierarchy, which was enforced by its single inheritance model, and so I wanted to break that up as well. So let me go and kind of pause for one moment before rolling there and just see, got time for one or two questions if anyone wants to stop and ask questions before I actually get on kind of the meat of what I'm going to talk about. Go ahead.
Can you touch on the rape inside the space area?
Yeah, so I mean I can. I won't. The general episode, so the question was, can I touch on the whole rape in cyberspace episode? So the context there, and I'll just say a few words, I guess, to give people a sense of the flavor of the thing. The notion of an online community was very new at the time. I mean, you had Genie, you had CompuServe, and a few things like that that were obviously multi-user. Lambda Mu was very interesting and new because it was very unstructured, right? There wasn't a set of system administrators enforcing a lot of things. And so that particular episode involved a character who found a flaw or an exploitable opportunity inside of the database and was able to essentially make other characters in that virtual reality do or appear to do what that user wanted. And so that obviously was fairly traumatic for a lot of people. It was fairly new. It literally, made news. It became a play at this point in time. So what's that?
So it's a Bob Reed salad.
Yeah, it was actually Mr. Bungle abuses a large number of people. But anyway, is that close? Yeah. So anyway, very interesting one. Very interesting episode for sure, and informative in a lot of ways, and I think reflective of what Lambda Mu, the community, was and was not at that time. So okay, let me go roll and start talking about text and why it is relevant. So this section, so roughly speaking, I want to talk about the community, I want to talk about the code, and then I want to talk about the use of those codes to code together. And I think as this rolls along, you'll see how it all ties in. So very quickly, this is the section about community. And what I did is I took some snapshots of some of the information out there just to give everyone a kind of a data format, a sense of where the community has been and where it is right now. So this is actually, SourceForge is where the server software is currently hosted. They have a mailing list associated with it, and this is the number of posts starting in about 2002 last year. There haven't been any posts on that mailing list this year. So you can see that there is some, even as going back as far as last year, as recent as last year, some posts. Obviously not quite as much activity though. The big place for talking about Lambda Mu is actually in a Google group called Mu Talk. And so that started around 2008 and has been, relatively popular. Certainly around 2009, 2010 was probably the point of most posting. But there continues to be on a monthly basis dialogue and discussion, primarily around building, a little bit around the server itself. So it kind of encompasses both the server and the community or building side of it, people trying to set up their own things. The contrast here, though, anyone who spent time on MooCows, which was the mailing list for the server in the mid-90s, that had literally, up to, probably on average 300 posts a month, 200 to 300 a month, and up to 500 a month. So obviously, the mid-90s, the volume was there. What was interesting, though, as I started getting involved, my interest wasn't so much connecting with the community as extending the server for my own purposes. But in doing that, you end up hooking up with whatever community is left. And I found some very interesting things that kind of tie into text and why it's relevant. There is a MUD. This isn't a Lambda Mu, but it's a MUD called Alter Eon. The interesting thing about this is that if you poke around, almost all of the players are actually blind or seeing impaired. So as it turns out, now this is not, like I said, Lambda Mu, but it ties in very closely to what I'm going to talk about in a second about text. It turns out that there's a reasonable number of people for which the fancy graphics in a online multi-user graphical role-playing game simply is not effective, right? They can't make use of that environment, but they're still gamers. They still want to have fun. They still want to play. And so surprisingly enough, there's actually a fairly reasonably sized, passionate community of gamers out there who are seeing impaired or blind who actually make use of this. I've got on my laptop, and I'll keep rolling because I don't want to run out of time, but on my laptop I've got a text-to-speech reader, and you can connect up, and I actually have tried this several times with a whole bunch of Moos, and you can actually play these things and interact with them with your eyes closed. Sit in the dark, close your eyes, which is nice if you stare at a screen like I do all day, and actually interact with a virtual world purely audibly. So on the Lambda, like I said, this is just a MUD. On the Lambda Mu side, there is a company called RS Games. Now, they're not making communities, they're not making adventure games per se, they're making more social games, but their back-end engine is actually Lambda Mu. So they're using the Mu server basically to manage all of the games, to implement it from a programming perspective, and then what they provide is a client that allows you to download sounds and some things like that so that you can actually play these games. Their whole market is visually impaired gamers. Another forum called Audio Games focuses on, broadly speaking, games. Could be ones you install right on your laptop or your PC, online games or whatever, but they also have discussions and people launching on a regular basis new MUDs that are basically text-based. So I don't want to imply that like this is the majority of people using MUDs. Go ahead.
No, no.
Okay,
I
okay.
asked a question there. I was just
Okay, yeah.
parsing something in my own mind.
Okay. So I don't want to imply that the community of people using text is the majority of people, or people that are visually impaired is the majority of people using or playing MUDs. It's still a small minority. It's probably larger than the population as a whole. But my point is there's a community out there for which this is a very, very valuable resource. Text-based itself is interesting too. So the whole point here is that this got me thinking about the role of text overall. And what's interesting to me, and the reason why I consider text to be important, is because the effort curve, the learning curve to create something is so much smaller. If you think about writing a book or putting together a presentation or building some kind of a virtual reality, a single person or small group of people can actually build something creative using text. And it can be very engaging, right? Books are still incredibly engaging for people that read them. And text has that property. We're built to handle language in that format. And so text itself still ends up being very relevant because the production costs for doing something graphically are so high. If you want to create a game, if you want to, just for your own benefit or for a small community, want to do something and do it with full kind of visual production, you're going to need a team to do that. You're not talking so much about individual creativity. There may be a creative director and some people involved, but you're going to have a team of people basically building that, and they're going to be building aspects of that. If you write a book, there's still the notion of an author and an editor and a few people involved in actually creating that piece of work. And so what this episode highlighted for me is that from a creativity perspective, and I think that ties into kind of the DIY thing that I like so much about events like this and other maker type things, for me, the creativity is what it's about, right? I'm not interested in people that are trying to make $100 million in a theater, right? I'm interested in what average people are trying to do to create interesting things for themselves and their community. And so from that perspective, I think text is very relevant because the number of people that are going to be able to build something visually engaging is much, much smaller than the number of people that can build something using text as a metaphor. And the way our brains work, it actually works very well. So that was kind of point number one. Text, I think, is still very relevant both practically and just kind of conceptually as well. So before I roll to the next point, anyone have any questions or comments? Go ahead.
Do you have any sense of how large that market is for text-only, from a commercial perspective, for text-only games?
Yeah. Yep. So the question was, do I have any sense of how large that market is in terms of text-only games for the seeing impaired? I actually don't in terms of good solid numbers. I have talked to the folks from RS Games a couple of times because they use Lambda Mu. They were interested in whether or not something like Stunt would be useful from the back end, and were interested in actually adding thread support and some things like that just to see if they could get better performance out of their engine. My sense is that if you focus on it, you can, certainly make a decent living doing it. So if it's something you care about and want to do, clearly companies are doing that. Obviously, the number of visually impaired gamers is quite a bit smaller than the number of sighted gamers, and so, the market is just going to be small. All right, so the next one I wanted to talk about is why easy to build is important. So as I kind of get into this, what I wanted to do is just go through very quickly the status of Lambda Mu overall. So Lambda Mu releases. So the last official release was actually in 2000, so it's version 1.8.1, and that's what most people actually download and use. Okay, so they're using code that's 14 years old. There were some unreleased versions and some kind of unofficial versions that came out by the people that are actually maintaining the main server. There's the question, too, of why I didn't try to extend, I obviously tried to extend Lambda Mu. I'm not the maintainer of Lambda Mu. I didn't even ask for that role. I'm not sure I would take it if someone offered it to me. Lambda Mu is still an ongoing thing. People have expectations about it. They use it and they want it to behave a certain way. I want to break things. And so for me, trying to both maintain a piece of software that people use and break things was too hard to maintain or to do simultaneously. So I chose instead to call, even though it's very compatible, literally you can take code that runs in Lambda Mu, bring it up in Stunt, and everything's fine. I wanted to make it clear that I wasn't maintaining Lambda Mu per se as trying to pave a path forward. And ultimately, it would be nice to see some of that rolled back into the main server. But I was very definitely trying to break some things. So there was a 182 that was unreleased, a 183 that was unreleased, and there's a 184 that's actually in progress. But we're still talking about code that's actually relatively old. What's interesting to me is that people still download this. So if you go to SourceForge right now and take a look, they provide wonderful metrics about what people are using. And I could get this for Stunt too, but I didn't bother. Stunt is hosted on GitHub, and I just didn't fiddle around with trying to get these numbers out of there. But people are still downloading it to the tune of probably 50 downloads a month. Go ahead.
Where's the main Lambda server located?
Yeah, I don't know physically. I can pop the URL up. I think it's actually in Washington State, to be honest with you. I think the guy who runs it right now, which is one of the guys who's been around using it and running it forever, is located up there. So I think physically that's where the server is. But it's actually at the same URL it's always been, I believe. So the question was, where is the server located, or where is Lambda Mu located? So people still download it. I found this very interesting. People still run it. Okay, this is the crucial one, and this is part of the reason why I didn't want to become the maintainer per se. So MudStats is a site. If you augment your code, whatever MUD you're running with a couple of bits and pieces, you can actually publish information to MudStats, and people can actually look up various categories of MUDs and see how many people are playing or online or various things like that. So I think when I snapped this a week or two ago, there were 54 MUDs, and new ones appear periodically, and of course the existing ones are still there. If you look 2 lines down, you'll see Lambda Mu, which is still very popular in terms of MUDs. It's only the second most popular one, right behind Helmu, which is quite an entertaining place. But my point is, and there's some other ones too that have been around since the 90s, and then some new ones that appear, but the point is people are still running and still building these things, right? This is like still a very active area, not in comparison to the number of users of Facebook, but in terms of kind of, people that are roughly this, I guess, what's that?
Ancient key.
Yeah. So anyway, I thought this was interesting, and you can see the different versions here as well. So the last point, and I'm going to come back to this one, but I just wanted to throw it out here, is that people are still trying to recreate Lambda Mu. Not so much the community here, but the software, and I'll come back to that in a second. So think about people are still downloading it, people are still building it. What does that mean? Okay, it means they're dealing with some very old code, and that's where I get to kind of more the code technical side of what I'm going to talk about. What does old code mean? So this is what old code means to me. How many people know what that is? Okay, awesome. So you don't see a lot of this. There's a great line right here. Let's see if I can find it now. From the README itself. But basically, if you look at the Lambda Mu README, it literally has some lines in there that basically say you're going to have the best luck if you find yourself a largely ANSI-compatible C compiler. And it's like, when's the last time you even saw that in README? When's the last time you even saw Kernahan and Ritchie style code? It's not all over the code base, but it's definitely in there. The regular expression package, I swear to God, is based on Henry Spencer's regular expression package from forever ago. And it's still got KNR style function declarations. So it's some old code. A lot of it's been updated, and of course it uses POSIX primarily, which makes things a lot better. So anyway, that's what old code means. That's kind of entertaining, but it's not necessarily the most important part. There's another kind of old code that's actually much more relevant if you're trying to do things right. There's code in the old server that, simply speaking, doesn't perform its intended function like it should anymore. So the only hashing function that's available in the Lambda Mu server is MD5, and that's it, right? So if you want to hash things, if you want to create some kind of a digest, you're going to do it with MD5. That's probably fine for many applications. From a security perspective, MD5 is completely unacceptable, right? It's effectively broken. So if you are, kind of just building something simple, you probably don't care about that. If you're actually concerned about building something that's going to be able to function properly on the web, it's actually a big problem. One, because it's broken, and two, because other protocols out there require your ability to hash other things. So RIPE-MD or something like SHA-1 or SHA-256 are considered to be much more acceptable hashing functions. So it was necessary for me to essentially continue to support MD5, but ultimately make the default something more sensible. So the point here is that when you're dealing with old code, and this is kind of the pragmatic side of the talk, when you're dealing with old code, you're gonna find code that was in there that probably compiles fine, it functions correctly, but it's simply not adequate to its intended task anymore. Another way that this plays out, people tended to use hashing functions like MD5 to compute things like digital signatures, and it turns out that almost any combination of your own code plus MD5 is probably going to be the wrong way to do something secure like that. What you do now is use something like an HMAC. Which is, been kind of demonstrated to be a better combination of these primitives. So adding an HMAC support was an important piece as well. Once again, the average user probably not going to care, but if you're really concerned about doing things right, you're going to need that. Another place where people were using something like a hash function incorrectly is in dealing with passwords, right? So if you used Lambda Moo's built-in crypt function, you got whatever your OS, your operating system supported, which was, if you didn't pass anything in there, probably going to be something like triple deaths, right? Which is, whatever. It's not great. The problem with even using something like SHA-256 in your own construction is that password hashing should have some additional properties that you're not going to get with a fast hash. In particular, password hash should probably be really slow. It should take a lot of CPU cycles. It should abuse the CPU or the computer in ways that make it hard to parallelize, for instance. So really the state of the art there is something like bcrypt or scrypt. And so what I did is I actually built bcrypt into the server itself as the default for the crypt function, so that if anyone was encrypting passwords or hashing passwords to store, they were going to use something that was a little bit closer to modern standards. Related to hashing, so once again, this is the technical bit. I hope it's enjoyable for some of the folks anyway. Related to the security is the fact that you should really try to have good randomness, right? Modern web applications, modern applications in general benefit from having access to good random numbers. Lambda Moo's random function basically was a linear congruential generator that was fast but not particularly good for generating long streams of numbers for something like a secret key or whatever. So I built in something using the Sosmanuk cipher, which is relatively recent, but it is underwent, at least handled some decent amount of scrutiny. And it's seeded from dev random and then generates good, secure, cryptographically secure random numbers in big batches. So if you need 64 bytes of random data for a key or whatever, you can actually get that in something less predictable sort of way. And then of course the last one that I mentioned before from an old code perspective is with Mudge you're going to be dealing with Telnet. And once again, Telnet's great, but Telnet is not something that the average user is even going to know what to do with. They've probably never even heard that word. And so the first thing I did was build in the HTTP support that allows you to make some use of this inside of a browser. So, and I've got this. If people want to come up afterwards, I can actually demonstrate some of this, or maybe toward the end, the Q&A section, we can talk a little bit. I can pop these things up. I've got them running on my laptop. So I want to talk now about some kind of the downsides where some of the technology starts to impact the community in interesting ways. So once again, thinking about the community, you're dealing with a group of people that have very specific expectations about what Lambda Moo should be and how it should behave. And as a result, incompatibility, and they're not extremely tech savvy. So you have people with the barest ability to maybe download the code, run configure, run make, they've got Xcode installed or they've installed the GNU toolchain or something, right, LLVM or whatever, and they're actually can get it to configure, get it to compile, and they can get it to run on their database. But I mean, that's the extent of it. They're not programmers. So it's a largely non-tech savvy, application-focused user base. So for that group of people, incompatibility is actually a big problem, especially when you're trying to break things like I am. So this was definitely something that has to be weighed in terms of what you want to do with a chunk of code. Where this was relevant for what I was trying to do, Lambda Moo basically writes to disk a representation of the in-memory data structure. So when you save it, what gets dumped to disk is basically something it's text-based, but it's ultimately the in-memory data structures. That supported a particular style of object orientation and a particular way that parents and children in a OO environment were constructed, et cetera, reflected in the physical manifestation of that database. So in order to support something like multiple inheritance, which was actually important for me for constructing software, I wanted to be able to mix things together versus create long inheritance chains. That changed the format of that database. So while Stunt can read old databases, it actually doesn't write old databases anymore. And it turns out that that's actually a huge problem for a lot of users because, you know, when you're dealing with new code, you want to know, can I go back? And so there's a big disclaimer on the Stunt thing, you know, back up your database because you cannot go back. It's like probably theoretically possible, but pragmatically, I'm never going to write that code. So that turns out to be a big issue, something to keep in mind. On the platform side, though, things are actually a little bit better. If you go back to look at the README and some of the documentation for Lambda Mu, you have something like 10 or 15, now maybe 10 or 12 different Unix-y type of platforms, right? You've got, various, you've got obviously Linux and things like that, but you've got, well, I'll just read the list. You've got BSD, Unix, AIX, IRIX, Sonos 4, Linux, System 5, Release 4, Ultrix, OSF, FreeBSD, Solaris, Next, etc., right? So back in the day, you dealt with that all the time. As it turns out, today, you pretty much only have to worry about 2 or 3 platforms, right? Linux, obviously, a lot of people are now building software on Macs, so you're some kind of a BSD sort of thing. And then, like, half the people that download Lambda Mu are actually on Windows platforms, so something that maybe compiles under Sidewin or something like that. You don't have to worry about Sonos 4, for instance. It's pretty much not an issue. So that's kind of nice. The patch side. So the other thing that was interesting from a community perspective about Lambda Mu is there was a large collection of patches that people applied. If you go back and look at the screenshot of the MudStats thing, almost no one is running straight like 1.8.1 Lambda Mu. They're running 1.8.1 plus a bunch of patches that they downloaded and applied. So there's a lot of patches floating around, and there's a kind of a desire to obviously see some of those rolled in or supported. Where this became interesting and challenging was that in a software project, you probably do or should have a point of view of what's important. In the case of Lambda Mu, there was very definitely a model behind what they did. Because it was an environment that was meant to be easy to program for multiple people simultaneously, there are some kind of invariants that should be in place. For instance, a chunk of code that a user writes shouldn't block the server while it's doing I/O. Like if you keep everyone else's work from proceeding, all their verbs from running, you actually bring the little virtual world to a halt while that piece of code is running. That's important, right? Your code shouldn't be able to muck with other people's code, so the security aspects needed to be preserved, and obviously you don't want to crash the server. Because the community has always been very embracing of people without deep technical skills, a lot of the patches out there violate one or more of those, and some of them flat out outright crash things. So it was early on attractive to maybe put those in. As it turned out, it's actually much more important to keep the code quality up and make it clear from a contributions perspective exactly what you would like to see that people provide. So that's the kind of the old code side of this thing, the technology piece of it. This ties into this. Oh, go ahead.
I'm kind of curious, if you load an old database that was made for a server with those patches, will stuff like those?
It depends. Some of them it will, and some of them won't. It depends on if it actually changed the way the data was stored, the data structures were stored. So for instance, there's a fairly popular patch that added kind of a class-based inheritance scheme called WAIFs, lightweight objects. The structure of that changes the in-memory data structures, or the implementation of that functionally changes the in-memory data structures in a way that's actually even kind of hard to predict in terms of what it will do to things like some hard-coded constants. So it doesn't handle those very well at all.
So you could could you take the text and change its format to different typeface, or put it in a cartoon balloon or something like that?
You could. In fact, if you want to come up afterwards, I'll show you the user interface piece of it. Right now, it's very simple and designed for exploring. So the question was, can you change the visual aspects of it and maybe show?
I'm interested in ad cluster.
Okay. Okay.
I'm interested in putting messages, sponsors wouldn't endorse.
Okay. Yeah. I mean, the user interface is web-based, so you can do quite a bit. The key, I guess, from the easy to build perspective that I wanted to tie back into is, once again, easy to build means easy to try, right? And part of the reason I tackled this, or one of the things I was doing parallel to this effort, was actually trying to implement diaspora. So I spend most of my life writing code. There's nothing about diaspora that's complex for me per se, but it became very obvious when I was trying to set that up in, I don't know, 2010 or sometime around then, 2011, that the number of moving parts in that piece of software, which I consider to be potentially very important software, simply was going to be impossible for the average user to set up. They were going to have to use other people's diaspora nodes to connect to be part of the diaspora network. And setting up something on their own is going to be virtually impossible. So easy to build is important from a DIY perspective, because easy to build means it's easy for people to try it out. Lambda Mu, oddly enough, is a proof case for that. It's very easy for people to put it together, launch it, and get it going. This last little bit is pretty quick. So let me go just roll right into this. Lambda Mu came out of an environment where programming was immersive. So rather than sitting down with a text editor, editing a bunch of files, compiling them and running them, or loading them into an interpreter and running them, you basically sat inside of the server itself and made changes so that you could see those changes happen immediately. That isn't highly popular, although surprisingly enough, going back to Smalltalk for a minute, there is a relatively new project called Pharaoh out there, which is once again a reimagining or an extension of Smalltalk, trying to kind of bring it back. And if you go to the site, you log in, you got this graph. It's like a combination IDE, runtime, et cetera, all in one piece, right, where you interact with the world. I think if you followed along, the notion that immersive might be important or need another look actually kind of fits into the whole thing, right? You can kind of see where this is going. If text is important because it's simple and allows people to be creative, and easy to build is important because it allows people to try things, right? Download environments and try them. Immersive is important, I think, because it makes it easy for people to jump the programming gap. If you have to get a text editor and frickin' figure out that Word is not a text editor, creates a bunch of gibberish that you can't compile, so you have to figure out what a text editor is, et cetera, that becomes a surprisingly large barrier if you don't spend your time looking at that particular problem. The immersive environments were nice because you went in and in Lambda Mu, you edit something. You see you're creating an animal or a ball or a room or whatever, and you want it to do something. You edit a particular little, what they call a verb, which is a method, and you change what it does, and you save it, and it does that. And someone who interacts with that object that you've created in this virtual reality can actually see that take place immediately. So you break down a barrier to learning to program, which to me I think is very important. And really that's the whole last point, which is the thing that I think was attractive about it was that for me was that when I was learning to program, it was a very nice immediate environment to figure that out. I think other people see this as well. Going back to this earlier point from when I was talking about code, people are still trying to re-implement Lambda Mu. So 20 plus years after Lambda Mu was created, people are in the process of continuing to try to reinvent it in other languages. These are all GitHub projects. They've all got commits from with just recent few months. So Lampy is Lambda Mu implemented in Python. I mean, that's an obvious one. People have been trying that for a while. I thought this was very interesting. Adamu is Lambda Mu. I'm not actually trying to be disparaging either. It's like Python was a popular choice and people took swings at it. But I think this is interesting. Lambda Mu in Haskell. So someone has actually implemented a chunk of the Lambda Mu server in Haskell. Lambda Mu in Erlang. Obviously they're trying to take advantage of actors and the distributed nature of Erlang to build something that's probably Lambda Mu++, but whatever. Lambda Mu in Go. Go is a very new popular language, certainly here in New York City for sure. Lambda Mu in D. And literally many of these projects, most of them, probably 4 out of the 5, all have commits within the last 3-4 months. So people are actually trying to implement this Lambda Mu promise, this immersive, easy to build, easy to use environment, even right now, which I think is tremendously interesting. So that's basically it right there. The key to this whole thing, kind of once again a little stroll through Lambda Mu history, a little reflection on what it was involved in actually maintaining and extending it and why those extensions were necessary. But kind of the subtext of the whole talk was really 3 points that I think reflect on the community and the code and the continued involvement, which is, once again, text certainly for some groups of people is still very important. Seeing impaired, for instance, because they can do the screen read thing and actually make use of it. Easy to build is important because it means it's easy to try for people that otherwise wouldn't get in there and try it. And then the last one is immersive. It needs, I think, to be revisited because in terms of learning to program, learning to interact with complex systems, it's very, very important as well. And kind of the broad picture is as we sit in an environment where we've outsourced more and more of our data and more of our computation to third parties, from a kind of a DIY perspective, having people more involved in building these things and using them themselves, I think is actually an important direction to go overall. So that's really kind of the subtext of the whole talk about Lambda Mu and maintaining the software. I've got now time for questions, and I'm happy to talk and do demos and whatever outside of this room if people are interested in that as well. So I'll just open it up for questions first. We've got about 10 more minutes or 5 more minutes until we're booted out of the room. Go ahead.
So what does the future look like?
What does the future look like of Lambda Mu in general, or Stunt, or?
What do you want to do? See how the next?
Yep. So in terms of adoption, Stunt has a couple of issues right now. One is potentially the compatibility one. One is that my philosophy is currently still breaking things. The thing that I missed more than anything else, though, in terms of planning this, was the fact that for most people, what they want is the virtual reality, right? They're downloading it because they want that starting point. They want to be able to create rooms and places and have that navigation. I didn't build that because I assumed that was what everyone wanted to build, right? They wanted to experiment with text-based virtual realities or whatever, right? So I didn't build it. Building something like that, I think, is important so that people can jumpstart that piece and actually get to the building of the rooms versus the environment, the framework for building virtual realities in text. I've got a prototype of something called Kinetic, which is meant to be this very fast text-based environment with literally a text-based scene graph to construct the world in a way that hopefully is still accessible but potentially interesting. So there's that. I think getting away from the text-based database is kind of I think we've got better ways to store data now. It's not fast. It requires a long checkpoint for big databases, so that's problematic. I think there's some improvements to the language. I actually wrote an InMu parser for a new language that is an extension to the existing language. So I think there's some improvements there as well. Other questions in the back?
Did you have to consult with many people, or were you able to tease it out from examination of code yourself?
Yeah, so the question was, did I have to consult with many people or did I tease it out myself? I actually had started using Lambda Mu and trying to program in Mu and then doing some server things in the early 90s. So I actually had a long history with the technology. So I've almost kind of forgotten, like what it was like to start in some ways because I had been playing with it before. So when I got to doing this, it was relatively easy, I guess it felt like, to pick up and extend because I already had that long history of playing with the server code and playing with the Mu code itself. So for me, it was probably easy. I would guess you'd need some patience and tenacity if you wanted to jump in and do that. Just like any open source project, it's not super hard, but it's not super easy. It's an open book, but sometimes it's not written so well. Other questions? Go ahead.
Curious of you said of the HTTP interface. How does that work? I mean, because the old food, because of Telnet would give you that fast interaction. So with your HTTP, are you still have to wait on loads, or are you doing kind of a
Yeah. No. What's it? 2 minutes? Okay. Yeah, so maybe we'll do this question, maybe one more. Yeah, so on the HTTP side, I mean, obviously HTTP itself is less speedy than, just doing simple messages over Telnet, right? Just the size in general of the messages is going to be larger. There's a console built in, and once again, I can demonstrate some of this stuff that falls back to either a direct socket connection using Flash or something like long polling, which is a little bit simpler in terms of once you start interacting with the text-based portions of it, and then liberal use of AJAX, speeds things up as well. But yeah, it's definitely, you pay a price for that level of additional accessibility. So I think we've got time for one more.
So if you have these time move, whatever you call it, you can use it to splice, currently used code with these old codes?
Yeah, so the question was, I think, about compatibility, old code to new code. So from a compatibility perspective, Lambda obviously is very compatible with itself, and the new versions of that are very compatible. Stunt is very compatible in terms of you can take a lot of old code and it'll run just fine. In fact, almost all the old code I've ever come across will run just fine on it. So from that perspective, it's very compatible. There's a lot of example code floating around on how to do things, and a lot of that runs just like you'd expect. So anyway, I appreciate everyone coming. 10 a.m., early discussion. I love talking about this stuff, so you can grab me at any point, and I'm happy to stop and talk and do demos or whatever. So appreciate everyone coming. Thanks.
I've actually been kicking around doing the H.O.P.E to get it running on .NET. Just because I wanted a more pluggable framework, so somebody can just write a DLL and throw it in there and use the server that way.
So that's actually a good point. From there's no easy way right now with any kind of dynamic library to extend the functionality. Some of that would be easy, like that in a built-in would be relatively trivial, but more it's generally extending, not well supported, which would be the kind of thing I'd love to see for sure.
That's I'd like to have a bunch of server so that people could just bang out a little bit of C#, pop the DLL into the folder, and have the server respond to it. Load in the new, types or built-in or whatever.
Well, so that's where the age also runs into. So right now, that notion is pretty common, right? People would expect that to be straightforward. I suspect I'd have to go back and look, but the notion of dynamically loading code, I don't think is as streamlined. And so, people just didn't try to make it easy to do it, and because it's still a fairly conservative group, it never got added as well as the main server. I know there are definitely people that would love to see that.
I still right now, it's not an old core that I was working on long ago, but I had so many odd server restrictions, I don't even remember which ones.
Yeah.
I don't even think I have a copy of the code and it says server file at this point, so I'm like, I have this database file, I don't know if I'll ever be able to do any slides.
Yeah. So that is that. Let me just double check that I got all my stuff. Okay.
Get a charge in case. You never know what can happen. Oh, I see it. Extension cord. Yeah. Oh. All right, so I'm going to get started today with a malware talk. Some of you just rolled out of bed, so that's good that you made it this early in the morning. Sure, last night was pretty rough for you. So I'm talking about basically malware on the network today. Is it going to blend, and what it's actually looking like these days. So But first, I'll introduce myself. My name is Mike Sikorsky. I'm based actually here in New York City, so this is very convenient for me. I've been at Mandiant for 7 years now. First, I was a sort of jack of all trades consultant there. Moved on to be more of a focused malware analyst and reverse engineer. And built out a team there that does stuff like that. My research is primarily focused on classifying, malware as good or bad, or binaries as good as bad or bad, and then also clustering, basically taking malware and grouping it together. And I also do a lot of knowledge sharing, so I teach a lot. I taught at Black Hat the last 7 years, and going out to Vegas in the desert yet again this summer in August. And my background is right out of college, I went to work for the NSA, and then did a stint of research up at MIT Lincoln Laboratory. And for fun, I do triathlons, and that's me just getting out of the Hudson River. I'm actually jumping in the Hudson again, which I highly recommend, especially when you get kicked in the face and take a gulp of water. It's really healthy. But luckily, you get some current, so you're out of there as quick as possible. But I'll be jumping in there August 3rd. So if anybody's around at 5 in the morning, just come stop by. And I also am on quests to find the best beers in the world. So I've been to Belgium and monasteries and stuff like that. And then that's me up in Vermont not too long ago, hauling back a couple cases of Heady Topper. If anybody is a beer connoisseur, come chat with me later. Everybody loves that beer. And you can find me on Twitter. I don't tweet too much compared to a lot of people. Anyway, this is just who do I work for now? So now that there's been this sort of transition, Mandiant was kind of in the news with, all the Chinese hacking stuff, and then, Edward Snowden came out and stole our thunder, and nobody cared about us anymore. But luckily, we got acquired by FireEye not too long ago, and actually what I did was took the malware team at Mandiant and created this group called Flare, which is basically the advanced reverse engineering team is what we're calling it. And basically focused on all the reversing needs of the whole company, and then also basically just focused on knowledge sharing. What kind of things can we release? So we're going to be releasing a whole blog series on IDA Pro scripts to help you with your reversing. And we also released this challenge recently. I don't know if anybody in here has done it, but we've had over 4,000 participants actually in just 2 weeks. And it's sort of, do it as at your own pace. It's not like a traditional CTF where you got a couple hours, something like that. This is basically just if you want to grab some binary challenges and puzzles. They're not all malware focused, but they do span a wide variety of things, everything from .NET to Linux to actual malware to a whole variety of things that we cover. So if you want to take the challenge, go for it. And you can fly it at flare-on.com. I have one more last thing before we get to talk is No Starch Press is actually here. I was fortunate enough to write a book with them. They're an awesome publisher. And Bill just wrote me into, he's the owner of No Starch. He wrote me into doing an impromptu book signing right outside the room after this talk. So if you want to come hang out, talk about malware, I'll be right outside. So to talk, I'm going to start by covering, give you a quick history of malware on the network. After that, we'll open up the malware vault, show you some of the samples that I've actually seen used in the wild, and then we'll talk about how analyzing malware can help you make more efficient and better signatures to be able to find malware on the network. And we'll also talk about basically how you have to really go to this in-depth reversing level to get the best signatures possible. So, brief history of malware on the network. Back in the day when things were first established was arbitrary ports, arbitrary protocols. Malware could do really whatever it wanted to do. There maybe was a couple roadblocks with NAT or something, but it was pretty Wild West out there, and it was really easy for them to get around. But then, defenders started restricting ports that they could use. First they just were focused on inbound stuff, right? Plugging everything that could come inbound. But then later, outbound as well, they started plugging up, and then basically this pushed the attackers to just focus on ports that they're allowed to go on, such as 80 and 443, obviously. After that, defenders started restricting the protocols. So they started inspecting the protocols that were actually running over these ports and confirming that, hey, this is actually HTTP or whatever it might be. And then also requiring all their web traffic to go through proxies. So what happened then is, attackers started using SSL and started focusing on whatever it is that you allow on your network. is sort of the protocols that they move to. I'm going to get into all these things much more in depth in a second. And then finally, defenders started reversing malware and creating more signatures in the forms of snort sigs or whatever it might be, and focused on domain names, IP addresses, anything that they could block. So, what is malware looking like today? Well, it's hiding in plain sight. Okay, it's the attacker's goal is to avoid being detected, right? Because if you detect them, well, they're going to not have access to your system. They're not going to be able to steal your documents, whatever it is they're trying to take from you, money. We've seen it all. And then also, they have a risk of being detected in the future, right? If you start detecting them on your network, maybe you share signatures with somebody else, and then all of a sudden their malware is found on all the networks that they're infecting, right? So they don't want to be caught because it's going to take them down. And they use many different tactics to be able to do this. And I'm going to go through each one by one, but it's mimicking the protocols that are out there, reusing infrastructure that's already out there, and focusing on calling out from the inside the network instead of coming into the network from the outside. So attackers love protocols that you use on your network, like HTTP, HTTPS, and also DNS. It lets them blend in. Malware back in the day would use IRC and stuff like that. A lot of people started blocking that on their network because of the fact that malware was using it, right? So they're going to stay in those protocols that you allow, right? Because otherwise they're going to really stick out quickly. And then, we've obviously seen a huge push of malware using GET and POST requests because everybody allows browsers on their network and people to browse the internet, right? So it's really easy for them to hide in that kind of area. They also want to reuse existing infrastructure. This is extremely common. We do a lot of investigations for companies, and if malware just set up its own server, it would just stick out like a sore thumb, right? You just take that down, and then that sample really wouldn't be doing much. Instead, what they do is they'll take down a web server that is, a company or something like that, and infect it with the malware or whatever. And so that way, when the malware beacons out, it'll actually communicate with, real actual servers. You can imagine if there's some Google server, you allow people on your network to go to Google, but imagine if that got compromised and the malware author had control of it, you'd be able to, you wouldn't really notice because you're allowing Google, right? And this helps them basically mask the things they're doing. And due to NATs and proxies and everybody being so locked down from the outside, right? And most network security, not all, but most, are very good at not letting people in from the outside. So what do the attackers do? They're going to do client-initiated beacon, which is basically being inside your network and calling out and then establishing a connection to be able to do its bad stuff, right? So it's going to get into your network via some other means, via a spear phishing campaign or something like that, to be able to get malware running on your system. Once it's running on your system, it could then communicate out because people's security is much less focused on the things that are leaving their network than they are the things coming into their network. But this makes it very difficult for the attacker to realize basically where they're coming from, right? They might have infected just some random machine on your network and you don't know where they're coming from. Or that the attacker themselves don't know where their malware is coming from. So what they do is they start to embed things like a system survey. It says, hey, I'm on this host, so that you know, and so if you want to move laterally and go to infect servers and things like that, this is where I'm at, and that basically gives the malware author knowledge into where they are in the network. Understanding how this is working is often one of the best steps you can take in order to find malware on the network. And I'll get into that when I get into the reversing side more, but it's very, very often that you're going to have to do some reverse engineering of the malware to figure out how it's basically telling the bad guy where they are on the network. So malware often wants the ability to not let you block them so easily. And so they use things like domain generation algorithms. This is basically malware's ability to generate addresses at runtime, right? So rather than just go out to do a DNS request and get an IP address back and go to that IP address? Well, it's pretty easy. You just block either the IP that the DNS is returning, or you just block the DNS, right? So there's a variety of ways that malware has tried to overcome this. And one is you just have a lot of requests. A lot of botnets use this kind of thing. You can think of Conficker was a big one that uses this. Zeus was a big one that uses this. But basically you do have an algorithm and you do numerous requests. And it could be, the algorithm just basically generates domains that with some sequence that the malware author knows. Here's an example of, www dot and then the date today, right? So you can imagine if that beaconed out every hour like that for that domain, and it went from 11 o'clock to 12 o'clock to 1 o'clock, the attacker could predict, in 3 days, this DNS request is going to come out. That's where I'm going to set up my infrastructure. Unfortunately, as a defender, you don't really know when they're going to actually set up that infrastructure, right? Because you don't know which date they're picking, or hour they're picking for that matter. Attackers often will take a subdomain and then actually derive a fully qualified domain that actually has information in it. For example, I keep talking about this host survey that might be important, where it says, hey, I'm at this place in your network. This is an example of real malware where obviously the domain's been changed, but evil.domain.com, and what they would do is actually tack on a subdomain there, which is an encoded host name, which tells them which machine they've actually infected in the network. I've also seen malware do multiple requests to calculate an IP address. So they'll do a request for one legitimate website and another legitimate website, and get the two returned IP addresses, do a calculation on them to compute a new IP address, and that's the actual IP address that they communicate to. So you can't just and if they're going to legitimate domain names to calculate that, how could you possibly figure that out without reversing the malware and figuring out how they're combining those IP addresses to generate the one that they're going to? So obviously, all of these all these methods, I should say, are set to break blacklisting. You can't just take a bunch of domain names and say, okay, our people on our network can't go to these. We're not going to return the DNS. It's just black hole, but that's not going to work, right? All right, so samples from the vault. So I reverse a lot of malware, and so there's obviously a lot of samples we see that sort of communicate in the network in a variety of ways. So I'm going to kind of go through some of the interesting samples we've seen on the network. So, like I said, ports are very restricted, right? The web servers on your network hopefully only allow the things you want, resources you want people to access, like maybe port 443. And sometimes an attacker has a legacy piece of malware or something like that, where they, use old ports. Like maybe they want to use port 12345, and they don't want to rewrite all their malware, but they want it to still work over port 443 because that's their only way they're going to have access, right? So they compromise a web server, and the firewall is going to say it's locked down. Only 443 is allowed, but the attacker still wants access to this backdoor. So what they could do is, and what we've seen them do, is they'll still run their backdoor. It's listening on 12345, can't be accessed by anybody. But what they do is they'll install a kernel mode rootkit or basically a device driver on the system, which will actually reroute packets automatically at the network layer without anybody seeing anything at the user space level. And so what it'll do is it'll see a packet coming in for port 443, and it'll look for a signature and to know that, oh, this packet's actually not for 443. I need to rewrite the headers of the packet and send it over to 12345. So this is great for the malware author because they don't have to rewrite any of their samples. They just get this driver loaded, and then they have full access to be able to just reuse all their tools. And the really interesting part about this sample that I thought was we actually saw this on somebody's network on both their Linux servers and their Windows servers, the same exact method. So that requires a huge difference between malware, right? Because to have a rootkit that's on Linux or a rootkit on Windows is a huge difference. But the fact that they were doing the same thing means they put a lot of thought into it so that their malware would still run on both systems. And I think that's the first time I ever saw that, where it was actually the same malware on two different operating systems. And yes, there is Linux malware, and yes, there is Mac malware. Most people don't think there is. So let's think about what you allow on your network. These are all things you allow, right? You let people, web browse, right? You access webmail. You go to Gmail at work probably. I mean, I've heard of a few companies locking that down and not allowing that, but it's pretty rare. Also, you allow chat programs, right? Maybe Skype, something like that. Calendars, Outlook, all these things people use at their job, right? So is the bad guy. So here's an example of, and I have like the obligatory screenshot of Vita Pro. I have to have that in a talk to keep my street cred up. Anyway, this was a piece of malware. We were doing an investigation, and the bad guy just kept getting in via the Linux server. And we, did forensic, took a look at the server. Nothing was really, jumping out at us. They didn't really have logging turned on, and then we decided to pull apart the SSH daemon because we thought, hey, maybe there's something going on there. And we realized that, hey, there's this got any roots string in there that's being checked right before they validate the user. And basically anybody, what they did was they backdoored the SSH daemon so that way anybody who's logging in, they just provide the password got any roots. Doesn't matter what your username is, just provide that as your password and you get into the system. And so that was their backdoor, back way into the system. And nobody noticed because, hey, they allowed SSH connections in, and hey, they didn't have logging turned on, so it's not like they could search the logs and see, oh, there's people logging in with got any roots. And so it's pretty interesting how this stayed under the radar for so long. ICMP, a lot of people don't focus on or even think about this protocol too much, and sometimes it's allowed, and we've seen it used before. I don't know how many of you are familiar with ICMP, but it's mostly used for like sending error messages. Traceroute uses it to basically figure out how many hops away it is. If anybody does anybody know Next Gen Hacker 101? Yeah, that guy does. So if you go to YouTube and check out this kid, he's awesome. He just like basically takes like tools like in this case Traceroute, which on Windows it's TraceRT, so he calls it TraceRT, and basically just makes up how the tool works on the fly. And it is awesome. It is absolutely hilarious. You have to see it. So, for example, here he'll be like, "All right, this is how traceroute works." And if you know how traceroute works, it basically, you do here. The example is, trace routing to Google, and so it's 14 hops away. Basically, it's going through 14 routers to get to Google, right? But he just makes it up on the fly. He's like, "All right, trace RT to Google. This is how many users are connected to Google. 14 right now, and this is their IP addresses." And this is their connection speeds, and you can see how their connection speeds trail off sometimes or speed up depending on how close they are. And this other person, I think it's like, oh, and this one person's at AT&T, so and it's just it's really good. So if you have a chance to check it out, it's got a lot of hits on YouTube. But I love Next Gen Hacker 101. Anyway, ICMP is leveraged maliciously to be able to. Basically, there's a data field inside of it, and since nobody's looking at this protocol, we've seen attackers just basically use it to communicate. And since there's a data field, you can embed things like a reverse shell really simply, right? And you can imagine the bad guy, because bad guys who are attacking your network, they always wear masks like that. And so, yeah, they could just have a simple reverse shell that they put on your network and use via that protocol. Obviously, keep talking about how attackers were pushed to HTTP. And, so in this example, there's a GET request for badsite.com, and there's actually a GET request, and it's this long number. Once again, this long number is going to be that host survey beacon that basically tells the attacker what system's infected. And not a lot of people are doing inspection of their URIs, surprisingly. And so malware like this still works. And I'll talk more about why URI inspection is very important. Also, there's the user agent field. So in this example, request is going out, and user agents is used to basically identify your browser to a web server to basically say this is Chrome or this is Firefox or an iPhone or whatever. And what this is doing is the malware actually embedded that survey inside the user agent. Obviously, this should stick out like a sore thumb if you're doing inspection of your HTTP, But a lot of people are not. So a lot of user agent signatures are able to be written out there. Also, HTML comments, this is sort of the famous one, right? This was in the APT1 report. This is the Comment Crew Web C2. There's like 50 different names for this group, but this is sort of like the original thing that they used. And they would have base64 encoded HTML comments on their page. And when the first time I ever saw this was many years ago, and I was at a client. This is when we used to go on site to reverse engineer malware, because I don't know why we thought we can only do it on site. So I forget where we were, but anyway, you know, nothing was showing up in the logs, but we had the malware. And then I saw the malware was connecting to like this dog kennel company in like Nebraska or somewhere, and I'm like, why would malware be connecting to a dog kennel company? And this is before all this information came out, and so I realized that they were pulling down HTML comments. So what actually ended up happening was the attacker compromised this dog kennel, thus reusing infrastructure, which I was talking about earlier, to be able to serve up web pages that they've modified. In this case, an HTML page you see there, that's not what shows up in your browser, but that's actually what it looks like over the wire. And anything that starts with that sort of exclamation point at the beginning, as you see on the bottom, that's not going to show up inside your browser. And so it's an easy way for them to hide. So this was really popular for a while until people started realizing it was going on. MSN Messenger, so you obviously allow chat on your network. Well, not obviously, but a lot of you do. And MSN Messenger is actually one of my favorite pieces of malware just for how simple it was and for how cool it was. Basically, this network their security of the company was pretty strong, but they did allow MSN Messenger on their network. And I don't know why anybody would do that, but and what this malware did was it pretended to be just an MSN Messenger client. And so the cool thing about it was it communicated with genuine Microsoft servers. So there's no way from a network standpoint for you to notice the difference, right? From a user who's just accessing the MSN Messenger infrastructure or somebody else. And the malware had accounts and passwords. And I guess I should say MSN Messenger is very much like Skype. And so, and this protocol is actually not proprietary. So there's a lot of APIs out there to be able to write software that communicates with these servers, and a lot of open source projects you could copy. And the cool thing about this malware is it would log in and it would go to a chat room. And the chat room there was actually the bad guy. And so the attacker would actually, if you could imagine, you're in a chat room, you have all your friends in your chat room, you hang out and talk. Those aren't your friends, they're actually all compromised machines. And so you could just talk to each individual friend, but you're actually talking to a compromised machine. And so you have your whole chat list, and you're just communicating to each one by one and saying, oh, get this file off this system. Oh, upload this piece of malware. Oh, move laterally in this way. Do this command. And you're just and so the attacker's just sitting back and just having basically just hanging out in a chat room. But actually what they're doing is they're doing all the bad stuff they want to do and grab all the files off your systems. So do you allow chat? Do you allow Skype, Yahoo Messenger, Jabber? I've seen them all. So it's not just MSN Messenger. It's every single one of these. There's APIs out there to be able to use them, or somebody reverse engineered the protocol, and that's available to them. So just know that they're snooping around. They're going out via chat. Also, webmail, Gmail, Yahoo, whatever it is that you use, we've seen them use that as well. This is, malware will actually log in to Gmail and check if there's any messages. If there's any messages telling it what to do. Hey, go, excuse me, go compromise this server, or go, DOS this website, whatever it needs to do. That's just send email. So the bad guy's just sitting back and just having email conversations, similar to the chat. Also, we've seen for large uploads them use Google Drive or Dropbox as well. And also we've seen calendar malware as well. So Google Calendar is one that I've seen recently. where they use the client login authentication API from Google to be able to basically write their malware and interact with the Google Calendar. And what it does is you normally just check your calendar, see what you got going on today. The malware does the same thing. So they just check their calendar, say, what do I have to do today? What are my tasks? Oh, at 11 o'clock, I'm supposed to DOS this website, and at noon, I'm supposed to do this. And it's basically, they just set up the calendar, and that's how they go. They roll that way. So, and I know a lot of people access those web calendars, and so from a network signature perspective, what do you do? Also, there's this concept of translating for proxying. So let's say you allow google.com on your network. You allow your users to go to that website. But you blacklist Dyn DNS because malware often uses that. So you want to not allow people to go to those websites. Well, you probably allow translate.google.com or babelfish.yahoo.com or microsofttranslator.com. You allow all these websites to go. So what you could do is you could say, hey, Google, translate that Dyn DNS website for me. So I can see what content's on there because I can't get to it myself. And so what happens is translate.google.com goes to that website, which doesn't actually need to be translated, and does the web request on your behalf. And so this is a neat way that I first saw malware to basically get around the blacklisting that was happening on the network. So first they'll try and go to the Dyn DNS. Doesn't work? Okay, well, I'll let Google Translate do it for me. And this goes back to what I was saying earlier, which is you got to inspect the full URL for your DNS names. Okay, you can't just look at the DNS name itself because in this case, in this first example, you would just look for translate.google.com and be like, oh, that domain's allowed. What you need to do is actually look at the entire URL and say, oh, is the Dyn DNS or whatever it is you're trying to block, your entire blacklist for that matter, is inside that URL because so you got to start looking at a deeper level, not just blacklisting DNS names. And we already covered a whole amount of information as to why just blacklisting DNS doesn't work. So check out the whole thing, and maybe you'll find some URLs in there, malware trying to go to these translation sites. You hit the forums. A lot of attackers want to be infiltrating companies that have a lot of IP, especially software IP, right? They want to be able to get stuff like that. And you developers hit the forums, you hit the forums. It's all allowed on your network. And so we've seen malware that hits up Microsoft forums. In this case, they go to Tim's site here, and Tim's obviously not a real developer, but he does have sort of this gibberish on the bottom. And what that is actually just encoded data. And what that data actually is, once you decode it, is it just says, hey, malware, go to sleep for a couple days and come back, and maybe I'll have posted something to the forum by then for you on what you should do next. And so malware just can hit up the forums and basically get data that way as well. And everybody allows that outside their network, right? You allow people to go to forums and stuff like that. Now there's malware that tweets. So it wants to interact. What it could do is just follow someone. And that's not actually someone, it's the bad guy posting commands. This is a very obvious example for this illustration purposes, but this is real. And, obviously, Twitter's trying their best to prevent people from doing this, like, DOS this IP address 50,000 times or whatever, or, well, a lot more than 50,000 because they're multiplying by that number beforehand. But, that kind of stuff, Twitter can try and help block, but there's ways for them to encode that. They could say, hi, Mom, how's it going, or something, and that actually means you should do that, right? So there's ways for them to encode that in a variety of ways. And so, but basically, there's a lot of APIs out there. It's really easy for malware authors to write software that connects to Twitter. They could follow people. They could tweet themselves, say, oh, hey, I'm here. And that's actually them tweeting, so the bad guy is following them, and there's some user account that they're embedded with, right? And so there's been some malware out there that just follows, just one person. All the malware follows the same person, and they're able to basically set up a botnet really easily and get their commands via that way. The Outlook Assistant malware. So a lot of people use Outlook at work. And the bad guy knows this. And so they want to be able to, basically send email from your account without you knowing. And so the way Outlook works is it actually creates this MAPI session on your Windows machine, which is basically sort of like a messaging interface. And what the malware will do is it'll actually create a shared MAPI session, which basically says, oh, if anybody's authenticated via Outlook, to Exchange server or something like that, then I just want to share that session with them. What that enables them to do, it gets them notifications when messages come in, when messages go out. They could even set rules in your Outlook box with this to basically, log things as deleted before you get the chance to read them. And also they could check for things like, in this example, this piece of malware, it actually checked for any JPEG attachments. And if they had a special character inside the name of the file, it would automatically download that file and run it on the system after decoding, because they tried to make it look as much like a real legitimate image as possible, but it wasn't actually a legitimate image. It was really more malware to run on the system. And all email will actually originate and look like it's coming from your account because they're using the shared session and it shares it with your account. So it basically provides an awesome mask for them, right? Because there's almost nobody that checks outbound email, especially if it's really subtle and it just looks like messages. And what this malware did, they even took it a step further to blend in. Instead of like sending very obvious header, subject lines and stuff like, this is malware or something, they would check your past subjects and, tack forward : right? Because your forward email, they do that, or tack RE, regarding this or whatever, and then copy that out of some old message you had, and then also copy some contents out of the old messages you had. So it actually looks just like a message you've already sent. However, they're sending it to their own, email address that they already have control of. And oh, by the way, they were embedded with many different email addresses that looked very similar to, people that you would be emailing, whether it be Gmail people or just people at other companies. So they even had accounts compromised at other companies, and so it would look like you're just sending an email to somebody you send it to all the time. Problem is, they have this Outlook assistant also running on their machine too, and so they can kind of work their way around sending messages without getting caught. So what can you do? There's some tools out there. I'm going to talk about, there's basically two things you can do. One is, you could try and do this sort of low-level triage of malware to be able to find out as much information you can about it. And then there's the more in-depth reversing, right? And being able to basically, look at the malware at an even more in-depth level. But first I'm going to cover the dynamic tools that are out there, publicly available, that you can use. The first is FakeNet. This tool is really, the point of it was to make it as easy to run as possible. So you just double click it on your Windows system is the easiest way to run it. And basically it sets up a fake network, right? So you want to trick malware into thinking it's connected to the internet when it's actually not, right? That's how you analyze malware. So what this does is it allows you to trick the malware and keep it running as much as possible. So if malware implements a lot of tricks to be able to say, oh, I don't have an IP address, oh, I don't have an actual network connection, I should just go to sleep and not do anything. But if you're analyzing malware, you want it to execute and do as much bad stuff as possible so that you can see what it does. So that's sort of why FakeNet was built. And so it uses a variety of protocol, the most common protocols like DNS, HTTP, SSL, and it could actually be used just as a web server. So if you just need a web server set up and need files serving up, you could just use this to do that kind of thing. I've used that before. But really what you're using it for is to try and tease out as much information from the malware as possible. The way it works is it's a layered service provider, which basically enables you to hook all of the Windows WinSock functions, basically all the networking functions on a Windows machine. So that way you can figure out what the malware is connecting to and things of that nature. We also have a DNS module that allows you to have the DNS resolved to whatever IP address you want. Most people choose to use localhost because that's where FakeNet's running and it's emulating all these services, right? And then there's also the concept of NX domain, which is basically non-existent domain. A lot of times when you're analyzing malware, you want to tease out as many domains as possible, right? It's possible the malware has, it's not embedded with just one domain. And most tools, if you use them, it's just going to go to one domain, do its bad stuff, and that's it, because it got the connection to that domain, right? It got the IP address back. But what you could do is use this NX domain feature to be able to have it basically return, oh no, that domain doesn't exist, sorry. And then hopefully the malware will go through and cycle through all of its different domain names. Also made this basically extensible, so with plugins, so you could write Python to be able to add to it. And there's an example SMTP plugin for it as well. And the great thing about FakeNet is it works like not just if DNS is going on. A lot of other tools, it only works for DNS. This doesn't matter because it's running on the host and it has sort of this layered service provider concept going on. It's able to work no matter what port the malware connects to. If the malware connects directly to an IP address, if the malware goes to a domain, all of that will be caught and automatically captured. And so that's FakeNet. Oh, and also it also does PCAP automatically. So it'll automatically take all the packets from the malware, put it into a PCAP, so that you can analyze that, offline. So you don't have to have Wireshark up and be capturing in that way or anything like that. FakeNet configuration is really simple. It's just a text file, and you can modify things like what ports different things are listening on. Obviously, by default, we're listening on every port, but you could say, I want this protocol listening on this port. And so by default, we are listening for HTTP on port 80 and 443. We're listening for SSL. And all of the encrypted traffic like SSL, what we do in FakeNet is we actually automatically decrypt it for you. So you don't have to worry about dealing with SSL and, if you're just analyzing malware and using Wireshark, it's all going to show up as SSL. What we do is we actually decrypt it all for you, and so the PCAP is completely decrypted. Also, everything that's displayed to the user is decrypted as well. So its usage is pretty easy. You just run it, and it starts logging stuff to the screen. And so this is an example where, evilmalware.com is the DNS request, and then it does a GET request for this executable. We try and serve up as much as we can. So if the malware requests, sometimes malware will try and download an image from a legitimate website first to check its connection. Say, oh, can I access this legitimate website? Okay, well, can I also download an image? And is that image have a valid header? Something like that. So we try and serve up as much as we can. So we'll serve up images, we'll serve up web pages, whatever it is that needs to be done. And then we'll also serve up even executables. So in this case, it's malware is requesting an executable. We'll give it an executable. What that executable is it's just what we call the fake mini program. It just does a pop-up on your screen. As soon as you see the screen, you go, oh, the malware must have downloaded an executable and ran it, right? Because that's the only way this pop-up would have showed up. So anyway, you can download that tool, and FakeNet 2 is coming out this fall, which will have more support for the more modern Windows operating systems, and a bunch of cool features as well. iNetSim is another tool you could use. This is free Linux-based VM that you could download. It's a little bit more robust as FakeNet, but it's a lot more heavy and more difficult to manage because you basically need another machine. So if you're doing all your malware analysis on a Windows machine and you want to use iNetSim, you're also going to need a Linux machine as well. So you need two machines to be able to get your job done. But it emulates more services than FakeNet, and it has a lot of dummy services, and it also does that sort of serving up what it can, right? So you keep the malware running. And you can download it from there. But this is sort of what the iNetSim configuration has to look like when you're setting it up. So you have to have your Windows virtual machine, your Linux virtual machine, and set up routing properly and things like that so that it all works. Especially if the malware is connecting directly to an IP address and not doing DNS. It sometimes is a little bit of a struggle with iNetSim. So digging deeper. This is the concept of, you could use those tools. You're going to tease out some network signatures, but you can imagine if a sample of malware just it starts off and it goes to sleep for 2 days. Well, you're not going to sit there waiting for 2 days for FakeNet or iNetSim to catch what's going on. You're going to have to do a more in-depth analysis, and that's where the full reversing comes in. Okay, and there's And when you're doing full reversing, there's places you could focus your analysis, right? Sending and receiving data obviously is a good point if you're looking for network stuff, right? Because that's what the malware is doing when it's communicating on the network. It's either sending or receiving data. Also, this concept that I keep bringing up, which the system survey or beacon has to happen, right? Because there's a malware is using this client side, right? So inside your network, beaconing out, and it's got to tell the attacker where it is and things like that. And so that concept means that, hey, maybe the send data with that first beacon is the place I should look at. And that's where my most effective network signatures could come from. Also, it's probably the easiest place to start looking. So we want to find network code, right? So what are some functions that are used by malware on Windows systems to be able to communicate? Well, there's the WinSock. This is sort of like, you know, your Unix programming days, but on Windows. So send, receive, connect. You basically have to manage your own connection. So if you're using this functionality and you want to do things like HTTP or something like that, you're going to have to manage that whole connection yourself when you use this API. And get host by name, that does DNS. But, you know, malware authors don't always want to write all that code to manage all of their connections for HTTP, for example. So there's higher level APIs. This is in the form of WinINet. And this basically gives them a little more flexibility so you don't have to operate at that low level. And, you know, so it built into this is things like HTTP and FTP. And so they don't have to worry about those protocols. It's all managed by the code itself. And this is basically used for, you know, going to websites and downloading files and things of that nature. Also, COM is commonly used by malware. COM is basically a way for programs to share interfaces with each other. And so most common one that malware uses for COM is Internet Explorer. So this is basically enables malware to basically browse using Internet Explorer. And so if you allow, and let's say you have a host-based firewall or something like that, that is not going to allow the malware to go out, but it'll actually allow Internet Explorer to go out, something like that. This is how the malware will automatically run Internet Explorer. And sometimes it's a little difficult to analyze because you have to figure out how the interface works, what interface it's using, and so COM is a little tricky when you're analyzing it. So, what places can you focus that are going to help you when you're reversing to write an effective network signature? You know, if you just look at the network traffic, it's just going to look like random data a lot of the time, but it's not actually random data. Okay, so just staying and looking at packets only it's not going to work. You're not going to write effective network signatures. So what you're going to want to do is you're going to want to see, you know, where's the sources of data coming from. Maybe the data that they're sending over the wires coming from a keylogger or something like that, and that's something you could build into your signature. Like I said, the beacon is very common. A lot of times the host name or something like that is embedded in what's being sent out. And so you want to focus on the hard-coded data, right? Because the things that are consistently across runs, not the things that are dynamic. You don't want to signature off of a host name because the host name is going to be unique to the machine that's compromised. You want a signature off of something that's hard-coded within the malware that's going to make sense. And so there's this concept of the hard-coded data versus the ephemeral data. Basically, malware is, you know, if they use those lower-level APIs, then it's going to require them to do more manual work, which means there's more opportunity for them to make mistakes, right? So you can imagine if the malware author is writing software and they're going to use the low-level API, there's more mistakes they can make than if they use the higher-level API, right? Because they have to manage the connection. They probably have to hard code a lot of things. And this enables them to make mistakes, and they do very often, and you could signature off of those mistakes. So the most common example of this is in the user agent. There's a common set of user agents that are allowed out there, or that exist out there, right? It's like, you know, it's Mozilla, it's Internet Explorer, it's Chrome, whatever it might be. And obviously that changes all the time, but there's sort of a common set that you can look at. And so sometimes malware embeds their own user agent to try and look like a normal browser. But they might fat finger the name. For example, you see here Mozilla, they typed a capital Z, and then boom, you have a network signature just off that capital Z, and you just block all requests that are using this capital Z, and then you've effectively blocked that entire malware until, you know, they recompile and reinfect you and come back. But at least in the meantime, you could signature off something like that. That's a very simple example, but things like this happen very often in malware. Also, one thing worth mentioning is that encoding encryption can make this whole thing very tough because, right, what actually is going out over the wire is different than what it is that they're packaging up before they put it on the wire, right? Because it gets, let's say, encoded in the meantime. But that doesn't mean you still can't signature off it just because it's encoded. And I'll show you an example of that in a second. So when you're writing a network signature, what do you want to do? First step, you want to write a signature that works. Then you want to limit the false positives. And then you want to make sure it's got actually good performance so it's not bogging down your network sensor or anything like that. Also, you want to pay attention to the attacker's perspective. So if they want to try to blend in, I've already talked about that. And so it's a lot of work for them to update their code, right? They're software developers like anybody else, and they don't want to have to like recompile and redistribute, and it's just like such a hassle, right? So, you know, you got to remember that they have concerns as well as far as their development cycles and things like that, just like any other software developer. And so you're going to want to focus on things that are going to take the attacker a lot of effort to change in their code, right? Because they're not going to want to make those changes. So what can you focus on? You can focus on elements that are on both sides. So maybe focus on a signature that's going to require them to change code in both the client side and the server side. Do you know how much work that is for an attacker? For them to change their server side and their client side? Because if they change their server side, they have to change every client they have out there. It's too much work. They're not going to do it. And then after that, you could reverse more than others, which means what I'm saying here is you want to spend as much time as you can making the most effective signature, because the more in-depth analysis you do, the more effective the signature is going to be and the longer it's going to last, and the more it's going to be related to this concept of making the attacker do a lot of work to overcome what you're doing. So a simple network signature might be a 1 second change for them, but a really in-depth one might require them to take down their entire infrastructure, right? So, and they're not going to do that. So, a real quick example. I'm already starting to run out of time, I think. Is of how reversing helps. Okay, I want to just show an example of this, just to kind of drive home the point. And the concept here is, if you just looked at this traffic, and this is just one TCP stream from this malware. There was obviously many, if you had all the different malware variants and saw everything that was actually going on, there was a variety of things. And you're like, well, what can I signature off of? Can I signature off of, in this case, servebeer.com? Can I signature off that? Well, no, because there were many malware or variants of this malware out there that used a variety of domains, right? Can you, maybe signature off of the CSS? And well, that was changing across malware variants. And then there's this encoded data, right? It looks like encoded data. It's just a lot of percents and numbers. And you're like, oh, well, maybe that translates to actual letters and numbers and stuff. And it's like, well, no, that actually doesn't happen because it is, in fact, encoded. So what can you signature off of? If you actually reverse engineer, you can figure out what are some of these numbers and what are some of these encodings that's going on. And you'll actually see the 54 and the 55 there that I've kind of covered in boxes. And then this sort of key, which I didn't know was a key when I was just looking at the traffic. It just looked like another number, that it was kind of towards the ending, right before the FI that you see there after the 7C. And what that turns out to actually be is that 7C is just the XOR key that will be used across the whole rest of the sample. And so 54 XORed with 7C corresponds to open parenthesis, and 55 XORed with 7C actually corresponds to closing parenthesis. So it looks like we have open parenthesis and closed parenthesis in there. But if they use the key other than 7C, which all the malware variants did, that's going to change every time. So you're going to actually have to have logic in your signature to say, okay, let's see if there's, right before the FI, if there's a key that I can XOR, and then see if there's this open and closed parenthesis. Also, Between the parentheses is an encoded host name, which is going to vary in size, right? If the host name could be just a couple characters, or it could be much longer. And so there's no way to signature off of that length. So if you thought you were going to just look at the network traffic and a bunch of streams and say, oh, I'm going to be able to find this, it's not going to happen. You're going to have to reverse engineer it and figure out that there was actually this key concept going on to be able to write the most effective signature possible. So, conclusion. The malware is getting out, right? Monitoring by itself is not going to cut it. And no matter how small a funnel you put, right, you still got to let your users do work, right? They got to use their web browsers, they got to use chat, whatever they need to do to get their jobs done. So the attackers are just going to use that as their means to communicate. And you're going to have to reverse engineer to get the most effective signatures possible. And you're going to have to move to the host. So don't just look at the network, look at the host as well for the malware. But guess what? They're also blending on the host as well, just like they are on the network. And they're doing that in the form of rootkits, backdoors, all things like that. But that's another talk in itself. So anyway, that's talk. And so I could take some questions now. Yes?
Yeah, how can one, when it's doing, for instance, amateurs, that kind of thing, to keep from being mistaken for malware? What you're doing is maybe innocent and maybe only partially competent if you learn, but in the meantime, it doesn't look like standard traffic. You see what I mean?
I'm not sure I understand your question. You're saying?
Like, say I want to set up a search engine of my own to look for things I want to see, rather than what commercial entities want me to see. So I set up a slider. I set up a bot to go search the web and gather entries. And it might not be really competent. It might look strange. And yet I don't want to be mistaken for malware. I have no malicious intent.
Right.
How do I keep my door from being broken down?
Well, that's the thing is just it's this constant battle, right? Where you're trying to stop your network, for example, getting infected with malware, but at the same time, you want to still allow the good things to actually occur. So I don't know that I could answer that question with a short response, but other than it's complicated because that's not an easy thing to do. So anyway, yeah. Next one.
Okay, so the examples you gave show signatures in network data. But a new virus comes around, a new botnet, it'll have different signatures. You have to go and figure it out again. What work is being done to look at behavioral stuff? Because the wrong behavior is much more easily detected than a signature you haven't calculated yet.
Yeah, so exactly. That's what I was saying, like running on the host and getting on the host is an important part of your protecting your network, right? And so if you're able to be on the host and actually have something host-based, you could recognize when things are out of ordinary or something's running in a way it shouldn't be. And so, yeah, focusing your efforts there, which a lot of people are. And so it's kind of twofold, right? You want to be able to secure your network as best you can because, hey, you might not be able to focus on every single host on your network because, Jim might have wiped his laptop and still connects out via the network. So, yeah, people are doing that, absolutely, looking for behavior-based stuff. And there's a lot of behavior signatures you can imagine. Like I showed the HTML comment concept. You can write a signature just for generic HTML comments, right? And be able to find that generically. So the goal is you want to try and make your signatures as least specific as possible so that they encompass basically maybe an entire concept of attack, right? And the same goes for being on the host. There's only a limited number of persistence mechanisms malware can use or that we know about. And hey, can you look for all those persistence mechanisms? And hey, it's a very large effort for a malware author to come up with a new persistence mechanism. So there's this concept of, hey, can you make your signatures get as close to the attacker as possible? And I mean, by close to them as possible, I mean actually them. So like recognize that this piece of software is written by this person or that kind of concept. So as long as you move as close to that as possible, because obviously that's not a possible thing to do, but get there as close as you can will make the most effective signatures. Yes?
Do you see malware that like uninstalls security patches and installs firewalls and doesn't keep things?
No, that uninstalls what?
Security patches or drops firewall rules and doesn't keep them?
We've seen that before where they have the capability to log into firewalls and then, modify your rules and mess with you that way. Absolutely. That's more, I don't think I've ever seen malware do that. It's more like the attacker doing that.
Okay.
Yeah.
So a lot of what you talked about was evading blacklists. Tunneling through ICMP also has the potential to evade whitelists. Have you seen people doing other stuff like that in terms of structured DNS queries or I don't know what else, and that's what I'm asking?
Yes. Like embedding sort of covert communications over other protocols. Is that what you're getting at?
Right.
Yeah, I mean, you could think of like with the DNS requests for, you could embed stuff in the DNS request, right? Same concept as the ICMP, absolutely. And that's going on there. The thing is that's pretty easy to detect, right? If you start doing inspection of the DNS or inspection of ICMP or whatever it is that you're allowing on your network, hopefully you can see that. Yes. Or wait, you already got one. I'll go over here. Yeah.
When you are reversing things, you mentioned looking at particular commands. Do you typically work backwards on those when you're trying to come up with these things, or do you just actually work application notes?
Yeah, so what I was getting at in the talk is, like, those are good starting points. So you go straight there, because you know that's where the malware is actually going to, that's a function, the API functions the malware uses to communicate out. So why not focus there first, see if there's any low-hanging fruit for your analysis. It's basically a place you could target really quickly. And then after that, you kind of have to work your way backwards, because maybe malware is doing, something weird to be able to, circumvent your analysis from being that easy. Yes. I think I got to go down. So one last question.
What about like automated analysis of like domain names that might be used to traffic? Because they look really obvious, but it's not normal renaming to the eye. Do you automate that?
Oh yeah, absolutely. There's a lot of people doing using machine learning and things like that to look for anomalies in DNS names and stuff like that. So that crazy long DNS name that I showed you, yeah, that should stick out like a sore thumb, because that's not something normal that somebody would be going to. So yeah, there's a lot of work being done out there from that perspective as well. So anyway, that's all I got. I'll be outside doing sort of this impromptu no starch press thing. So come say hi and talk about malware. And thanks for your time. Oh, nice. Good luck. My pocket is empty. You feel it, like you're like in your life.
Getting something like just can't figure it out.
Yeah. It's like every 10 seconds I'm always like. I love the show.
Thank you.
Mike Tyson's Punch Out.
Yes, nobody appreciates the class.
007-373-5966.
Yeah.
Am I close? I'm close.
Close.
That's the code. Somebody in here definitely knows it. Good luck, Nick.
Yeah, is that all right? That's fine. Just making sure. Right, just plug this in the headphone jack. All right. Matter of fact, let me get set up first so that I don't like. Yeah, no problem. All right, cool. There and go. Thank you very much. Okay, I haven't plugged in yet. Trying to
They just set it up that way.
I guess they're still working on the video. Yeah. Is that another cable? Oh, there's a VGA. I don't know what one. Oh, I'm looking down here for it. No, trust me. Sorry about that. Boom. Thank you. You're welcome. Okay, ready to go. Okay, my name's H.O.P.E. I work for IBM X-Force Advanced Research. I'm just going to apologize in advance. I'm not going to have as polished a briefing as the last guy, but I'll do my best. So here's what I'm going to talk about today. I'm going to give an introduction on boot kits, talk about walk through the boot process of various operating systems. I'm sticking mostly to x86 architecture, x64. We're going to take a deep look at the technologies involved in booting and give some advice for how to prevent exploitation. Take a look at some case studies that that are real-world examples of lower than OS exploitation. So here I just wanted to set out the scope. For this presentation, we're talking about bootkit is anything that exists below ring 0, below the level of the OS kernel. This talk's going to cover those infections that are persistent. They maintain presence on the hardware after reboot. I'm not really going to talk about stuff like bootable CD-ROMs that are auto-pwn. Like I said, we're sticking to x86, x64 architectures. I'm not really covering virtualization in depth. Not every system uses it, but and it's definitely an important area of infection and persistence. It was just beyond the scope of what I was doing my research on. I'm releasing a white paper eventually. It's probably about halfway finished, but I'll try and distribute that out to H.O.P.E. If you grab my Twitter from the first slide, if we can publish the slides on the website for H.O.P.E., feel free to add me, and I'll post the white paper there when it's finished. So, before I get into the boot process, I just want to talk about a little bit about bootkits. They've been around a long time. Stone virus hit in 1987, and that was an overwrite to master boot record. UEFI got popular 2013 with the Dreamboot exploit. So the danger of bootkits is that they sit below the OS. So many times you cannot detect them from the OS. They're persistent, so you can reinstall the operating system and still have an infected machine. You can, in some cases, you can even reflash firmware and still have an infected machine. So I think this is an important area of research, and trying to prevent and detect what we can of these becomes very important. So here, this slide, I'm talking about the basic boot process for old Windows machines on power on self-test. Yikes! Power on self-test. Hardware gets initialized. Drivers get loaded. RAM gets checked out on post. From there, the BIOS gets read in off of a ROM chip, and searches the devices for the master boot record, which has a boot sector on the beginning of the physical media being used for boot. From there, it looks for volume boot records, VBR, and from there it selects a partition to boot. Once it's found a partition it wants to boot, uses NT loader, which uses boot.ini for specific boot options. It runs NT detect to gather information about the computer's hardware, and then passes all of that information to the NT kernel, and starts loading the OS. Here we've got boot processes for later architectures, starting with WinVista. Instead of just loading the NT kernel straight out, as it did in XP architecture, It calls the Windows Boot Manager. And the Windows Boot Manager loads boot configuration data from the BCD file, and it passes that data to the WinLoader, winloader.exe, and then loads the operating system kernel environment. So starting with Windows Vista Service Pack 1, Windows began to add support for UEFI. Now UEFI is a technology that a consortium came up with specification for. They're currently on version 2.3.4 or 2.3.1. And basically, UEFI is a much stronger version of the BIOS. It can be split between firmware and other storage devices, but it's basically a mini operating system, and much more powerful than the old BIOS technology. And because of that power, is that much more exploitable and dangerous if it gets exploited. So from here, we've got UEFI loading either a master boot record or a new GUID partition table, which is a new way to store partitions for hardware storage devices that are over 2 terabytes. Again, from there goes Windows Boot Manager, boot configuration data, and then the Windows Loader. Windows 8 came shipped with Secure Boot. Secure Boot is a technology that checks the signatures of every piece of software involved in the boot process. So if something doesn't match up, it just won't let it run. It's kind of like a bouncer at the entry to a club or something. It checks signatures. If they don't match the master keys stored in UEFI, then that particular phase in the boot process doesn't get to run, and it has to go back to setup mode. Mac's been using kind of an older version called EFI boot. They've been using that for a while. I think it's still based off of the EFI 1.2 implementation before EFI became UEFI. Again, the boot ROM has 2 major functions, or 2 major services. One is power on self-test, which does the RAM checking and some initial hardware checking. And then EFI, which does the more standard hardware initialization, selects the OS, and then loads the bootloader, boot.efi Mac bootloader. Here's how it works for Linux. When Linux uses BIOS, goes through post BIOS. Linux has capabilities for master boot record or GUID partition table. And then it'll call either Lilo, Grub, whatever Linux bootloader you've installed, and there it'll load the Linux kernel. Linux also has support for UEFI. Linux also has support for secure boot process. There was a lot of controversy when Windows 8 machines came out. They had all secure boot enabled by default, and the keys that were being checked for were always Microsoft signed keys. So Microsoft released some keys for open source developers to use. There was a bit of an outcry. Initially, people thought that Microsoft was attempting to limit certain hardware architectures to only being able to boot Windows. I think some people are still leery of the keys that were distributed. Again, the boot manager, the bootloader, and the Linux, even the kernel, all have to be signed with valid keys. So if something's been tampered with, its signature is not going to match. UEFI secure boot says no good, goes back to setup mode, or possibly bricks your system. So here, let's talk about BIOS. It's basically a bunch of compressed modules. Each module is signed with a checksum, but there are a couple modules that are not compressed. First is the boot block that handles post, and then the second one is the decompression routine for the LZH compression, compressed modules. And if you modify a module without updating its checksum, again, you've kind of bricked your system. So some examples of persistent BIOS infection were presented by Core at CanSec West in '09. Again, they used that should say building BIOS building tools such as the Pink-Zacco's method. That's basically just a method for updating checksums and making sure they get stored. Then go ahead and run the patch and update the checksums. Dump the BIOS with flash ROM, patch and update, reflash. Here we have 4 ways to avoid this type of attack. So you're going to see the first bullet quite often throughout this paper. And you can pretty much assume that this is a basic way to avoid most infections. A lot of these things need multiple stage infections. So they initially get on with some exploit. They then escalate privileges and then use those escalated privileges to install at the very low level. So if you can protect yourself with antivirus, firewalls, intrusion prevention systems, host-based intrusion prevention systems, and good security policies, which you can't always predict your users. They're usually going to find the way to do the worst thing possible, but if these things are in place, a lot of times you can prevent some of these attacks. A lot of these attacks that I'm covering, I mean, you'll notice the last one, first case study was from 2009. So some of them are pretty well known, and some of the mechanisms have already been patched that they're using to get down, not only to gain persistence for the boot kit, but also to gain initial staging for escalating the privileges. So the smaller you make your target profile, the better luck you'll have mitigating some of these risks. You can also enable write protection on flash. Digitally signed BIOS firmware has been out a long time. And number 4 goes back to policy. Don't download BIOS updates from untrusted sources. Again, if it's malware that's going after the BIOS anyway and bundled, it may not even be a firmware flash that you're doing, and rather something that gets run automatedly. So I guess just be careful. So here we are back to UEFI. Again, it allows pre-OS networking. It's not the only technology I'm going to cover on here that does. So there have been a couple versions, such as I believe Phoenix's implementation that provides antivirus for the host operating system. Allows you to run that before the kernel's been loaded. If you can see the second bullet down there under the 2 types of services, it actually has a significant amount of functionality while the OS is still running. So there, it definitely has a staging footprint that you can still access while the OS is running, and it also has a extremely extensive boot services that it opens up, much more so than traditional BIOS. Now, the biggest example I could think of for an attack on this was Dream Boot. Again, it finds the bootloader, patches it, takes the kernel entry point at the end of the boot process, redirects the control flow so that it can do what it needs to do. As you can see, the deactivates kernel protections like patch guard, and it hides in a relocation table. So again, back to countermeasures. Secure boot will help with this one. Intel has a trusted execution technology, provides late launch. It basically refuses to load software that it does not, I'll cover more later, but it refuses to load software that does not match its metrics. Its stored metrics for the footprint of the software. BitLocker in TPM mode helps out a lot. So TPM mode allows different types of encryption. One of them is sealing. So if, again, TPM also uses software metrics, and if the software metrics don't match up to what it expects, it will not allow the unsealing of the keys, the encryption keys that are being used to encrypt the system. And as we talked about before, here's Secure Boot. Secure Boot has been bypassed. Here we have a good example of this. Was a talk given at Hack in the Box Amsterdam 2014 by the MITRE research team headed by Corey Kallenberg. What they found was that there was a way to bypass the signature checking that Secure Boot offers. Certain OEM vendors didn't want such things as graphics card drivers, which have, or graphics cards with option ROMs that can be updated, didn't want those option ROM updates to be in a state that could possibly keep the system from booting. So they programmed in a way to avoid the signature check. So the MITRE researchers found a way to manually set the flag that describes how lax your policy is. So they found out that the system variables were not being protected. So they were able to say, oh yeah, don't run signature checking on any of the software, which completely trumps Secure Boot's entire purpose for being. So yeah, so the first bullet on here is make sure the UEFI version follows the spec. So the reason that lax policy was implemented was one vendor's, and I believe it was American Microtrends, implementation of UEFI didn't really match up with the spec. The spec doesn't say anything about being able to skip signature checks. But American Megatrends wasn't the only one that used what they started. A bunch of other OEM vendors began to use the same thing. So it was kind of a problem of lax implementation that spread. So there are some technologies such as BIOS control and BIOS write enable protection that you can turn on. You can also do the set Intel protected range SPI flash protections, like setting the flash configuration lockdown bit. setting SMM BIOS write protection. These are all things you can do in UEFI or the BIOS options that you can set as long as you've got, I guess, the latest up-to-date BIOS or UEFI. You got to go into boot options, of course, to do it. And back to the original, common security mechanisms measures will help quite a bit. So here we have Mac EFI used on all Intel Macs. So you find a way into Mac EFI, you've got basically a golden ticket. Some of the other technologies are a lot more hardware specific, BIOS in particular. UEFI is quite hardware and vendor specific. But Mac EFI, you own it once, you own all Macs. And here, it was briefed at Black Hat by Snare in 2012. He ranks 3 different options for gaining persistence, patching and replacing the bootloader, which he ranked pretty low, writing to PCI device expansion ROM, which is similar to what we were talking about with the option ROMs with the graphics card on the early example that would defeat secure boot. And then the last one was flashing the firmware. And he was saying that newer Macs write protect the flash, which makes that very difficult. And that the signature of the flash firmware update gets checked. So if your signatures don't match up to what's in there, it's no go. He ranked this one as the highest. He said if you can do it, I would do it anytime. So countermeasures. Actually, the researchers' statement was that we're all out of luck, we're all doomed. But EFI passwords. That's one of the few options you've got for securing Mac EFI. It's a rather low barrier of entry, but I mean it helps. It turns off some of the booting features. UEFI secure boot would help out the situation a lot, but currently unsupported. Third bullet, we've seen this time again. So the fourth bullet, it talks about the evil maid scenario, and that's basically somebody gaining physical access to your machine. You step out of the room for a minute, they drop by with a USB drive and pop it in. That's one of the most dangerous options for a lot of these Tech Asus motherboards. SMM is very dependent on who your motherboard and chip manufacturers are. So he created a keylogger that would trap at the IO trap on the SMM firmware, and he was kind enough to write a simple C program that would detect it by checking to see if the controller port, to see if it was enabled. If you're specifically worried about SMM bootkits running in the background, capturing key logging, that would be definitely something to look into. I think you can get to it from the presentation notes from his slides. The one important thing about the key logging situation is that it can be used to capture passphrases, so that even if you've encrypted your hard drive with, say, BitLocker and TPM mode, you capture the passphrase, you can then decrypt the drive. So this one can be extremely dangerous for cascading and finding other mechanisms to exploit. The last bullet is a SMM transfer monitor. This is a technology that Intel designed, but they haven't implemented. it virtualizes the SMM handler, and it would go a very long way to securing systems. Quite a few of the presenters have actually complained. They make it a point to complain about Intel's lack of implementation for this technology in countless briefings. So, yeah, that would, if that's going to be one of the morals of my presentation that I'll inherit from the people that came before me, is definitely pressure Intel to get some of that implemented. This is Intel Active Management Technology. This is allowing remote maintenance of machines. Your system doesn't need to have an operating system installed for this thing to kick off. It doesn't need to even be initially powered on. And it has network access. So, stores various data to the firmware memory. You can get access to, any type of configuration details, credentials, network configuration, security configuration. Provides direct memory access, which basically you have access to the PCI, access to RAM via the PCI bus without getting the CPU involved. Patrick Stewin of Berlin actually he has a number of talks actually if you check out the Berlin Institute of Technology page. And yeah, he has a good number of proof of concept code. AMT comes disabled by default. It's an option you're supposed to turn on, but there are actually AMT functions that run periodically whether it's enabled or not. So his proof of concept was hijacking one of those functions that ran periodically, and then using that to gain further access. I believe he did a keylogger as well, and he took advantage of the fact that it had network capabilities already outside of the US OS, and set up a exfiltration mechanism as well. So he had complete and total out-of-band communications with his keylogger that you would have to be elsewhere on the network to even detect. The problem with his proof of concept, it only works on old Q35 chipsets, was I think our 2008, maybe 2007. Q45 was common at least by 2009, so as long as you update your hardware. In order to pull off his proof of concept, updated BIOSes were blocking him in certain circumstances, so he found out that you can kick off a BIOS downgrade without any kind of user consent on older versions, and was able to do that to open up the door to run his code. Yeah, his initial proof of concept was in Linux. So the last presentation where he said that there are viruses for Linux, Windows, and Mac. This is pretty much proof. He did port it to Windows. Countermeasures: update your hardware, update your software, update your firmware. Intel Trusted Execution Technology, and again I'll cover that in a little bit, and common security practices. So here we've got I'll try and wrap this up in the next 5 or 10 minutes. Trusted Platform Module is the heart of low-level security. It was standard for a dedicated microprocessor for doing crypto. And at the bottom, the last two bullets, you can kind of see the two different types of encryption it offers. So not only key generation, system hashing. The binding is encryption with a factory burn key or a derivative of that factory burn key that comes with the chip itself. And then sealing means that chip has to be in a certain machine state in order for it to even consider trying to decrypt something. So TPM's pretty solid. Again, Joanna Rutkowska of Invisible Things Lab said that her main scenario that she pictured for compromising TPM was, again, the evil maid scenario, dropping by with a USB key, allowing a user to grab keys. Again, restrict physical access, consider gluing your USB ports, disable your CD-ROM if it's that important. Okay, here we've got trusted execution technology. It offers secure storage. It gets a secure storage from TPM. What it does is it stores the metrics for the programs it's about to load, and then will not load things that don't match up. And again, AMD has a version that they implement with a SKIN instruction. And here, Joanna Rutkowska, again, Invisible Things Labs, exploited a flaw to basically leveraged authenticated code module. There was the ability to do a buffer overflow in SINIT, and it required some heap manipulation, but was able to write a malicious ACPI DMAR table, which is, hardware memory access table. Requires pretty low levels of execution. Basically hijacks SMM, and Intel jumped right on it, issued advisories, offered patches right away. So protecting it, yeah, just make sure you're up to date. The Intel got involved with the OEM vendors and made sure that they could get patches out to people as soon as possible, require downloads. Yeah, one thing Intel did was change the layout of the trusted execution technology and make it so that the launching control policy was executed first. So that you can blacklist stuff ahead of time and not necessarily need to rely on patches. So it was an architectural change that would prevent anything similar, even if they found another avenue to attack SMM. TXT. So master boot record, boot sector at the beginning of storage devices, partition information, limited because it only handles up to 2 terabytes, 2 terabyte drives. This is pretty much your classic, traditional, the oldest form of bootkit available. So Stone bootkit was originally 1987. Peter Kleisner briefed an updated version at 2009's Black Hat. Basically, he dumps firmware, updates it, reflashes it. In this case, he also patches the OS loader. Full disk encryption using BitLocker would definitely help with this one. So would UEFI Secure Boot. You would be able to see that the modified kernel loader was not legit. And even the updated MBR wouldn't match up. Volume boot record, loaded the same way as an MBR. It's just another level down. So GAPS was a bootkit that was briefed at RECon in 2013. Requires Windows layout, patches 4 bytes, so it modifies a variable that increases the number of hidden sectors and that allowed them to hijack control flow. They also patched the boot manager and WinLoad. So for this, the countermeasure for this would be switching your partitioning mechanism to GPT would be the quickest, but that would also be a pain because you'd probably need to reinstall. UEFI secure boot would help. BitLocker in TPM mode, being able to check, having encrypted boot process, encrypted hard drive, and then expected signatures and metrics before it'll decompress and boot. And the final bullet, common security practices. I'll try and wrap this up. Here's the MBR replacement. This is going to be the way of the future. I think Windows 8 already comes with it pre-installed. A lot of people have had problems multi-booting Linux and Win 8 because on certain systems with GPT pre-loaded, they had to make sure that their Linux distro supported the GPT. I think Ubuntu 12.04, for example, I do not believe supported it when it was Win 8 was first coming out. So another stage in WinXP boot, the NT loader, it gets compromised by a bunch of the earlier examples I gave. So kind of felt like giving another example would be repetitious. Its replacement is Windows Boot Manager. It's hidden system file. Again, we talked about it earlier that it loads the BCD data. So there was a couple of proof of concepts for this one. VBoot from Nitin and Vipin Kumar of MV Labs. They did one version and then they just updated it a few years later. They had to use a CD in order to get it to load. I said I wasn't really going to focus on ones that were not already persistent on the system, but this is the type of attack you could probably run in an evil maid scenario. Hook N13, which is hardware read, I think, CD-ROM read. So when they hit bootmanager.exe, they run their payload, patch in 3 different places, bypass checksums, digital signatures, and depth, because they're hitting an already loaded piece of software. And then because I think they're patching in memory when WinLoad runs, it runs off of the pre-patched information. Again, don't allow physical access. We need to find a better way to prevent in-memory modification between loading and execution. Again, BitLocker in TPM mode will take measurements, and if it doesn't match up with the measurements, it won't let it run. It won't even unseal the keys to decrypt the drives. So in conclusion, everything has, we all know software is vulnerable. We haven't written complex software yet that is completely invulnerable. A lot of the new technologies that have been coming out have been offer a lot of mitigation, trying to stay current, trying to stay updated in hardware and firmware is actually becoming important. They've made a lot of advances. They still have a long way to go. They still need to get better. Again, the main point, Intel should definitely release STM. And then back to the common security practices. If you can stop exploitation of your machine, you can avoid a lot of the problems with malware trying to elevate its access and permissions. and burrow down deep into your system and maybe install something you can't get rid of even with an OS reinstall. So covered a lot of the references here. Hopefully you can, when I release the paper, I'll hopefully you can check out some of the conference briefings if you want some more in-depth information. I'm going to release a white paper. It's going to have a lot more references in that than even I mentioned here. It would have been 20 or 30 slides to quote them. So that's. Thanks a lot for attending it. I think I've got 10 minutes or so for questions. So.
Would you recommend that we have a machine that remains infected after installing the operating system? What's the next step after that?
Take it out back and shoot it? No. So identifying where the infection becomes important. If you reflash the firmware, BIOS or UEFI, and that's not working. If AMT is not working, and you try and update Intel's active management technology, or every step of the way you try and update firmware, try and isolate the problem. If it's something that you still can't get off, no matter how much you've flashed, or could even possibly be a hardware infiltration where they've soldered something onto your board that's not supposed to be there. So I mean, at a certain point, these things do get deep enough where you got to hope that something comes out down the road to help you identify it. But I mean, that's kind of the idea with 0 days. You can't always detect them. You can't always block against them right away. So just try and stay as current as you can and reflash everything that you've got options to. I'll go with you first.
About the AMT services that remain enabled when you say disable AMT.
Yeah.
So can you briefly characterize them? And second, do you have, are there signatures to their activity?
I'm sorry, I don't have more information on me. If I probably should have done a better job keeping track of the actual function that runs. I want to say it had something to do with a timer that would run periodically, a low-level timer that gets initialized, or a low-level check to see if something's been changed. And let me double-check. What the presentation was. The Berlin Institute of Technology. Okay, he's got probably 3 or 4 presentations on Patrick Stewin, if you can Google him, and Berlin Institute of Technology. He does a much better job than I can of breaking down the attack. Yeah, probably 3 or 4 presentations and at least a couple white papers. I'm sorry, was there anybody else? Yeah. I can't hear very well. Some of these technologies exist on their own chips. So some of the other technologies will not be hit if you do a BIOS or UEFI reflash. Right. So for example, Trusted Platform Module. It's its own chip, has its own firmware, does its own thing, exists outside of the band of a standard BIOS update. If you found a way onto that chip, yes, you could check. If you can find a way to read the memory of that involved with that chip, hooking up JTAG debuggers and finding out what's stored in the bytes there, yes, you could double check to make sure, do a sanity check to make sure things match up. But some of these technologies exist very low, like outside the normal scope of. I wouldn't say impossible. I think it's definitely feasible. It's just one flash is not going to do it. You might have to flash a few different components. Sorry if that. I'll go you in the back first. Oh, sorry. Okay. I can't see that direction.
So a lot of these, thanks for presentation. It seems like you're covering mostly like desktop, motherboards, motherboards. Have you done any research into the boot environments of embedded systems? Like Intel has a Galileo board now.
Okay.
There's the PI, the Beagle board, and Beagle bones. You have a lot of these small embedded devices that are 32-bit, gigahertz processor running Linux.
Right.
Raspberry Pi has a GPU, and they each have like their own, sort of unbrickable preview POS.
Right.
Have you looked into that at all?
Just very little. A lot of my RE experience is reversing firmware for embedded devices, so to say I haven't looked into it is probably not entirely accurate, but I haven't done in-depth research or surveys of what's available for exploiting the boot process on Raspberry Pi and whatnot. Definitely something to look at in the future, though. Sorry. Okay. Sorry?
So, along the same lines, we've heard of markets for phones. Because I know that there's a whole industry, right, cottage industry about ruining your phone and getting the bootloaders.
There's at least there are a few for Android, for sure, and I don't remember seeing anything for iPhone. When I was doing research this time, but I can say without a doubt that there's a way to the hardware on iPhone. I meant to answer you in the back. Sorry. That's a tough call. From what I was researching, UEFI, because it is kind of a nebulous spec with so many people's input, I think that one in particular, because nobody took the lead and stamped out, I think that the spec might have been a little bit nebulous for some of the vendors. I do know that the more times you release an RFP or a spec and sorry, not RFP, RFC. 20 people implement in different ways. I've done a lot of network device research, and there's an entire field of fingerprinting based on different vendors' implementations of standard networking protocols. So I think anytime you release a standard, you're definitely open to the idea that people are going to implement it in different ways and be more or less strict with it. I would say it's a common thing that anytime you try and have a public standard, that bugs are going to find their way in. Yes?
These are all talks and concepts. How often do you come across rootkit type problems?
Oh, so I'm sorry. Going back, each one of these has in the wild exploits. So the stoned bootkit I was talking about, very similar to mebroot, which is a Trojan that does pretty much the same thing. Dream boot is actually in the wild. Think a few of the other ones on there they had kind of clones, maybe not maybe not the exact same thing as the proof of concept, but something that worked very similar.
But will they develop it right after the presentation?
That's a tough call because Stoned, the updated Stone briefing was in 2009. I think MebRoot was released in 2009, so I believe that, yeah, in some cases the research may drive some of the technology, but in other cases it's definitely the opposite. Somebody sees a nasty piece of malware and briefs on how the mechanism works. So, sorry. Thank you very much. I'm going to post it on the H.O.P.E website, I think. If they don't, if not, my Twitter's at H.O.P.E. Yeah, it's just one word. But yeah. But yeah, if you need me to write that down or email address, just let me know. I'll grab you in a second.
I just want to say thanks for doing your prior research. Have so many people come up and like, I found this good thing. You can have NPR. So thanks for giving a shout out to all the people that came before you. Giving all those references.
Well, yeah, I was a little bit nervous.
An hour, so.
I was a little bit nervous that I was doing more of a survey talk. Then this is something I created.
It's most useful. Different kinds of talk, right?
I'm not planning on. Okay. Thank you. So I think it makes sense to go ahead and get started. Hi, everyone. I'm Jonathan Mayer. Before getting into the substance, I want to make sure to note that everything I'm about to present is not just my work. I had some awesome collaborators on all of this. And Dan Benet and John Mitchell, faculty at Stanford, Ed Felton, faculty at Princeton, my colleague Patrick at Stanford Computer Science had tremendous input. None of this is just my own work. I also have to do my obligatory disclaimer at this point that I'm not your lawyer, and nothing I'm going to say today is legal advice. If you have questions you want to ask that are of a legal nature, this isn't a confidential environment, so keep that in mind. And the reason you know I'm not your lawyer and this isn't legal advice is because the transaction would look a lot more like that. Okay. So let me start with the motivation for our research on the NSA. It started from a place that I think many of you may be familiar with, a lot of frustration with the agency. That it hadn't been very straightforward, that it engaged in a lot of conduct we found objectionable. And so, we were pretty concerned about what we were learning. And there was sort of a common mode of response. Again, I'm sure many of you are familiar with this, that the NSA deserved some pretty substantial public opprobrium. So that seemed to us an entirely fair viewpoint for folks to have. But it seemed to us maybe there was a way of leveraging computer science in debates over the NSA to try to have a constructive role alongside the sort of directed opprobrium at the agency. And so kind of very roughly, this was our model of how the NSA interacted with its oversight authorities. Maybe it would make sense if we could find some way to get some actual computer science facts into this debate in a way that had seemed, unfortunately, quite lacking. And so we started by trying to learn as much as we could about the law that governs the NSA, talking to intelligence law experts all over the place, then did some computer science research, trying to understand the implications of the law, and then finally returned that to legal fora for arguments about why, as a matter of what we now know from computer science, the NSA's programs should be held unconstitutional or should make less sense as a matter of policy from one of the oversight board's perspectives. So this is what we tried to do. And in thinking through the law, it became very clear to us early on that domestic bulk surveillance authorities include privacy safeguards. They're safeguards primarily for U.S. persons. So if you're a foreigner outside the United States, you're kind of out of luck. And today I'm not going to be talking about international surveillance. In particular, you might have heard of Executive Order 12333 and what the NSA does outside the United States. I'm not planning to talk about that in the body of today's talk. I'm happy to take questions about it. I'm also not going to be talking about individualized surveillance, targeted orders for an individual's information, since the legal structures there look very different, and I think it's fair to say raise a very different sort of policy concern from bulk surveillance authorities. So in thinking through these privacy safeguards, it became apparent to us quite early that these were safeguards designed by lawyers, and that was kind of a weird property for them, since there are safeguards on primarily technical systems. So lawyers on the Supreme Court, the Foreign Intelligence Surveillance Court, certainly within the executive branch, had put together a set of rules, and rules based on technical assumptions. Maybe it would make sense to, if you can't practice law without a license, maybe you can't practice tech law without a computer science license or something like that. Anyway, so these guys were kind of practicing computer science without a license, and so we thought, okay, let's take a look at those assumptions. Let's see if they're accurate. And so today's talk is going to proceed in three parts. First, laying out the NSA's Domestic Bulk Surveillance Authority. I suspect that's going to be recap for a lot of you, but I want to make sure the playing field's level. Then I'm going to talk about our work on the NSA's International Internet Traffic program under Section 702 of the FISA Amendments Act. And then last, turn to the phone metadata program under Section 215 of the USA Patriot Act. So I'm going to start with that overview of domestic bulk surveillance programs, and first talk about the earliest court-sanctioned program, no longer in existence, looking at bulk email metadata. So the legal constraints on this program were that the NSA was only allowed to acquire metadata. There need to be reasonable and articulable suspicion to look at the data set. RAS is a legal standard that's used for so-called Terry stops, stopping you on the street. The controversial New York stop and frisk policy was based on RAS, so it's a pretty low standard. So those were the legal constraints for taking a look at email metadata. The source of legal authority there was not the FISA business records provision you might have heard of, Section 215 of the Patriot Act that's been in the news a lot. It was actually Section 214 of the Patriot Act, the pen register trap and trace device provision. The reason that's important in NSA overhaul debates is if 214 can get used in the same ways as 215, then 214 also needs some revisions. Not coincidentally, the NSA has taken the position that, well, if there's going to be action on 215, why don't we leave 214 in place? The Fourth Amendment also provides some constraint here since metadata, at least under the law as the NSA views it, isn't protected by the Fourth Amendment. I'm happy to take questions on the specifics of that doctrine in the Q&A, by the way. Okay, so a quick sketch of how this program worked. If the laptops represent end-user devices and the servers represent email servers, a user might use webmail over HTTP or send a message over SMTP to their email service, and then goes over SMTP to another email service, and then finally someone will retrieve it by webmail or one of these mail retrieval protocols. And while your session with your service might have been encrypted and authenticated, and the recipient's session with their service might have been encrypted and authenticated, for quite some time, the traffic between these servers wasn't encrypted and authenticated, and so the NSA was having a bit of a field day. Thankfully, this is now changing. Large email service providers are now starting to encrypt and authenticate their traffic, so it's not clear this program could even be as effective now as it was historically at collecting information. But anyway, that was the design of the program. And so just a quick sketch of what this looked like in SMTP to give you a sense of how easy it is to pull this data out. If this is an SMTP session, the NSA would get the stuff in red. All right, pretty easy to just parse that out of traffic over the wire. So that's the first program. It's no longer in existence. We didn't study it primarily because it's no longer in existence. So I thought at minimum you should be aware of it. The next one that was in the news quite a lot actually very recently is the NSA's 1N4 and Internet Traffic Program. Appears to have started in about 2001, transitioned to court oversight in about 2007. And I think the NSA's own slides probably provide the best explanation of it. So great, like lots of internet traffic flows through the U.S., even if it's not necessarily directed into the U.S. or out of the U.S. So the NSA is in a good position to observe network flows as they move around the internet. The program I'm talking about is the one known as Upstream, not PRISM. They both arise under the same legal provisions, but they operate very differently. So Upstream is internet traffic as it flows over the wire. PRISM is targeted orders at particular services for particular accounts. So Upstream is bulk, PRISM is not. So the Upstream program was a very controversial part of the recent Privacy and Civil Liberties Oversight Board report on FAA 702. If you want to get a little more detail on how it operates, that's probably the best place to look. Unfortunately, the details are still incredibly sketchy. Including some specifics like, is it all 1N4 in traffic? Is it buffered for a while so that the NSA can look back for a few days for traffic of interest? Are the rules different for organizations versus persons when they're human persons when they're targeted? Are the rules different when the traffic is some sort of messaging that happens to be going over some corporate network, but that's sort of an intermediary step? It's not really clear. The FISA court certainly has not parsed this all out, and the PCLOB didn't either. Here's a quick sketch of what the sort of information that's available from the system looks like. So So at least once once it gets to an analyst, it looks just an awful lot like ordinary internet traffic here, a parsed up HTTP session. So again, the legal constraint is that this has to be one end foreign, that is, one end of the communication has to be outside the United States. Not entirely clear what the NSA considers to be sufficient for one end foreign. The authority is FAA Section 702, so every year the FISA court stamps a targeting order. Then the NSA, acting through the FBI, it appears, serves out orders without court involvement on major ISPs, and they provide access to this traffic. The Fourth Amendment, in the NSA's view, doesn't apply because of one of two doctrines, one being around non-U.S. persons outside the United States aren't entitled to Fourth Amendment protection. It's not clear how good the precedent is, but at any rate, that's the NSA's view of precedent. And the other being the border search doctrine under the Fourth Amendment. So that's why the NSA believes this program is lawful. Phone calls have certainly been in the news. One of the earliest of the very controversial NSA programs. The legal constraints here look an awful lot like the legal constraints around the email metadata program. Again, metadata only. Again, RAS for querying. There's contact chaining allowed here. Contact chaining also is allowed for the email program, by the way. The idea being you don't just look at the metadata of a target, but you can look a few degrees removed. In the news, very controversial. And this is the program that's under Section 215 of the Patriot Act, the so-called business records provision, so not quite the same legal authority as email metadata. The Fourth Amendment rationale, by the way, the exact same, metadata not protected. There's a financial records program under Section 215 of the Patriot Act that the CIA operates. Details on that are pretty thin, too. So we know it exists. There's not so much more that's been published about it yet. There was a trial of a phone location program under Section 215 of the Patriot Act that was short-lived, allegedly a little narrow in focus. The agency appears to have not thought it was getting valuable information out of it, but certainly believes it has the legal authority to collect that information. Okay, so those are the major programs we know about. What don't we know about? Who knows? There certainly could be other 215 programs. There could be other 214 programs. There could be other things 702 is getting used for. There's been still very little transparency on the legal reasoning and application of that reasoning side of the NSA debate. So this was our best attempt to synthesize the playing field. And with that out of the way, let me turn to the research we did. Since for us, anyways, this was the much more exciting part. So starting with the internet traffic program, the 702 when and foreign internet traffic program, we started by looking through assumptions we found in documents justifying the program, documents out of the FISA court, documents out of politicians, documents out of senior executive branch officials, and started documenting what the assumptions were surrounding the programs. And one was that Americans don't send data outside the U.S., and so we thought, okay, let's see if we can measure that. That seems like a good technical question. Do you send your information outside the U.S.? Another assumption is that, well, when you send information outside the U.S., you know you're doing it. So it's sort of an assumption of the risk argument. Kind of like when you decide to fly internationally, you know you might be subjected to some sort of heightened search at the border. I'm not saying this is great legal reasoning, but at any rate, it was one of the assumptions. And so we thought, okay, let's see if we can find out whether Americans knowingly send their data internationally. And so we found the answer to both questions was, yeah, Americans send data outside the U.S. all the time, and they don't know they're doing it very seemingly wouldn't know they're doing it very often. So let me give a few examples of how this happens. How stuff that would seem like it should be entirely domestic, should seem like it should be entirely protected by the Fourth Amendment, and should have been unambiguously protected by the Fourth Amendment for decades, may actually come within the NSA's warrantless surveillance authority. So first, domestic websites often include foreign content. So here's a trivial example. Let's suppose you're reading a news website, and some advertisement loads from some advertising company, and the news website is located inside the United States. Well, the NSA is going to need to go, well, I should say the FBI is going to need to go and get a wiretap order to monitor your traffic to that website, and the content of the traffic. But suppose the website is in the U.S., but the advertising company isn't in the U.S. There's a sort of echo that goes to the advertising company outside the U.S. With your HTTP request, there's this field included, or FIR. You know, of course, that the folks who designed the HTTP spec weren't English majors, because now we're stuck with a misspelled refer in every HTTP request. So by watching an international advertising company, the NSA could very easily see, okay, you've just read something on this news website. And so long as it's a public URL, it doesn't even matter that the NSA can't see content, because of course they could go check out the URL themselves. So here's a really simple way in which, just because of the way the web works, the NSA may have the ability to read, see what you're reading on popular websites. And let me give you what was unambiguously my favorite example of embedded third-party content on a domestic website. So you'd think like the House of Representatives website would be as American as apple pie. It turns out that there was a little text widget, like a read aloud widget, that was hosted off of a server in London. Entirely noble aims, but you know, for folks who had difficulty reading English. But the net effect was that every time you visited a page on the main House of Representatives website, your traffic flew over to London. One end foreign, pretty clearly. Okay, so we did a crawl looking at some popular websites to get a sense of how pervasive this sort of international traffic leakage was. And we found it all over the place. There were, you know, across all sorts of categories. Like Nike, for example, had a Japanese analytics company they used. There were ads getting loaded from outside the U.S. Some medical providers hosted or embedded little logos certifying that they complied with various legal regimes. Sometimes those logos were hosted on servers outside the U.S. So pretty eclectic mix of what caused the traffic to leak, but clearly it's the case that the traffic leaks a lot. And so it looked to us like very roughly about 10% of popular web pages include this phenomenon. And so that's kind of the net effect of the NSA's legal theories, that, take kind of a 10% haircut on the Fourth Amendment, because that's the proportion of your web traffic that can be surveilled without a warrant. Okay, so that's one way in which traffic might leave the U.S. Another is domestic organizations might just have foreign hosting. So another fun example we stumbled across, GM, you would imagine, very American, headquartered in Detroit, heck, owned in large part by the American taxpayers for a while. It turns out a lot of their corporate IT is based out of Frankfurt. And so depending on which GM URL you go to, your traffic might actually get bounced over to Frankfurt. And so the NSA could see, which caddy you were checking out. Let me give another example I stumbled across about a week ago, and that is yeah. So right here we are in New York. H.O.P.E, of course, sponsored by 2600, an American organization. Let's do a quick demo here. So make sure this is working. Excellent. Okay. Let me, sorry. Yeah, okay. Okay, so I'm just going to load up the H.O.P.E schedule and send that over here. Okay. Right, so hopefully that looks okay. Sorry, I'm going to freeze down for a second. So you can see right here, blog.x.hope.net is getting an HTTP request that's pulling in an RSS feed of who's going to talk at H.O.P.E. And so now, if we come back over here, okay, working on it. Okay. Hopefully that works. Not so much. Okay, just a second. Nope. I'm tethering off my cell phone. So anyways, you'll see that this is not a server actually located in the United States. Kind of didn't really hide the punchline too much on this. This is like the most anticlimactic demo.
Worth the suspense.
Okay.
Just more weed.
Wow. This is why Verizon is so great.
Yeah.
There's London.
Okay, very excited. We left the U.S. Houston, we have warrantless liftoff. Okay. So you get the idea. So things that would seem very, very domestic, not necessarily so domestic. Also, there can be services that are not obviously foreign. So you might think you're using something that's based in the U.S. as a U.S. company, very popular, just happens not to be. So, for example, if you've ever scheduled a conference with the website Doodle, turns out they're a Swiss company, and a lot of their infrastructure is out of Switzerland. So your conferences getting scheduled through Doodle are apparently open to warrantless wiretapping. Spotify, popular music service, also not in the US. is.gd, popular URL shortener, you might use it on Twitter. Turns out every time someone goes through one of those is.gd links, they're hitting up a server in the UK. And actually, some people who, some folks use is.gd links in a sort of ironic way. So I don't know if this is like actually Bruce Schneier's official feed. But anyways, kind of funny that like you click a link to learn about the NSA and there goes your traffic into the one end foreign bucket. Okay, so fourth way in which your traffic might get wind up outside the US in a way you might not expect. Sometimes routes just go all over the place. So for example, here's a route that occurred not too long ago. That's from within the same city to within the same, 2 points within the same city. So the internet can be a little unpredictable, and so just by virtue of how routing works, your traffic might leak. So the punchline to all of this is that ordinary Americans are not going to send tons of their traffic outside the US. Those assumptions that underlying the legal arguments for this program are I think, all the more questionable in light of what we found. And so we think it suggests that just this one-end foreign rule is not really consistent with how information technology works today. And actually, this particular study got cited by the D&I review group for the idea that maybe one-end foreign doesn't make so much sense anymore. I think I saw a hand up. I'm planning to take questions at the end, planning to leave some time for them. So please just hang on to them. Okay. So now let me turn to our phone metadata study, and again start by unpacking the assumptions baked into it. One is that metadata isn't identifiable, which I think was kind of laughable to a lot of the folks we talked to about it. We thought, okay, we'll see if we can identify phone metadata. We were pretty confident we could do that. There's also this assumption that metadata wouldn't be densely interconnected, that by imposing limits on how long the data was retained, by imposing limits on how many hops you could make throughout the call graph, that would prevent getting too many folks' metadata swept up in queries. And so we thought, okay, let's see if we can figure out what the structure of the phone call graph looks like. Another assumption baked into this program is that, well, it's just metadata. It can't be that sensitive. What's the big deal? We were pretty skeptical of this one too. And so we thought, all right, let's see if we can draw some sensitive inferences out of phone metadata. And so the starting problem we had to overcome in our study was how on earth were we going to actually get our hands on some phone metadata and some ground truth to see if the inferences we were drawing were accurate. And so our first thought was like, maybe let's ask some telecoms. And yeah, that's like pretty much exactly what happened. Yeah, they were not so forthcoming. And so we thought, okay, like why don't we why don't we ask the internet? Like, pretty please, internet, we're trying to study the NSA. Is there any chance you would trust us with your phone metadata? And a bunch of folks did. So we put this app up on Google Play called Metaphone. And here's a quick sketch of what the screens looked like. So, you bet we had a disclosure. Went back and forth with IRB on this one. And then folks could connect their Facebook account. Great, so this was how we solved the ground truth problem, that we said, give us access to your Facebook account, and that way you don't have to answer a bunch of survey questions about your age, your gender, your location. Facebook's API will provide that to us in a well-structured way. This was all directed on the US Google Play Store. And actually, I think we occasionally got negative reviews on Google Play saying, I want to give you my information, I'm outside the US, why won't you let me? Yeah. So a lot of folks participated. We had the good fortune to get some press attention on this as we shared some parts of our results. So each of the red lines represents some amount of media attention around some release, and then the blue bars are how many folks submitted data in each week. So kind of got a little spike as we shared our results. The sample is definitely not representative of the US population. You have to have an Android phone, you have to have a Facebook account, you had to opt into this. I'm pretty confident some of these people were lying about their age. And then, of course, the gender imbalance was unfortunately, roughly like, DEF CON. I was going to say H.O.P.E., but I've been really heartened to see that H.O.P.E. is not DEF CON. So we had all told about 825 participants, which leads to some awkward conversations with folks in Silicon Valley. I'm like, did your app go big? And they're like, yeah, we were really impressed with how many folks were willing to give us their metadata. And they're like, hundreds of thousands? Not quite. But we thought more than enough to draw some conclusions about the privacy properties of metadata. About 250,000 calls, 1.25 million text messages in our data set. So a good amount for making some observations. So we looked into this idea that phone metadata isn't identifiable. It's an idea that's actually gotten tossed out by some folks who really should have vetted it more thoroughly. So for example, here's what President Obama had to say. Here is what Senator Feinstein had to say. And on the other side, Judge Leon from the District of Columbia, the most confusingly titled court, there are two districts, said, gee, it sure seems like it would be easy to identify these. And then Ed Felton at Princeton did a declaration for the ACLU pointing up, it sure seems like it would be easy to identify this stuff. Not to ruin the punchline, but shock, the computer scientists were right and the politicians were wrong. Okay, we sampled 5,000 numbers and hit up a bunch of APIs. Here are 3 of the ones we played with, trying to see if we could match those numbers to identities of individuals and businesses. And so here are the hit rates we got on each of these. All told, we got a little over 27% with just free public APIs. And then to see what a little elbow grease could get us, we just sampled 100 numbers randomly out of our data set, and then just using Google, just like popping the number into Google, and a free commercial database, we got to 91 of them identified, in addition to the sources with APIs. So the notion that phone numbers aren't identifiable is definitely not true. Okay. So we next looked at the structure of the call graph, trying to understand what the NSA's durational and hop limitations did in effect. And to understand how those limitations work, it helps to give a quick sketch of how the 215 program works as a sort of database, as a sort of shuffling data between databases project. So there's this raw phone metadata that comes in from the phone companies, and individual analysts can't look at it. Technicians can, for purposes of combing over it, and making sure it's well formatted, making sure the agency is not getting fields it's not supposed to get. But individual line level analysts aren't supposed to look at it. Separately, there is a list of seed queries that have been cleared for reasonable and articulable suspicion. Originally, those were cleared internally. Now they're all cleared with the FISA court. And then those two can be combined, a seed query in the raw data plus a couple of degrees, hops, outwards in the raw data to get a sort of neighborhood around some seed phone number. And then finally, the results get put in some database called the corporate store. Why it's called the corporate store is beyond me. Once data is in the corporate store, it can then be analyzed without any further need for looking for RAS and with some more substantially laxer constraints than the raw data has. So there's this incentive to put as much data as possible in the corporate store if what you'd like to do is maximize the information available to line-level analysts. So in thinking through how much information might be available for a given seed query, we started by thinking, okay, so there's 2 or 3 hops out, 3 initially, now the NSA has voluntarily scaled it back to 2. So here's just kind of a recap of what the hops look like. And for clarification, as best I can tell, at the last hop, the agency collects the metadata of each number that's within that hop count, such that you're actually kind of 3+ or 2+ hops away because you can see numbers that are connected to the second hop or they're connected to the third hop. One call in the past 5 years is currently enough for a hop. Under the White House's reform proposal, that would get scaled back to about 18 months, which is the retention requirement for phone companies anyways. Okay, so we thought we should ask how much of the call graph could go into the corporate store. And our first take on this was, well, let's just kind of think about it like a Kevin Bacon problem. And a pretty diffuse social network where, very roughly speaking, you have some degree associated with each node and you multiply out the degree, and there you have roughly how many folks are connected within some number of hops. And we certainly weren't the only ones with that intuition, and you would get some number of folks from the thousands, the millions, depending on what you assume the degree was and how many hops you went out. So we thought, okay, that's kind of what this is going to look like. We're going to be able to say something about the rough degree of a phone subscriber. We're not going to be able to say much more of that because our call graph is going to be really disconnected. And we thought it was going to be really disconnected because, well, we have the scattershot sample of folks who just decided to give us their phone metadata. It's a time-limited sample. We only got about 180 days from most participants, as opposed to the NSA's 5 years. And it was, all things considered, a small sample, enough that we thought we could draw inferences, but, it was hardly hardly Silicon Valley big. So that's what we thought we were going to get, and it turned out we were entirely wrong. And so let me give you some diagrams of our connectivity graph. The blue dots represent participants in our study. The gray lines represent some connectivity between the dots. And then the red dots are going to represent non-participant numbers. I'm going to add those in with the highest degree ones first. So you can see here there are just two people in this visualization who had directly connected with each other. So not a closely connected participant base. So the highest degree hub we found was T-Mobile's voicemail. Turns out if you have a phone configured to dial into voicemail, well, there's this there's a hub. So everyone who has T-Mobile voicemail is just 2 hops away from everyone else who has T-Mobile voicemail. Yeah, so that's quite a lot of connectivity. That doesn't look a lot like a diffuse social network. That looks a lot like a hub and spoke network where just a couple of hops can actually get you pretty far. And adding some more in, customer service. I guess a lot of folks have indeed to call Comcast customer service. Skype uses certain predictable numbers for their outbound calling if you haven't paid for a custom Skype number. So if you've taken a call from someone who uses Skype, then you're connected to everyone else who's taken a call who uses Skype from that auto-set Skype number. Lots of calls with 611. Let me add some more in here. So then things started to get really fun when we started to see the telemarketers in our data set. So they're like just making the NSA's job a lot easier, right? They're just trying to dial a bunch of phone numbers, which has the net effect of putting them all 2 hops from each other. Yeah. Right. So you see how, right, more and more of these hub numbers crop up, pretty densely connecting our participant population. And so by the time we're done, it doesn't look like a diffuse social graph at all. Actually, it looks like you might get an awful lot with just a couple of hops. And so to show this slightly differently in graphical form, the horizontal axis here is the hub numbers just ranked, and then the vertical axis is the proportion of participants that are connected. And so one key takeaway from this is instead of thinking about this as a Kevin Bacon problem, where you're kind of multiplying out from a certain number of people who might be connected, maybe another way to think about it is just meaningful share of the entire U.S. population that's within 2 or 3 hops of a number. So right, very easy for a hub to be between some seed and some individual phone user. We found that over 90% of the participants in our study were within a connected component, over 60% within 4 hops. Thinking through the possible 3-hop connections, we didn't have a good way of seeing 3-hop connections because our participants weren't connecting directly to each other. But you could imagine something like one of these 2 arrangements, right? So you call someone who in turn calls a hub. You're then 3 hops away from everyone else connected to that hub, or the hub could come earlier in the chain. And so we did a resampling approach to try to roughly get a handle on what the implications of these hubs were for 3-hop call connectivity, and we found over 50% of our participants were connected within 3 hops in expectation. So 3 hops gets an awful lot. And to leave you with like one other way in which 3 hops can be substantially more concerning than 2 hops, you can even have hubs connecting to hubs, right? So if someone from Skype has at any point called Comcast, you have the Skype hub now connected to the Comcast hub. And so the numbers start to get pretty darn big. So the takeaway for us was that this hop limitation isn't much of a limit. You would have to do some mandatory removal of high-degree nodes in the call graph. And even then, the degree of participants, the number of folks they were calling was so high that there was still a large number of people within the neighborhood of 2 or 3 hops. So the hop limit didn't seem to us like a particularly persuasive means of cabining metadata surveillance just on the numbers. And one side note to all of this, it's not really clear what moving the raw data solves. If that raw data on the database diagram I showed resided with the phone companies as opposed to residing with the NSA, when so much of that data can get shoved into the NSA's corporate store, it's not really clear what the big privacy win would be by moving all of that data over to phone companies. Okay, so that's all I wanted to say about the graph of the phone network. Now I want to turn to inferring some private information about phone users. One experiment we ran was trying to identify relationships automatically. And so we took as a fun little weekend task inferring folks' relationship status just from their phone metadata. It turns out if you know someone's in a relationship, figuring out who they're in a relationship with is really trivial. It's like the person they call all the time. But figuring out whether they're in a relationship is trickier. And so we thought, okay, let's see if we can figure it out just using automated graph analysis. And most of these, by the way, were not public relationship statuses. They were shared only with friends or one of the other Facebook settings you can twiddle. So here's the performance we were able to get just with like a weekend of hacking away on this. Not great, but we thought pretty good. And anyways, right, like what do a couple computer scientists do on a weekend instead of like going out on dates? They figure out if other people are going out on dates. So we got decent performance. We're still hacking away to see if we can do substantially better. But clearly there's a lot of opportunity here for doing automated analysis. We also looked into whether we could draw some pretty sensitive inferences out of phone metadata. We went looking for businesses that were associated with sensitive traits and found, for example, there was a participant who had calls to and from substance abuse treatment center. There was a participant who had calls to and from an STI outpatient center. There was one participant that got a lengthy call from a major medical center, then from a clinical psychologist at that medical center, then some calls from local pharmacies, calls to and from cardiology groups, and finally regular calls to a home heart reporting line used for a medical device to monitor an arrhythmia. The individual had an arrhythmia. We were actually able to confirm that using public information. So there's finding a medical condition just using someone's phone metadata. Really not challenging. Or there was another participant in our study who made a number of calls to a local handgun sales and repair. I should say handgun, and also specialized in a specific kind of assault rifle, the AR-15. Followed by some lengthy calls to a company that specializes in making an AR-15 platform rifle. We were able to confirm, again, using other information, that this individual owns an AR-15 rifle. So they're spotting a specific model of gun that someone owns just using their phone metadata. So we have this hypothesis that maybe, in fact, phone use is more common in sensitive communications. There are these sectors, whether it's medical practice or legal practice or gun stores, where just as a matter of path dependency, they tend to use the phone a little more than others. And so, in fact, maybe this focus on phone metadata can be really quite revealing, perhaps more revealing than other forms of metadata you might get because of its tendency to get used in these sensitive contexts. So that sums up everything I wanted to say about the NSA's programs and about our research. I wanted to close with a quick request to you, and that is that unambiguously the government needs help from you, from our community. Our lab got tons and tons of questions about our work from folks at pretty senior levels in the federal government because they didn't have another place to get the facts. And so my request is maybe if we could change the diagram a little bit, and maybe if our community could step in and provide the facts to NSA oversight authorities that the NSA isn't providing right now. That's not to say it's not mutually exclusive with saying screw the NSA. But it's a way of, I think, constructively affecting the debate using the computer science skills we have. And so I guess I would, to the extent it seems of interest to you, I think it would be an extraordinarily productive use of your time. Okay, that is the sum total of my material, and I'm happy to answer Q&A, including beyond the material itself. Thanks.
In looking at this surveillance data, were you able also to look internally or analyze the Snowden documents in some way, help us understand why this massive investment in surveillance technologies like this happens at this time? Is it just about terrorism or something more?
Well, with respect to the legal arguments around these surveillance programs and why they're getting made in ways that seem very uninformed and why they're getting made that way now. A cynical take would be it's just strategic, right? If kind of the technical details were known, maybe the FISA court would come down differently, maybe the White House would feel differently, maybe DOJ would feel differently. I guess there's a sort of other way of reading it, the sort of banality of legal incompetence version of just these are a bunch of lawyers who don't have great technical backgrounds. And I'm sure many of you have seen it in practice. If someone doesn't know the right questions to ask of a technical expert, they often don't get details they really wish they would have known. And so I think that is also a version of events that's entirely consistent with these legal rules.
Can I just follow up for a second? Because really what I'm getting at is the political rationale for all this as opposed to the legal justification for it. You've made reference, for example, to financial records, but there doesn't seem to be a lot of information about this. And that seems to be under the CIA, not the NSA. How do you understand what actually is being monitored here?
I don't think I have any special insight into the political dynamics of of why the NSA is surveilling in the ways it is. I'm happy to talk about it offline. It seemed like there were a bunch of other questions. Let's go. I'm going to just go across like this. Yeah.
I just wanted to know what you thought about inferring data via Skype or phone, which is safer?
Well, it seems like Skype information is not at present getting passed to the government in bulk. So at least with respect to metadata, a more targeted order would be required. Yeah, there's certainly the ability to do lawful intercept on Skype now, but the same. So with respect to a wiretap, it's very similar to a phone call. Go get a wiretap order. If you're curious on the details of this stuff, by the way, the sort of core orders you would need for a particular service to intercept, Stanford Law is going to be launching a class, one of these free online classes, on surveillance law in the fall. And so there's going to be a lot more detail on that there. Yeah?
I just wanted to know, in practice, do they focus more on computer networks, or do they focus more on phones? You know what I mean?
Well, I don't have any special insight into the NSA's internal priorities. But with respect to ordinary law enforcement, there's no doubt there's a path of least resistance current in focuses on various surveillance systems. And so, to the extent you're getting investigated by the local PD, you're probably more likely to get surveilled by some particular form of intrusive surveillance if it's something they've used before, they know the process for, and so on. Yeah, my understanding is Skype has gotten fairly routinized at this point. Yeah. Yes?
So it seems to me that something you might want to be concerned about is a connection factor. So that is, let's suppose you've got someone who, the NSA has RIS to look at the phone. Okay? What's to stop someone with a burner phone connecting that RIS number with some other number that they might not have RIS for?
So you mean intentionally dialing the RIS number? I'm not aware of any, at least government internal analysis that's been released on what the legal implications of that would be. For all of the criticism it gets and all the criticism it deserves, I can't help but imagine the FISA court would not have a sense of humor about that. That seems like pretty overstepping when you're intentionally circumventing a surveillance limitation solely by technical shenanigans. Yeah,
There's no specific privacy guards in place to address that?
I think that would, I'm not the NSA's lawyer, certainly not. If I were working inside the NSA as counsel, I would certainly not, look kindly on an analyst who wanted to do that. I think that would be a very, very strained reading of the FISA court orders that set up the phone metadata surveillance program. Yeah.
Regarding the network analysis that you were doing, do you find you have these hubs which are highly connected, and as a result, there's a very small path distance between people in the network? But it seems like many of these may not be actually very informative on a person's associations because, okay, they have T-Mobile. It doesn't necessarily mean that they personally go to a house. So, I'm not sure how you would automatically remove those hubs from the network, but if you were to do that, do you find a similar connectivity?
So let me start with removal of the hubs and then what the impact of removal of the hubs would be. The FISA court has a really weird kind of backwards view on this, where there's some language in their opinions where they view it as a concession to the NSA, that they would allow the NSA to try to identify hub numbers. They don't say the NSA has to, and their reasoning is, well, we're allowing them to look over the entire data set and generate some analytics in a way that we weren't going to otherwise. Right, of course that's kind of backwards. The whole point of removing the hub numbers is to protect privacy. So once again, practicing computer science without a license, and from the federal bench, no less. So the NSA appears to have authority to remove these numbers. As for whether they do, not entirely clear, and critically, to the extent they do, not clear at which stage of the pipeline they do it. Because, again, if the incentive is to maximize that corporate store, that database of phone metadata that's not subject to legal, such substantial legal constraints, why not detect the hubs, then use the hubs for hops in moving everything to the corporate store, then remove the hubs out of analysis within the corporate store. So in short, the kind of legal structure for removing the hubs is unclear and shaky. As for what the impact would be, it's hard to filter out just the hubs, since there's this kind of long tail of like the local pizza shop that would be hard to knock out in a very reliable way without risking losing some intelligence information. So you might be able to get rid of the really high degree ones, but there'd still be a pretty substantial impact, it seems, on the topography of the graph. And then even if you were to somehow just get rid of all the hubs and rely on just the diffuse call graph, there's still a sufficiently high degree. There'd be a lot of information. Okay, so here's my plan. We do take the remaining questions together, and then I'll answer both, and then we'll call it a day. So do you have a question?
Yeah, I did. So your end request was that we get involved.
Okay, and the other question. 2 more questions. I'll take them all together.
Okay, well, mine is in the same vein. I want to make sure I understand something. Are you saying that public officials who are involved in oversight of intelligence have actually contacted you or your colleagues with a view toward trying to understand what's going on? Not just to tell you to shut the fuck up, or they really want you to help them understand what's going on?
That's an easy question. The answer is yes. Next one. Okay. So let me start with how I think you could effectively impact the debate. Reaching out to folks in government is surprisingly easy. I actually worked a little bit on the other side of the table at the California Department of Justice, and we loved when people volunteered information that was helpful to us. And if folks came to us and said, "What can we do that'll be helpful to you?" we would tell them. And that's been my experience in this debate too. That there are folks with big questions they want answered, and they don't know how to answer them. There are also the questions they don't know how to ask, and there I think the way to start is what we tried to do. Start with understanding the law, then do some technical studies of what the law means, and then circle that back to, and here's why the law is probably wrong. With respect to learning the law in this area, we've been frustrated with the quality of resources available, and that's actually one of the reasons why we're working on this online class, so that folks who are really interested can get a good handle for free on the law of the space. Tempora appears to be a British program, so it's operated by GCHQ. It's not under Section 702. It's outside the U.S., so the legal authority for the 2 programs is very different. Collection from the Brits would seemingly fall under Executive Order 12333, which means the sum total of your privacy protection is the 4th Amendment as interpreted in secret by the executive branch, which is, to the extent FAA 702 seems a little lax, that may be a little laxer. Okay, thanks everyone. I'm not sure what the deal is with folks' stuff. If they have a place I can send them slides, I'll send them slides. I do. I think a version of this talk is on YouTube. I suppose I could put the PDF slides on. Yeah.
Seriously.
What is your website?
Oh, sure. I'm sorry?
Your website, what is it?
Oh, it's just firstname, Yeah. I wish I could get that copy. Oh.
Quick follow-up question. As far as the law goes, if you use less popular video conferencing program, like Obscure, does that make it safer?
So I think safer is all relative to what your threat model is. If your concern is you're getting investigated for something like,
do you have
I don't know, narcotics smuggling or something like that, right? At the end of the day, your door can get busted. So kind of to the extent you're a surveillance target, as a directed target, you're kind of out of luck with respect to preventing an intrusion. That's one of the very reasons we focused on the bulk programs. That there are things you can do, to be sure, using encrypted authenticated connections, using messaging services other than email. I think Chris from ACLU was planning to talk a little bit about this, if he hasn't already.
I don't know if you remember,
Yes.
but it used to be that if you talked on a cellular phone, you were more open to people listening. Does that hold any water now?
So with respect to phones, cellular phones, the encryption on them has generally not been great. At any rate, I think you could get a wiretap order out of the phone company. So, yeah, I guess I would not be super comfortable. I would not take the position that a cell phone is meaningfully more privacy protected than a laptop at this point.
Okay, thanks. Great talk.
Actually, I plugged mine in and unplugged yours already.
Oh, sorry. Yeah, go ahead.
I really like your talk. It's like my card.
Yeah, sure. Let me give you. I have a card in my bag over there.
But this isn't yours?
No, that was there when I.
It's
a public one. Yeah. Someone else. I got a question for you. Sure. I actually participated. I know you have
Playing audio on your laptop?
No.
All right, one person that has that number.
Yeah.
Owes money to somebody.
Okay.
Guess I'll just use yours instead of mine.
I tried to put it on do not call list. And then when they're blocking their number, so they can't put that. So what do we do? Is there anything we do?
Regrettably, that stuff is very tricky to do. Do much about. You might consider filing with the Federal Trade Commission. They have a website where you can go and provide information about companies you're asking you. Okay. In particular, if they're covered by the Fair Credit Reporting Act, there's certain requirements about not harassing folks. The Federal Trade Commission, FTC. Not the FTC.
I have to unplug it and put it in.
I think that is your best bet. Regrettably,
Okay, just
Yep. Yeah. So it's one of those unfortunate sets of issues that kind of falls through the cracks. Like it was sort of like identity theft was similar. You could set things up to deal with it.
What were there are two things you wanted me to mention in your intro.
Just that I've got a lot of experience with deep packet inspection technology. I created the first IPS.
Okay, yeah. We're good to go? All right. Testing 1, 2. Okay, cool. That sounds like it worked. Hi, everyone. Welcome to the X Keys Core talk. I'm introducing Rob Graham, who has done a lot of really interesting things. Two things he wanted me to mention were that he's done a lot of work with deep packet inspection, and you wrote the first IPS, you said? Is that correct? Yeah. So he's done a lot of work with this. And one of the things I want to emphasize, and this is not strictly related to H.O.P.E., but just in general, most of the response to all the NSA revelations that I have seen have been mostly legal and policy things, and is like really, really great to see somebody doing some technical analyses. So this is going to be really interesting for all those who are really interested in the technical juice. So with that, I'll hand it over to Rob. Thank you.
By the way, if you're looking in your printed program, there was a different talk scheduled for this time, and that was canceled. So they had me come on and to do an XKey score talk. So in case you're expecting one talk, this is going to be a completely different talk. What this talk is about recent X-key score code that has been released in the press.
I think some people don't know what X.key score is.
I'll be getting to that. Okay. So we're going to talk about that code. Well, I guess I can talk about it now. X-key score is sort of one of the biggest of the big brother programs in the NSA. It's they've got sensors throughout the world monitoring internet traffic and bringing all that data back to the Utah data center that we've seen in the news quite prominently. So when you're thinking about Big Brother NSA spying on me, outside of the context of phones and stuff, a lot of it is related to this X-key score system. So code was released recently on. Back in January, there was a code snippet released by the New York Times. They didn't mean to, but they did accidentally. They did the typical thing of putting a black box in a PDF over an image over the text, but the text is still there, so you just copy and paste and get the text. And then just a few weeks ago, some more code, a lot of code was released related to how this system is being used to spy on Tor. Who am I? As Aesthetic mentioned, is that I'm a long-time developer coder that's worked on deep packet inspection stuff. So technology that sniffs the internet and then extracts interesting data from that data. Also on my GitHub account, I have DPI projects there that packet sniffing things that extract data from network traffic that spies. You can use to spy on your home traffic and see what's there, in a way similar to the NSA. So this talk is in 4 parts. The first part, I'm going to talk a lot about X-key score and the NSA. The second part, I'm going to talk about deep packet inspection technology and how that works, how they get data out of packets. Then we're going to look at the code itself and walk through that code. It shouldn't be too onerous. I mean, none of us read X-key score code. It's not a language that anyone knows outside of the NSA. And then on the fourth part, we're going to talk about the fun stuff of how we can jam that system. So this is the Verizon memo that started off the whole Snowden revelations. This is the first thing revealed. This is the Verizon memo that said we want all phone metadata, whether it's landlines or cell phones. I would have leaked this. If I been in Snowden's position, I would have leaked this. And the reason I say this is because it marks me as sort of treasonous. It means that I can never get a clearance with the government ever again, admitting that I would have leaked this information. So who here also would like to mark themselves as treasonous and would have whistleblown this document? So none of you are getting clearance. The reason I bring that up is this next slide. A former NSA employee said this. People have unfairly demonized the NSA to a point that's too extreme. These are good people trying to do hard work for good reasons. How many people agree with this statement? Okay, leave your hand up if you know who said this. So this was said by Edward Snowden. About 3 weeks ago, he did an interview with the NBC, a TV station in the United States, and he said this. Because he's been on the inside of the NSA, he knows that they're not all evil people, that they are in fact good people doing good things for good reasons, nuclear proliferation, terrorism, that sort of stuff. And I bring this up to see the counterpoint, is that in the news we have this impression of the NSA because we've only seen one side of the argument. Every new Snowden declaration gives one side of what the NSA is doing wrong, and we've developed an impression that they're all powerful, they're all evil, they're all seeing, that they can do anything. And in reality, as I go through this technology, they actually have a lot of limitations. So how we see them sort of informs us to how we need to interpret code and technology and things. One example of this is the word collection. So as that Verizon memo said, they're collecting all of the phone metadata. But in their viewpoint, they're not. The NSA has a very narrow definition of the word collection. When they gather the phone metadata and put it into a database, no one has access to that. And since no one has access to it without a FISA court order, they're not technically collecting the data. So in their minds, they're not spying on Americans. They're just putting data into a database. And that's a very interesting thing, because when you talk to the NSA, they're not spying on Americans. No matter who you talk to at the NSA, they believe firmly they're not spying on Americans. But that's because they've sort of moved themselves into a corner of this perspective, we're not spying on Americans, even though, as we've seen in the other Snowden revelations, that they in fact are, depending upon how you define words like collection. One important concept is also tasking. A lot of our impression of the NSA is that they're just blanket spying on everything and gathering all the data. And in fact, while they're collecting data and putting it into databases, they're very rarely accessing it. NSA analysts have a very specific procedure they go through to go through that data, specify what they want, and then grasp it from the database. And it's all very bureaucratic and controlled and marked, who the analyst is, who their target is, why they're getting data, and so on. And we don't see that bureaucracy, we just see this blanket thing of them getting everything. Along with this is efficiency. Analysts have an efficiency rating. They have to get results. They just can't rummage through data for years on end and get no results. They actually need to get specifically to a target. So we're afraid of them spying on us and rummaging around. Actually, they don't want to rummage around because they're getting no results. There was a story about how the team after Osama bin Laden was reduced to 4 people because everyone who got on that team got no results for years and had their careers ruined, basically, by that search. So even the people who did find Osama bin Laden in the end, they still had to leave the NSA because their efficiency ratings could never be improved because they only found one guy after years of work. This picture here is from the THX 1138 movie, where they eventually give up on going after the hero of the movie because they're just over budget. And that's really a lot of what happens at the NSA. We have this fear that the NSA is a bunch of people, very smart people. In reality, they're successful because they've got money, they can solve things with this brute force, and they've got access. They can put network sensors grabbing data in the oddest places in the world, like on the bottom of the ocean floor. They've got their own submarine. They can drop to the bottom of the ocean floor and just put taps on subatlantic cables. Where they get their smarts is, by the way, is from us. When we give presentations at Black Hat on some new technique, they start using it. So we're actually the source of most of their smarts. An example of this is this recent revelation from the GCHQ, the British spies. One of the things they have here is Changeling, which allows them to spoof email sender addresses. How many people here have spoofed an email sender address? So yeah, that's not very smart. They also have another one where they do SSH through Tor. How many people have SSH through Tor? Fewer, but many of us. So a lot of what they're doing is not smart. There's one program that was recently announced called Boundless Informant. And all this program does is it monitors all the other programs to see how much data they're collecting. One interesting piece of information from this was 97 billion records per month. This is like March of 2013. They had 97 billion records. The top one is DNI, which means direct network interface, which means reading from internet links. The second one was the phone records, the dialed number, whatever it stands for. So 97 billion records per month. And where they're spying is also on this graph, which is kind of cool because we know that most of their attention is in the Mideast. You know, Iraq, Iran, Afghanistan, Pakistan, where their targets are. They're not really, you know, for all that we're afraid that they're targeting Americans, in reality we see where the sources of information are primarily where we expect them to be.
Why Greenland?
Pardon me?
Why Greenland?
Well, green means very little data. In this case, probably zero. I can't imagine there's much threat from Greenland. Dark green means very little sources. Lighter green means more data. Yellow means even more data. And then orange and red means lots and lots of data. Also that. So, for example, Libya, as you say, is fairly green. But it's someplace we do want to monitor, and that's probably just because there's just not a lot of internet in Libya. Also, by the way, it's kind of strange. They do a lot of satellite tapping. So the internet that is in Libya actually goes through like the United Arab Emirates instead of Libya because it goes up to a satellite and down. So where they're getting it is not actually from Libya, but it's Libyan traffic. So here's one of the slides released by Edward Snowden. And X-keyscore really is a user interface thing. Edward Snowden was at the top level, sort of the user of the system, rather than one of the low-level guys actually on a network link capturing the data. So X-keyscore, the way it works is it puts packet sniffer on network links to grab data. And at the low level here, we see three kinds. On the right, we see SSO site. That's special sources I don't know what it stands for. It means other partnerships, like the GCHQ or corporate partnerships like with AT&T. That's where they get the data. The foreign sat means satellite. That's where they've got things watching satellite links, which is a big deal because in a lot of parts of the world where there's no infrastructure, satellites is how they get communications. If there's a chief of a village, he's got a satellite receiver doing satellite internet that does internet for the entire village. And that's F6 HQS. That's where they get like a special forces team. They go into the desert, find a fiber optic link, and stick a monitor on it. So that's where all the evil monitoring that they don't want to get caught. That if they get caught, that's because something bad's happened. So this slide is a slide about Google Maps, about them getting data. But the key part of the slide is where I've got this arrow that a lot of these sensors, they stick out in the world to monitor traffic. They gather too much traffic that they can't pull back to their headquarters. So a lot of this whole X-keyscore system is about filtering data at the point of collection rather than pulling it all back to the database. So now I'm going to talk about deep packet inspection, because that's the technology they're using to monitor the internet. All it is just tapping in the network traffic. This is, I don't know if you guys have seen this before, it's the throwing star LAN tap, and you just plug it into a wire, and then plug in two more wires to then sniff everything going to and from. And it's a great debugging tool for your home network. These cost like $10 at hacker stores. And that's essentially what the NSA is doing. They got a wire, they've got a hub. They just hook in there and say, give me a copy of all the traffic. So this is what packets look like. This is a real packet. It looks kind of like random data as far as we can see looking at it. But it's like the Matrix. So in the scene in the Matrix, we had Cypher saying, hey, I don't see code here. What I see is that's a redhead, that's a blonde, and so on. And so we look at this packet, and all of these data, all these pieces of data in here mean something. For example, I've pulled out the IP address and the port number. So this is like https://74.125.196.128:443. So that's what this packet is. It's this packet, an SSL packet. I don't know how well you can read that. So we can take that entire packet and pull it apart field by field. What this packet was when the SSL server sends you the certificate. And every field in that packet means something. Every byte in that packet can be pulled apart. What we see here is a picture of a program called Wireshark. And it's what network technicians use to diagnose network errors. They stick it on the wire, tap into the network, capture the packets, and then decode the packets and analyze them. And what the decoder does, it means saying for every byte here on the right-hand side, we're going to say what it means on the left-hand side. Because really, we like to think we can read the hex, but we really can't. We just use decoders like this. But what this also is a deep packet inspection tool. Oh, by the way, I want to mention something about Wireshark. So all these bytes have meanings. I can tell Wireshark to take this SSL traffic and try to decode it as HTTP instead. And this is the result we get. It's an error. It can't decode it because the data suddenly becomes meaningless. And I use this to highlight that the data has meaning. It looks like gibberish to us, but it actually all means something. So what XKeyscore works is it's like TCP dump. TCP dump has this ring buffer mode where you set aside, say, hey, I want to do 100 files and each of a gigabyte in size, and just keep capturing into that buffer. When you run to the end, just start writing at the beginning again. So all you have is 100 files that are 1 gigabyte each. And that's mostly what XKeyscore is doing. They've got sniffers throughout the world on satellite links, on undersea cable links, in an Iraqi phone data center, capturing just on a server, just this nice little 3 days worth of data that just constantly always the last 3 days. And then what they do is they take all the deep packet inspection tools they have, and they use a lot of them. I've heard over 100. And they run them on this data. It could be Wireshark. Wireshark has a command line tool called T-Shark, which is really cool. I want to get into that. An IDS, intrusion detection system like Snort, can be used to post-process the data. They use commercial products like NetWitness. NetWitness has really cool tools for extracting files and stuff. Once they get the files, then they run those files, like images they downloaded via the web or sent via iPhone. They run those files through various parsers, like email parsers and image parsers, PDF parsers, and then grab as much data out of them as they can. And what they're looking for is not the content so much as we've seen in the Snowden revelations, but metadata. Like for image parsers, they want the GPS locations that might be attached to an image. So as an example here, I was going to use Snort, because that's an intrusion detection system. That's in which you run live and very similar to this. But I thought actually I'd focus on T-Shark. T-Shark is just a command line version of Wireshark. So what you saw in that GUI, it does on the command line. And what you can do in T-Shark is say, hey, pull out all the packets in this terabyte worth of data that satisfy one or more of these fields. So I can say, pull out all the packets where there's an X.509 certificate with the UTF-8 string of splat.google.com, and it'll pull out those packets. T-Shark is great because it's got tens of thousands of these fields just like this. So that the listing of the fields that you can choose is tens of thousands, because they decode every protocol under the sun. They decode everything. They're the most comprehensive deep packet inspection tool there is. Unfortunately, they're kind of slow, so you wouldn't actually attach this to a live network, but post-processing interesting data, it runs pretty well. I mention this because people have this idea that, we shouldn't release too much of the XKeyscore source code because it'll help other countries like do spying on their own people, and it's too powerful of a code, too smart of a code to be released to the public. And in reality, whatever XKeyscore is doing is less than T-Shark. They might have faster tools and stuff like that, but it's less than T-Shark. Just to reiterate, they have full capture systems like TCP dump, grabbing all the data, the last 3 days worth in a round robin. They extract data from it, metadata files, and that sort of thing. And then they pass the metadata up to their major databases. What we saw in that previous slide is that when an analyst needs to get some of that data, like they've targeted someone, it passes that string on down, go back here, and says something like, hey, I'm looking for a certain name, so every email target passes a little command like this and says, go grab that data. And then it'll go post-process that 3 days worth of data, go grab all those emails and send them back to the analyst. But mostly all the traffic remains on the sensor and then just drops off after 3 days. There's also not just the analyst to grab this data, but also automated systems. It starts from an analyst setting a tasking to say, hey, I've got this automated system that's going to do these steps. Like wait for that guy to log on and then try to send him a hostile PDF exploit. And that's where the TAO attacks come from. Okay, so let's look at the source code. This is the source code that was released on January of this year inadvertently by the New York Times. There's a lot of chunks here, so I'm going to sort of pare it down to the essentials. So at its essential, what it's doing is it's saying, I've got a fingerprint, I've got a file. I don't know what's in the file yet. But I'm going to test that file extension, just like the T-SORC expressions work, whether it has JPEG on the end. And if it does, I'm going to add the metadata to the file, and in this my little example here, saying picture. So that when an analyst needs to task the system and say, hey, show me all pictures that were taken from Iraq, they've got this metadata that can satisfy the query. Now this thing was a little bit more complicated. What it wanted to market was not just simply as an image, but an image that has GPS locations in it. So therefore the expression grows. So not only trigger when it has a JPEG file extension, but also when it has this EXIF information. The EXIF information is what's attached. Every time you snap a picture with your iPhone, it attaches your GPS latitude and longitude to it. And it's a feature that JPEGs have. By the way, it's not a feature that GIFs have. So you see in this thing where they've added GIF as a file extension, it doesn't work. It'll never happen. So that's one thing we find with this X keyscore code is there's lots of bugs in it. Bugs that don't stop it from working, but which we can just say, hey, you can take that GIF out and it'll make no difference.
Does that go by extension or by file signature?
That's a good question. So there's three ways we can recognize what a file contains. By its extension in the file name, like .jpeg. The content type, when it's downloaded via HTTP, it has a content type associated with it. Or by looking at the first few characters of a file name, it says, well, it can only be a JPEG, or only can be a GIF. And this code says file extension, which is the worst and stupidest way to do it. Which means either they really are that stupid and they're just doing file extension, or they've got some other thing in the pipeline before this that marked the file as that, hey, it was downloaded via a content type of JPEG, so we're going to put a file extension JPEG on it, so that then later things can trigger off of a file extension. So, I don't know. One thing to notice about this is that there's also another bug here, is it says the first condition and the second condition or the third condition. And people laugh because they know that's a bug. Because most languages would interpret it, and has a better precedence here. So it says either it has latitude and is a file extension JPEG, or it has longitude, is how most programming languages interpret this. But that probably doesn't matter because it's not going to have that property of GPS longitude if it's not a JPEG in the first place. So we could probably just take the whole test of whether it's a JPEG out of it to begin with. Yeah. And that's the thing is we look at this and this is like one signature that was inadvertently done by the New York Times, and we have questions about, okay, the operator precedence is wrong, they're using GIF files here, it looks like they're doing the lamest thing of just the file extension, so we've got three problems with only one signature. Okay. That's one theory. Yeah, Snowden really is just, he's a plant. Just to convince us of that. No, but it actually is true that the stuff that they put in these Stone documents, most of these documents were the presentations for the intelligence community. So they're not putting in their smartest code, they're often in these presentations putting in examples or samples and not real code. So there could be reasons why it's dumb code that maybe the code they put actually out in the real world might be smarter. A couple weeks ago, there was a story in a German radio website that talked about how they showed all the source code targeting Tor. And so here's one of the first things where it's saying, hey, we want to mark this. Again, this fingerprint thing is just extracting metadata. We actually don't know where that goes. Does it go to an automatic targeting system that tries to automatically hack anyone who uses Tor? Or is there an analyst out there who's specifically at this moment looking for Tor, and that's why this exists? Or is it Tor and other conditions we can't see in this source code, but which happens in the whole process? Like, I want all access to Tor from Libya. Maybe that's his query. So we don't see the whole picture here. Also, what we see is that in this code that was released, there's lots of missing pieces. We see this variable name, Tor authority, that's nowhere defined in the code. So we don't know where the Tor authority is. We know in practice which servers they're talking about, but we don't know how they've defined that variable. So again, the purpose of this is just to say, hey, I need to mark all TCP sessions that go to and from a Tor node authority, and I'm going to mark it with this metadata, so I can then query on it later. Another signature was this one, is they want to find all the Tor bridges. And this one worked by decoding the SSL certificate. And what we see here is it's looking for the X.509 subject name, the DNS names within certificates, SSL certificates. So as soon as you connect to an SSL server, you see the certificate. And I mentioned this because that's very similar to the T-Shark signatures I showed you before, where T-Shark can pull all this information out. So in fact, they may be using T-Shark as the underlying thing that services this. That they just send these, wrap them up in the T-Shark signatures, and then that's how it's done. They had a more complicated signature, and so this is sort of the outer portion of that signature, where it looks for emails. One of the ways you can get Tor bridges. Oh, by the way, let me talk about what Tor bridges are. We have all the public Tor servers out there, the Tor nodes out there, but those are all banned a lot in countries. So in Great Firewall, China and stuff just has that list in there of all the public servers and bans them or something. So if you're an activist or a dissident in one of these countries, you want a secret server, a server that is a Tor node, but which is not generally known to the public as being a Tor node. So you go to this bridges at torproject.org, and they'll send you an email that says what those bridges, it'll give you 5 bridges that you can use that are not known to the public. And everyone who sends them an email gets a different list of 5 bridges. So what this signature is looking for is, I want to scan all the emails that I'm getting collecting on my data, and I want to scan them and grab all those lists so that me as the intelligence operative can get my own list of all the public Tor bridges. And so that's what this fingerprint starts with. It says, okay, the email address from bridges at torproject.org, and somewhere in the email body is the string Tor bridges. And then, that we see here, is going to shell out to C++ code, which means whatever system is running, it's now going to run some C++. And what's in that C++ code is, I'm missing something here. Okay, I'm missing something, so I'm going to go out here to okay, what we see here is the regular expression. So it takes an email message and runs what's called a regular expression. And that's this bit right here. And that's just matching that string of bridges, space, IP address, colon, port number. And that's all of this complicated regex is doing. I'm going to talk more about this regex in a bit, but so I just want to make sure you see the regex. So that regex then causes C code to be executed. That regex has these things called captures, when you put a parentheses and a regular expression to grab everything between that, the parentheses. So it grabbed an IP and a port number. And what we see here in this code is that it takes that data and sticks it directly into a database. So until this point, we've been using APIs that fingerprinting, like fingerprinting an email, causes metadata to be attached to that email. So that email can then be queried and pulled up by an analyst. And there's always the source and destination of where the email came from, who that email is from and to. All that information was included with all that metadata, and it wasn't lost. So that if later an auditor comes in and says, was that email you captured an American citizen, they've got the full trail of where that email came from. They know where it was captured, like, okay, this was in Iraq, it was sent to this guy, it was sent from that guy, and so on. But what we see here in this C++ code is they're extracting data, putting it into a database, losing all of that context. So later on, if someone says, where'd you get that bridge information? They don't know. We got it from monitoring the network. We don't know where it came from or whose emails we monitored. Was it an American citizen or not? We don't know. So this is one of two things. When I saw this in the source code, I had one of two thoughts. The first thought is, potentially, the NSA is breaking the law here. That it's something so technical that no FISA court auditor will ever notice that they're actually breaking the law and getting data without knowing who it came from. Or maybe the source code that they got is not NSA source code at all. As I said before, the NSA works with partners. Their biggest partner is the GCHQ, the British spies. Well, they don't have quite the requirements we have for monitoring their own citizens. They don't have quite the whole infrastructure for knowing where data came from. So those guys have the ability to do a signature like this and send it down to their systems that they control of just grabbing data and saving it and not knowing who it came from. So either the NSA is breaking the law, or the American law, or it's one of the partner systems. Is that a question?
So basically, GCHQ can be providing NSA with the up-to-date brief.
Right. That may be a product that they give to the NSA. The NSA just says, hands off, we don't know where the data came from, we don't care. The GCHQ gave it to us. That's also possible. For the contractors, the systems those contractors control. Right, they can get the data and resolve themselves and do an end run. But they're not getting if they're getting it from their own sensors, they're breaking the law. If they're getting it from the GCHQ, they're not. Also, another weird thing to notice is that this C code has that API string XKS : when it fires the fingerprint. That XKS is so deeply in the code seems kind of weird, because X-keyscore is the project name for what the users see on top, not all the hundreds of disparate systems down below. So it's kind of strange to see it this low in the whole stack. So they had some other strings. Here's another misspelling, Tor project that they misspelled with a note missing an R there, or a second R. But one thing about the signature is kind of interesting is it does show that there's still care about where data comes from. So whoever wrote these signatures do care that there's a different set of rules for the 5 English-speaking countries and everyone else. So whatever rules they're breaking, we still see in the code everywhere that they're still trying to follow some sense of the rules. The big story from that German story was that it was calling people who use Tor and Tor websites as extremists, and that's kind of a misreading of what we see in the code. So here's a comment that say that Tails, a version of Tor that runs on its own USB drive, is advocated by extremists on extremist forums. And a lot of people have interpreted that as meaning the reverse, that all people who use Tails are extremists. And that's not what this comment says. It just says extremists use Tails. And which is, by the way, true. If you go onto jihadi forums like ISIS, the Islamic Caliphate now in Iraq, they recommend using Tor and Tails. You go into their forums and they recommend it. So just because they use it just because those guys advocate using it doesn't mean that everyone who uses Tor and Tails is an extremist. And that's not what the code says either. Is the code is triggering on things like Linux Journal and the Tails website, which you see in these strings, but it's not labeling those forums as being extremist forums. They're saying extremist forums go to these websites in order to download Tails. And that's what we see in the code. So that big story it has, again, is this one-sided story that kind of, and we see in that German news story, they take one-sided of it and don't kind of take the opposing side, that maybe that's not what the code says. There was another thing, just like the bridges, it would pull out onion addresses. Again, onion addresses are not publicly known. Unless someone gives you their unique 16-byte code, you can't access their website. So this, again, it uses a regex to grab it. And one thing I wanted to focus on that regex is that both this regex and the one that grabbed the bridge information, they both optionally grabbed the port number when it was in the string. And they did so in two completely different ways. So you see the snippets from the regexes. The first one is from this one, grabbing the onion addresses, and the second one is grabbing the port number when it's a bridge address. There's no reason for these to be different. It's just that regex is such an ugly, terrible, nasty language. Like, just look at it. It's awful. That everyone does it slightly differently, which means you can often fingerprint the author and know who wrote these regexes just by they have a very distinctive style. So we know, for example, that two different people wrote these regexes. Now, there may be reasons for it, like they actually didn't write the regex themselves. They just copied off of an internet forum that was talking about capturing onion addresses, and they just copied it into their NSA rules. So it may not be the NSA person himself who wrote it, but that's an interesting thing to note about these regexes. They also have bugs, by the way. All these regexes have a bunch of bugs. Like this first one here, grabbing the port number, the second one. What that regex says is also grab as part of the port number the first character after the port number. So that when you see this in the database, it always has additional characters that are not part of the number. Also, it's 2 to 4 characters. So a port number with 1 byte, like 0 through 9, doesn't get captured, or a larger port number like 30,000 doesn't get captured because that's got 5 digits. So again, we see bugs up and down throughout this code. And then what it does with the port number is it puts it up into a Google protocol buffer. Google created this way of creating easy protocols called protocol buffers. It's kind of a weird, stupid name. But part of what this shows is that the NSA is just grabbing what everyone else is doing in the community. Oh, Google has this new thing called protobuffers. Well, we'll use protobuffers in our code. It satisfies our needs. Or the whole map reduce paradigm, or everything that we would do to create this is just what they're doing. They're not doing anything special other than what we would be doing. And again, what it does with the onion addresses, again, it just sticks them to the database, losing all source of where those things came from. Again, being maybe a product that GCHQ provides to the NSA or something. So now let's talk about jamming the system. Now, most of what we talk about for the NSA is about evading them by encrypting our stuff so they can't see it. But it'd be really fun is to attack them and do nasty things to them. For example, one of those signatures was looking for Tails plus USB within Google searches. Well, what I can do on my website is I can put an image tag that's not normally seen by the users, but which goes out to the Google search URL and causes a search to happen for Tails plus USB. What that means is now their database is now filled up with people throughout the world doing this search. And no one knows they're doing it. It's now the Google or the NSA analyst who is looking for this information, who's searching for Tails on USB, has now been flooded with data. Their databases probably have maybe filled up on some of their sensors, and now they can't process the data. Now their efficiency is going way down, and their boss is saying, hey, you haven't produced us any results in the last month. What's going on? Do I need to demote you? And so they say, okay, I'm going to remove this from my searches because it's just too much noise. So one thing is with Tor is the Tor right now runs as a separate service. It uses SSL, so it looks very much like a web server, but it's not a web server. Well, let's make it a web server. Let's make it so that our own web servers on our own websites actually have just a Tor as sort of an Apache plugin. And now the NSA can't differentiate between people using Tor, which looks like SSL, but I really know it's not. It's really easy for me to tell. Well, now I see a website traffic. So I see normal website traffic as well as these long-term sessions that last for 15 minutes before they end. So it becomes very hard, once we make our traffic look like other good traffic, it becomes very hard for those deep packet inspection tools to tell the difference between one and the other. That bridges thing, well, if that's what they're doing today, well, we can just start exchanging clear text emails with each other with just a million bridge addresses in them. Just start with like 001, 002, 003. So then they've got a database sensor that's maybe running on a low-end computer in Iraq or something, and now that the whole system floods up, the whole database fills up with invalid bridge numbers. And of course, we can do the same thing with the onion addresses. That regex had a bug that it's looking for HTTP and HTTPS, but really what's capturing is just any number of letters, alphanumeric characters, or alpha characters. So we could put any string we want there instead of HTTP, like something else. That could be not only a message for the analyst, but also we could put 1,000 characters here or 1,000,000 characters here, and technically it would be matched by the regular expression, which can destabilize the system and bring it down before it's able to actually build a list of onion addresses. One of the things I've been doing recently for the last year is a project called MassScan, which I've been using to scan the entire internet. On an appropriately fast link, it will scan all 4 billion IP addresses in an hour. So deep packet inspection code hates two things. They hate lots of small packets because there's lots of overhead per packet. So when the network traffic consists of small packets rather than large packets, they get really unhappy. Second of all, they don't like lots of concurrent connections. They're built for maybe 100,000 concurrent connections. And that's a lot for most of their tools. Running MassScan, you can generate billions. And so I've heard through the grapevine that this has indeed happened, is that they've had sensors go down because I run MassScan and scan the entire internet. So I've heard through the grapevine that indeed they've had sensors go down. They've had to write rules for the IP addresses that I do MassScan from to say don't capture that data. Which, by the way, makes me feel really, really good. I mean, for most people to say, oh yeah, the NSA has like added your IP addresses to their system. Like, that would scare most people, but for me, of course, it's quite the opposite. We can do this with normal tools too. Like BitTorrent has this peer-to-peer tracker service over UDP that runs in the background and exchange. So it's a trackerless system, so that we all exchange in peer-to-peer where the tracking information is from, rather than having servers. This generates a lot of connections. So when you run this on your laptop, it just generates lots of connection records. And so if someone's trying to monitor you, their database fills up with connections. Bitcoin wallets have the same property, because you talk to eventually every other Bitcoin wallet in the world. And so now you have lots of connections, and you got the connectivity graph, and it destroys an analyst's ability to be efficient in trying to track down who are you actually talking to. One cool thing, so there was that signature that looks for the bridge.torproject.org within X.509 certificates. Well, okay, let's all set up, run Apache on a random port, like 1, 2, 3, 4, 5, and just create a self-signed certificate claiming to be a bridge at torproject.org, and just put it on the network, and then put like a little image tag within one of our HTML files, and cause people to download that certificate, cause it to go buy a sensor, pulling out that information. So again, we'll cause the database to fill up. So we can use that principle. Anything we think the NSA might be tracking, we'll just start doing it on our websites and causing their tracking system to become very inefficient. There's this tool from, I think maybe it's Moxie Marlinspike, I forget who does it, called googlesharing.net. And what that tool does is when you do a search in this tool, instead of doing a search via your cookies, it sends a search to some other user of this product doing that search from their cookies. So if you want to do like ricin or bombs or something, it'll be searching using other people's cookies. And likewise, their searches will go through your system. And that will then totally disrupt trying to track down which people are doing which searches. But I think we need to do more projects like that, where we would do something of like, let's just take our whole search history and just start exchanging it with each other. And just causing in the background those searches to happen on Google. So that eventually every one of us has done all the searches that everyone else here has done, making the whole search thing just make it go bonkers. We can also do the same thing with a cell phone. Imagine a nice little Android app that communicates over the internet with each other, and then during the night, for most people have free minutes during the night and weekends, you just put your phone into roulette mode, and then they just start calling each other. And you also turn off your speaker so you don't hear it, so you can go to sleep. But then we have metadata of all of us are calling everyone else. And now it becomes really hard for the metadata systems to pull out who actually are you calling. So the more that we exchange metadata and contact each other in the background, the less they can actually say for real who are we really contacting. So we're all kind of afraid of being that 3 hops away from a terrorist, but actually when we're all 3 hops away from everyone else, the whole hops idea just drives down the NSA's efficiency and they can't really do much. And then finally, there's exploitation. I know that they're using open source tools. I know they're using Snort somewhere in the system. I know they're using T-Shark somewhere. I know for every deep packet inspection tool that exists, the NSA is probably trying to use it somewhere. Wireshark in particular has just buffer overflow bugs at the yin yang. Just go pick a random protocol, search for a bug, and you'll find one. So if we just start grabbing bugs and just knowing that what the source systems they have are probably x86 systems running Linux, running these tools, we'll just start finding ODays in them and then running exploits for them. That the exploits go off and like delete everything on the system. And that will drive their efficiency way down. So that's my talk. Any questions? You can come up here.
So first off, thank you very much for that talk. I really enjoyed it. So it seems to me like within file formats, there's all this discussion on metadata, and the way that we store metadata within files is kind of finicky, and I could very easily change the way that it's stored as long as I have a program, say, on my side and my recipient side that can understand that the protocol that's being used. So if you can change the protocol that easily to basically thwart these detections, can I draw conclusions about that, either about from that idea, either about how the NSA operates or about how the people the NSA is targeting operate?
Well, one thing is that protocols have a very wide range of what's accepted, which means that you can encode your metadata one way that normal programs will read that metadata, but which may no longer be extractable by the NSA. So I can maybe encode it so that other image programs can read, like Photoshop can still read my EXIF GPS locations, but I've done something that most tools that the NSA is using cannot. Just look on the open source tools that grab that data, say, hey, there's a bug here, or it's more limited, I encode it this way, I can evade it. But the rest of your question, I don't really know how to answer. Question?
Two really quick questions. What's your background?
Back in 1998, I wrote the first IPS. I wrote a suite of tools all based on intrusion detection technology called Black Ice. And it's deep packet inspection. Decodes a lot of protocols looking for intrusions and was like that. And in 2007, I did sitejacking, which was deep packet inspection to grab cookies and then put them into your browser so that you can like hijack people's connections without knowing their password. And then recently, I've got code up on my GitHub that does deep packet inspection.
And the second question, what ISP do you use that doesn't carry your path scanning the whole web?
That's a frequent question. And we work. The company is called CarryNet, which you can just do reverse. Look in your logs, see me scanning, and find out. But we work closely with them. So we've got our own little swipe, little 8 address range that gets the abuse complaints back to us. Everyone who asks, we put into our exclude files so we won't scan them again. So we work closely with them to avoid any disruption. But by the way, back to mass scanning, H.O.P.E has a 10 gigabit uplink to the internet, which means just go grab an Ethernet cable, go to one of their hubs, sit down there, and just run mass scan. It runs on all platforms, and just compile it, run it, start scanning the internet yourself with the H.O.P.E traffic. And you can like scan the whole internet in an hour with a proper gigabit adapter in your notebook. And they would love it because they want to fill up that 10 gigabit pipe, and you're going to love it because you're anonymous. The NSA is going to hate it because if they're monitoring this traffic at all, they're not going to see, suddenly all their sensors go blind because they fill up with the connection table limits that get exceeded and they just barf. One of the address ranges they have is actually a Netherlands address. So the NSA is probably not looking at H.O.P.E from maybe the FBI is, but not the NSA, on the American address ranges. But the ones that are actually officially assigned to Netherlands, they might be monitoring. So you can cause them lots of headache if you just go downstairs and hook into the hub and start scanning. Any other questions?
Do you know if they're pipelining any of their raw feeds to other products, basically, like sandbox? Yeah.
Right. The question is whether they're pipelining that data also to other products. And the answer is yes. So I sort of talk about this as if everything's key score, but in reality it's not. There's metadata heading towards the Marina project, and analysts put stuff in Pinwheel. It just goes all over the place.
So what degree of content analysis do you think is really going on for metadata?
So I think it's what they're looking for is things like show me all. An analyst will say something like show me all images where the GPS locations are in Mosul, which was recently taken over by the Islamic Caliphate. So they want to know something about that. So they say, hey, maybe there was a missile launcher in the Ukraine. So I know where that missile launcher was. Well, show me all images I intercepted from the Ukraine with a GPS location around where that missile launcher was, maybe the 1 mile radius, in the last 3 days.
You don't necessarily think there's a lot of automated surveillance going on with content, though. You think there's more metadata?
I think, it's mostly metadata, but of course, some smart guy says, hey, I know if I do this, this, and this with facial recognition, I'm able to throw things into a smarter system. But the smarter systems take a lot more compute power. So they can't grab every image and throw it through a facial recognition database. What they can say is we'll grab maybe GPS data, narrow it down via the metadata, and then just pass the small feeds up to Utah for more extensive processing or something.
I'm also curious if you run across some more information on what kind of hardware they are running.
From what I hear is they run everything, including Raspberry Pis. So when they break into a data center, they want to monitor phones a lot. So they're going to hack into someone's data center. They're just going to use the hardware that's available. Oh, there's this old decommissioned system that's still plugged into the network. Well, let's recommission it. And so they're using some old piece of hardware. Any more questions? There's one in the back. Did you raise your hand? Oh. Okay, I guess that's it. Thank you very much. You just go to my website, blog.erratasec.com. It's got some blog posts on this.
Good talk.
Thank you.
Yeah. Coming to DEF CON?
Yeah.
I'll see you there.
Erratasec.com, ERRATA, SEC.com. The blog that links to stuff.
Thank you.
Yeah. Thanks. Let me make sure I've got my phone.
Well, this was supposed to be.
You have a
Are you playing any audio from your laptop? Awesome. All right, then this VGA. Cool. So just plug in right here. That's one, and if you decide to
Oh, it doesn't. Oh, it doesn't.
yeah, if you decided to have a new power plug in.
Oh yeah, I do.
Right here.
I definitely do. It's an old machine. The battery sucks.
ThinkPad.
Yeah, nice and small.
Yeah. I have the other one, the huge one. Got the model. One of the first ones.
Thank you. Excellent. Yep. Yeah, I wonder if I'm the only one to actually use a PDF file rather than a PowerPoint. Sumatra PDF. Those Windows people. I have not given this presentation before. I have over 80 slides, so I have actually no clue when I'm going to be finished. Well, I do know I'm going to be finished at 3:55, but I have no clue at what slide number I'm going to be. And I mention that because there's a copy of the slides on my personal website, michaelhorowitz.com. I'm not going to forget when 3:55 is, but I have no clue where I'm going to be. Well, it's a lot nicer here at H.O.P.E. today compared to yesterday. Those of you who were here yesterday, it looks like the subway at rush hour. All right, 2:59, we'll give it a go. My name is Michael Horowitz. Oh, that. This is actually the worst room because the noise leaks from the Manning room next door. So I should have realized that. My name is Michael Horowitz. I've been blogging about defensive computing for a very long time. The URL for my blog is kind of long, but it's aliased at defensivecomputing.info.
There it is on Computer World. Used to blog on defensive computing for CNET years back. And again, for those of you who didn't hear it because I wasn't talking into the microphone, the full handout here is available in PDF format at my personal site, because chances are I'm not going to hit slide number 81 by the time we're done. Level set, I'm going to skip level setting because this is H.O.P.E. The only thing I'm going to say about level setting is about firmware, which is the operating system for a router. One thing that's been kind of encouraging is that here at H.O.P.E. the last 2 days, I've run across 3 new router firmwares. The EFF is creating a brand new firmware based on OpenWRT. Looks like it'll be good. It's not ready yet. Who knows what it'll be like in 6 months or a year. And a couple others here. There was the first day there was a talk at 11 p.m. about travel routers. A couple biker dudes. They're working on a new router with new firmware, and that sounds like it's going to be great, but I have no idea when it's going to be available. All right, we'll skip this because it's H.O.P.E. Okay, routers make a great target. I realize in saying this that I am preaching to the choir because everyone came here for a talk about routers. This was back in September 2013. Everyone here at H.O.P.E. has to make a mandatory reference to Edward Snowden. So this came from these Snowden revelations back in September of last year. NSA, but of course, why do you want to hack a router? Obviously, it sits in between all your internet conversations. You hack one device, you get access to a lot of different devices. Greenwald, when his book came out last May, he gave some more details about how the NSA hacks routers. And this is perhaps the iconic image, the image that will be remembered 30 years from now. This came from Glenn Greenwald. And this shows the NSA intercepting a Cisco router from the post office, opening up the box, and they're going to close up the box and send it to some poor victim. And of course, back in May, needless to say, the Chinese didn't want any of our routers. And that's not news because this was back from October 2012, where the United States didn't want any routers from China either. So routers have been a target for a long, long time. A compromised router, what can it do? The obvious thing, it can spy on you. The not so obvious thing, of course, is man-in-the-middle attacks and read all your secure SSL TLS traffic. A number of speakers here have mentioned Moxie Marlin Spike's SSL strip. That's child's play, because that is detected by fairly easily. But there are boxes that you can buy. This came out a couple of years ago. It was a big scandal. You can buy boxes that will dynamically generate literally valid certificates on the fly. So there's really no way for you to know if your SSL traffic is being watched. Obviously, compromised router, alter non-encrypted data, that's pretty easy. And the other thing is send you to evil twin websites. This really doesn't get a lot of attention. Evil twin, of course, people here know it refers to Wi-Fi networks. But if you ran the NSA, what would you do, assuming you were competent and intelligent? You'd go after Tails. Everyone here, probably most people here know what Tails is. It's a Linux distribution that sends all the output through Tor. If you have any reason for privacy, Tails is the best way to go. You cannot make a mistake. That whole Tor bundle thing is ridiculous. If you want privacy, you go to Tails. You can't make a mistake. If you're in Tails, everything goes through Tor. So, of course, if you ran a spy agency, you would love to have people download a compromised version of Tails. And how would you do that? You'd infect the router, and you'd send them to a scam copy of tails.baum.org, a spy agency-created copy of it. They download Tails, and they get a copy of Tails with a backdoor. And, of course, there's a lot of protection information at tails.baum.com. Here it says how to verify the ISO image. Well, that's chapter 3 of the book. The first chapter is, are you really at tails.baum.org? Because if you're at a spy agency copy of the website, they'll, of course, have their own instructions here. And here, there's all sorts of warnings about running Tails. And these are very valid warnings about things that can go wrong, what have you. But this all assumes that you're at the real tails.baum.org. Nowhere here do they say, the software you're downloading may have a backdoor in it because this is not the real website. How do you actually redirect someone to an evil website if you're in control of the router? The most obvious one is malicious DNS servers. You simply change the DNS resolution instead of the real. Now, of course, I don't know if that's the real IP address. I checked this a couple months ago. How are we going to know? Nowhere at the tails of does anyone here know who runs that website? Does anyone know where it is? I looked back in May, it seemed to be in Seattle, but I don't know. There are a couple other ways that a malicious router could send you to an evil twin website. In the interest of time, I will skip those. So the best thing you can do, of course, as far as your router goes, is be a lesser target. Spy agencies, of course, can get into Cisco and Juniper. At least twice that I know of, the Cisco firmware, source code for Cisco firmware has been stolen. Not to mention the iconic picture that Glenn Greenwald gave us a few months ago. And of course, on the home front, they. Now, by they, that was a bad term. By they, I mean either spy agencies or just your average bad guys. They're going to go after the most popular routers. That's why Windows is attacked, because most people use it. If a router is sold at Best Buy, you don't want to buy it. If there's anything you remember out of this talk, it's that one sentence. That is the most important sentence I'm going to say in the next 55 minutes. The other is that if your router is given to you by your internet service provider, you don't want to use it either, because they give away millions of them, and that makes them a prime target both for spy agencies and bad guys. If you were given a single box, which most people I think call a gateway, which is a combination modem and router, you should be able to contact your ISP and have them dumb down the box so that it acts as just a modem, and then you can add your own router to it. I know I've done that with Time Warner. Can anyone here confirm that other ISPs will do that too? Comcast doesn't? I've read, regarding Comcast Xfinity Wi-Fi system, I have heard people say that they will do that. Well, but it's only functioning as a modem. Enough. Yeah. Better than nothing, yeah. Okay, how do you configure a router? There's a million different ways. Most of us who've done it do it with the internal administrator website. Needless to say, there are more smartphone apps coming all the time. Who has them? Netgear and Linksys have smartphone apps at the moment. Cloud management via vendor websites. This is a really bad idea. If your router offers that, I would not do it, because now you're trusting another person in between you and your router. Cablevision. Cablevision offers that, as does Linksys. If you've heard of Cisco's Cloud Connect, that's letting Cisco's website get into your router. I just don't like that idea at all. And of course, Apple, UPnP, we're going to talk about a lot more. Telnet and SSH, if you see those in configuration options in a router, you kind of want to turn those off. If you're going to use the administrative website, the internal website in the router, the first thing you need to know is what's the IP address of the router. Probably everyone here can figure that out. But those of you who can't, I blogged about this in September 2013, covers all the popular operating systems. Any article about securing a router is going to say these obvious things: change your router password and update the router firmware. About the firmware, a couple things to say. You think it's a pretty boring topic. Of course, you have to update the router firmware. First of all, the routers, the way they handle this varies. Some do absolutely nothing. Some offer you a little manual check. You can go online, check a box, is there new firmware? Some routers may check on their own. So as soon as you log on, there may be a blinking thing that says, hey, there's new firmware here. One router, I can't remember which one it was, would actually send you an email when there was new firmware. Anyone know who that is? Has anyone seen that in any other routers? Linksys does it? I can't, it's been too long, I can't remember who does it. Self-update automatically, I don't know really the routers that do that. I've seen that Verizon's Action Tech kind of says it can do it, I haven't tested it. One thing I will say about the new software coming from the EFF, they promise that it will self-update and it will update itself through Tor, which if they really get that out the door, that would be a great thing. Okay, a lot of people don't update firmware in the routers because this really should not say new firmware is risky. That kind of goes without saying. These are defensive steps you can take if you're updating the firmware so that you don't get screwed. But of course, a lot of people don't update the firmware simply because it's too dangerous. Your internet access is too important. Having a spare router, I know someone who has a spare router. I gave someone a new router, all configured, and he had an old router. All he has to do is swap the two routers. If there's anything wrong with the new one, no big deal. You unplug it, you put the old one back. Still too afraid to do it. Internet access is obviously very important to a lot of people. So here's a step up in class. This is a company called P.E.P. Link. P.E.P. Wave is a small division from them. And this is a safe way that you can update firmware. You notice here at the bottom, this router keeps 2 copies of the firmware. So you can, on a Tuesday, download the new firmware and then not use it. You can continue running the router. Come Saturday, when the internet access is not all that important, you boot the new firmware, run it for a while. If there's no problems, keep it. If there's any problems, you reboot and back up and run the older firmware. Does anybody else know other routers under $1,000 that offer you multiple firmwares for cheap? Excuse me? The Netgear. And do you have any idea roughly how much those cost? 500? Okay, let me say a few words about P.E.P. Link. I know it says P.E.P. Wave on the thing. That's like a small division within the company. The company is called P.E.P. Link, and their website is peplink.com. I do not work for them. But what P.E.P. Link is a professionally run router company. And within that category, of course, there's thousands of professionally run router companies, but they offer something that's actually cheap. This thing in the picture, this router, was $130. And it offers you dual firmware. On top of that, most routers are sold to consumers based on 3 things: the number of features, how fast it is, and how much it costs. P.E.P. Link does not compete on any one of those things. They do not sell to consumers. They're a business class. The reason they're in business is they're a multi-WAN router company. That's what they specialize in. Your internet access is really important. You do not have one internet service provider. You have 2 or 3 or 4. And if you have 3 internet connections and one of them fails, you want to be connected to a P.E.P. Link router, because that's what they do. They round robin across multiple ISPs, and if one of those ISPs fails, you don't know, you don't care, your network keeps chugging. That's their claim to fame. That's their business model. That's what they do. They do not sell based on price. They do not sell based on features. They do not sell based on speed. Until roughly a year and a half ago, their cheapest router was $300 that supplied 2 ISPs and no Wi-Fi at all. This router, which is $130 without the Wi-Fi antennas, they have internal antennas. If you need better Wi-Fi performance, they'll sell you external antennas. That bumps the price up to $160. This has slow Ethernet connections. These are not gigabit Ethernet ports. This is not a dual band router. It does 1 band at a time. It can do 5 gigahertz, but if you set it for 5 gigahertz, it's not going to do 2.4. They are not selling based on features here. You cannot plug a USB flash drive in here and have it share on your LAN. This is a business class company, and yet you can get something like that for $130. It's a big step up from Asus and Belkin and D-Link and the like. Yes. It's really impressive if you have multiple ISPs, the way it load balances across. On their cheap stuff, which is under $1,000, I think there's 5 different algorithms you can choose for load balancing. On their really expensive stuff, with your few $1,000s, there's like 9 different algorithms for how they load balance. Yeah, that's what they do. That's what they do for a living. Yeah, if you want fast connections within your LAN, yeah, you can hook a gigabit switch into it. But that cheap router for $130, yeah, that has the slower 100 speed Ethernet. Just peplink.com. There are very few dealers for them. Yeah, but they're all at peplink.com. SSID, there really isn't too much to say about it securely. The most important thing is, of course, you change the default. And the other important thing is you don't give away any personal information. This is one of my favorite SSIDs. Obviously, some techie set it up for his mother. Oh, it says, Mom, click here for internet. That is the SSID. So yeah, if you live in an apartment building, you live in apartment 3G, don't call your SSID apartment 3G, call it apartment 5F. When it comes here to the 2.4 gigahertz versus 5 gigahertz, everyone in the world will tell you use 5 gigahertz bands, it's faster, there's less interference, but there's also a security aspect to it. The 5 gigahertz band does not travel as far as the 2.4 gigahertz band. So if there is some bad guy who in your neighborhood a block or two away, he might see your 2.4 gigahertz network, but he might not see your 5 gigahertz network. So it's a small security thing, but if you can, you want to consider turning off 2.4 gigahertz. It just leaks a little bit less. Excuse me? Oh, that's true, yes. For some routers, you can crank the power down so that the teenager across the street doesn't see your network. Okay, this is the most obvious stuff. What's not so obvious is even if you do WPA2, some routers are going to ask you a question after you choose WPA2. The right answer is AES, the right answer is CCMP, the wrong answer is TKIP. Some routers do not have an option to do just WPA2 only, and this is, Peplink's not perfect, I don't work for them. This is the worst thing about that Peplink router, is the only choice they offer you is combination WPA and WPA2. You cannot lock out WPA from their Wi-Fi. And it's $130. Now, WPA2, of course, needs a very, very long password. Another point, frequently when this topic is embraced in the media, people skip over the long passwords. Now, let's be honest, how long a password do you need? This is from Steve Gibson, Perfect Passwords, 64 random characters. This is, of course, ridiculous. Even Mr. Gibson gave up on this. He couldn't log on to his own Wi-Fi network. Yeah.
So I think they're only up to like 14 or 15 digits. So when I secure something for my customers, they're usually like 20 digits on the safe side. I do not think we need it.
Yes, I completely agree. The comment was, how long does a password need to be? And I here have my notes, 15 to 20 characters is probably enough. There's so much bad advice about passwords. Of course, every article in the world says to use a password like that at the top. This is a miserable password, both because you can't remember it and because it's way too short. So here's a good password, New York Yankees. New York Yankees with 2 periods around each word. ... new ... This is both easy to remember and pretty darn long. So this whole idea of random passwords is just stupid. I've never seen so many smart people say so many dumb things except when it comes to choosing passwords. All these passwords here are really good. The one that you like being a smart ass, this is your password, this is my password. If you put 12 greater than signs in front of it, it's a good password. And it's easy to remember. 12 greater than signs and then this is my password. It's really long, defeats brute force, and it's easy to remember. And now that you've chosen a great password, don't hook up any light bulbs. This came out just like a week and a half ago. It was LIFX was the name of the company, and their light bulbs could be hacked and give out your Wi-Fi password. And does anybody, people here, have any idea what the next slide is going to be about leaking Wi-Fi passwords? Another great way to leak what? Cell phones. Yes and no. Android, cell phone or tablet. Google knows nearly every Wi-Fi password in the world. And I say that because those of you who have an Android device, you pull out, if you're running Android version 4, it's under Settings, Backup and Reset, and then Backup My Data. So yeah, Google is nicely backing up all sorts of settings on your phone, and included in those settings are your Wi-Fi password. This is not a surprise. Apple backs up your Wi-Fi password too. It's part of iCloud, specifically Keychain. But the interesting part about Google knowing your Wi-Fi password is that they back it up in a format that they can read it. And of course, if Google can read it, the NSA can make Google turn it over. And some earlier presentation in H.O.P.E, I think there were like 600 million iPhones out there. Android has 78% of the market. So how many billion Android devices are there? 3 or 4 billion Android devices. And most of those devices, by default, will be backing up settings to Google, and Google can read your Wi-Fi password, which means, of course, the US government can read your Wi-Fi password. I am not a hacker. I didn't discover this. I blogged on this September of last year. Basically, all this article was a summary of other research that other people had done. I think this was first written about in 2011. I read about it from the EFF website. Someone named Micah Lee wrote about it. He tried to get a lot of stink and make it public, and it really went nowhere. He submitted it as a bug to Google, and that went nowhere. I don't know if Micah's in the audience. I know he was here yesterday. Now, of course, Google's probably not the worst company in the world. As I said, Apple also knows your passwords in the keychain. Of course, Apple swears that they can't read the keychain data. You can choose to believe that or not. Even if it's true, of course, Apple can still be compelled to turn it over to the US government. And who's to say that someone in the US government can't get your Wi-Fi password, even if Apple can't? I don't know what you do about it. Well, there's a number of things. I got another 50 slides here. But yeah, this is annoying because even if you tell, first thing you might want to do is change your Wi-Fi password. But if any Android device logs onto your network and that device is set up to back up settings to Google, you're hosed. I guess the only good news is that probably the NSA doesn't want to send someone to stand a quarter of a mile from your house and get in. They can do it better. So this is probably an old way of getting your Wi-Fi password. How many people knew this? Wow. Not all that many. Not all that many. I'm not going to speak to the other passwords. Yeah. Oh, by the way, if I hate Windows 8 as much as anyone else, but Microsoft is forcing you to log on now with a Microsoft ID, and as part of that, Microsoft is backing up assorted settings to their data center. I have no idea if they can read your Wi-Fi passwords too, but if they could, it wouldn't surprise the heck out of me. So if someone's on your local network, what's your first line of defense? And that is locking down local administration. Local administration is the normal way you configure a website, open your browser, go to the IP address of the router. So the worst thing you can do is just plain HTTP. Some routers will let you change the port number. So if you want to get into the administrative website, you use port 22999, just something I picked at random. Some routers will let you enforce HTTPS if you want to get to the local administrative website. And of course, the best routers will let you do both. Again, you can read 8 million router reviews, and not one of them is going to say, oh, by the way, this router lets you lock down local administration by forcing HTTPS and giving you an alternate port. Every single review about router talks about speed, 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 speed. Let me ask you, a few hundred people here, you all have smartphones, you all have computers. The last smartphone you bought, the last computer you bought, how many of you really cared about the CPU speed in the device? Well, I'm actually surprised that that many people did. But I think Wi-Fi router speed is much like CPU speed. It's really kind of irrelevant. Some routers will let you turn off wireless access. And that means if someone got on your network via Wi-Fi, they absolutely cannot get into the administrative website. That's a great security feature. I wish I could tell you which routers do it, but no articles that review routers discuss the security of locking down the local administration. Excuse me?
Most of the ones I've seen did have a way to shut it off. You look at the settings very
Yeah. Well, the options for locking down local administration vary by website. And I'm just a blogger. If I ran a lab, I would write up which routers did what, but I don't have access to a ton of routers.
Last questions at the end.
Okay, of course, turn off Telnet and SSH. These are alternate ways to get into the router. And what do I mean by clean up after yourself? I mean three things. One is when you're done administrating a router, obviously log off. Well, it's just another way. If you know how to use it, fine. But for most people who don't, it should be off. You're just safer if you disable it. No. It's just one less way for bad guys to get into your router. And clean up after yourself means if you're going to the administrative website, it would be good if you did it from porn mode. I forget, each browser has a different term for it, but the mode of the browser where it cleans up all the cookies afterwards and cleans up the cache so you don't leave anything behind. Those of you who are techies, of course, use remote administration so that you can get into and play with the routers of your non-techie acquaintances. And by that I mean here, AuntSally.DynDNS.org. Annoyingly about remote administration, every router company calls it something else. So even though I say, oh yeah, turn off remote administration, it's hard to know what to look for. I actually don't agree with the thing about turning off remote administration. I happen to use it on a lot of people I know so that I can get into the routers because I know someday they're going to call me, I can't get on the internet. And I at least like to know if I can get into their router and see what's going on, then I can kind of pinpoint where the problem is. So just like local administration, I want to force remote administration to go over HTTPS. Some routers do it, some don't. I want to force remote administration to use a non-standard port. Some routers do it, some don't. Here's another thing at the bottom, allow only specific IP addresses. It's an interesting security option so that the NSA can't do remote administration, only you can do it, but I don't know how practical that is for consumers. DDNS, of course, if you're going to do remote administration, you need DDNS. AuntSally.DynDNS.org. By the way, if anyone uses DynDNS, they've really gone downhill. It's been my experience. I have 2 accounts with them, and they moved on to other stuff. They're buying other companies. They're moving into other fields. So I think they take the unpaid summer interns, and they're the ones who manage their dynamic DNS now. Okay, DNS servers is the most boring topic here, so I'll be very quick on it. It's a classic attack. If a bad guy gets into your router, they modify the DNS servers, and then they can send you to evil twin websites. So the only thing to say about that is, first of all, I'm a big fan of OpenDNS. I would never use DNS servers from my ISP because that's not their core competence. OpenDNS, that's all they do, is DNS. They're not the only ones. Dyn, Norton, and Komodo also offer free DNS services. And any of these companies have another advantage. Not only do they OpenDNS does it professionally, but you can use these services without signing up for them, without having an account. So if your ISP is watching what you do by monitoring your DNS calls, use OpenDNS. It's one less thing your ISP can see. But of course, it's a classic attack of a router is to change the DNS servers. And how do you know what happened? If you're an OpenDNS customer, you can go to the third line there. You can go to store.opendns.settings, and it will tell you whether you're using OpenDNS or not. But here's another one of the really big things is myresolver.info. If you're going to write anything down, write down myresolver.info, because that is a website. I don't fully understand how it works. That is a website that tells you what your DNS server is. So you can tell very easily, without even going into the wet router, you can tell if you've been hacked or not. Yes?
You were saying that you could hide your DNS traffic from your ISP. Wouldn't a VPN be required because DNS is actually encrypted?
All right, we'll do that later. And it's not that you could hide your DNS traffic. Yeah, all right, we'll do that later. Anyway, myresolver.info, you might want to make myresolver.info your browser homepage. That way, every time you start up your browser, you're confirmed that you're using the DNS server you think you're using and it hasn't been changed on you. Guest networks, some routers have it, some don't. It's an absolutely great feature. The whole idea is, of course, you can keep your personal Wi-Fi password nice and long, but for guests, you give them a shorter Wi-Fi password that's easier to use. The important thing, though, if your guest network is on all the time, it's not providing any real security at all, especially if you use a shorter password. So some routers will offer timing. I've seen this on ASUS. You can turn on the guest network and set a timer, and 3 hours later it turns itself off, so you don't have to remember. That's a really nice security feature. If you ever see a review of any router that mentions it, I will have a heart attack. But it's a really great feature. So, some routers will also have a schedule, so you can say I can only have the guest network on Tuesday if it's a kind of consistent thing that you need to do. So yeah, guest networks are great. It's almost worth getting a new router if your current router doesn't have a guest network, but of course you have to remember to turn it off. And now if all else fails, it comes the question of who's on my network. Consumer routers do a miserable job of this by and large. PepLink, I have some slides here. PepLink does a reasonably good job of reporting who's on your network right now. On Android and iOS, I'm a big fan of the Fing app. I don't know if people here are familiar with Fing. Yeah, it's free. It's pretty good. It does LAN scan. It's pretty simple. On Windows, Nersoft is an excellent website offering lots of free software, reasonably professionally done software, and he has a portable software on Windows that will also give you an inventory. SkyDog, I'm mentioning SkyDog, they just, like 2 weeks ago, got bought out by Comcast. They were an up-and-coming router company. They specialized in parental control, so you make sure if you have a 6-year-old, they don't see any pornography. They were really, really good at that sort of thing. But the thing that I loved about SkyDog, whenever a new device got on your network, it would send you an email message. Wow, what a great feature. Has anyone seen that in any other router? Any kind of automatic notification when a new device shows up on the network? Wow. Well, I'm sorry, SkyDog is gone. Yeah, Comcast bought them, and that's the end of them. Okay, here's Fing. If this doesn't do it justice, you can click on the router and get all sorts of detailed information about the router. You can also click on individual devices and it'll show you some more information about those devices. Very simple to use, great way to who's on my network right now. This is the Nersoft program. Not much to say about it. And this is your PepLink router. PepLink router, which has a feature showing you who's on your network right now. It shows you the IP address, the MAC address, shows you the name of the computer. It tries to find the name of the computer, but you can do things like, say, Susan's iPad so that it's simple and easy to tell. But unfortunately, PepLink is not going to send me an email message when a new device comes onto the network. You can see the second line says Vonage Boxy. Obviously, I set that name. That's not the default name in the Vonage VoIP box. Nice thing about it, it gives you upload and download speed. If your network seems kind of slow, you can log onto the router and see who, if anyone, is hogging the bandwidth. The router also supports multiple SSIDs, so it shows you which SSID a client is logged onto. And really nifty is the last column, signal strength. So you can see how good the signal is for each Wi-Fi client on the network. And the icons all the way in the far left, they tell you whether you're Ethernet connected, Wi-Fi connected, active or not. So it's really great monitoring right in the router, so you don't need Fing or whatever. It also has another feature in the PepLink router that shows you every single socket, I believe is the official term. You go to CNN.com and it brings in ads from 8 different servers, and you'll see all 9 connections here, the 1 to CNN and the 8 to the 9 different ad services. So you can really have a good feel, and it's right in the router, no extra software. You really get a good feel for what's going on your network. Again, I do not work for Peplink at all. Okay, hiding on the network. Your router is a computer, of course, and this diagram only shows half the story. Router has a firewall, and the great thing the firewall does is block unsolicited incoming input. The firewall can also let stuff go through. This is called port forwarding. What this diagram doesn't show is the router is a computer. And the router can actually handle the unsolicited incoming input all by itself. And a lot of the bugs I'm going to talk about in the next few minutes have to do with that. And another great thing the router does, which is the next topic, is it throws stuff away into the bit bucket. Unsolicited incoming input, I'm just not dealing with it. Goodbye. Hiding from ping. Ping is a TCP/IP command being abused by a lot of bad guys to find live routers, live devices on the internet. Every single router has an option not to respond to ping commands. It's absolutely something you want to turn on. It's a great security feature. It helps you hide. Of course, you're not going to hide from your ISP, but you're going to hide from some guy in Russia and China who's trying to find all the live devices with a particular flaw in them. Unfortunately, hiding from ping, the terminology is terrible. Every company has a different term for it. HNAP, has anyone heard of the HNAP protocol? Wow, this is yet another way to access your router. Here's what HNAP does. Without any password, you just go to this folder, HNAP1, all caps, and it dumps out all sorts of technical information about your router. This is a terrible, terrible security feature. HNAP was developed by Cisco, actually developed by somebody called Pure Networks, and now Cisco kind of owns it. HNAP was involved in 2 router security issues. In 2010, there was an exploit of D-Link routers, where attackers used this HNAP to find which specific model of firmware that your D-Link router had, and they had specific attacks to go against that particular model. And the same thing happened just in February of this year, having to do with the Linksys E-line. There was a malware called the Moon, and it would spread from one Linksys router to another. Of course, how did it know which Linksys routers there were? Because it just made an HNAP request to the router. As soon as you get home, this is something you want to do in all your routers. Go to /HNAP1, and hopefully you get no response back. That's the only good thing. Frankly, if you get any response back, I would throw the router out. Here's some more information about HNAP. I'm sorry you can't see the URLs, but you can download a PDF of this. I have not seen any router that offers to turn off HNAP. So the question is, does your router support it? If you have a consumer router, lots of luck dealing with tech support. Lots of luck getting an answer from tech support on any consumer router. I did talk to Peplink when I learned about this a number of months ago, and I was specifically told that their routers do not support HNAP. Okay, firewall and ports. Needless to say, the firewall lords over all the ports in your router. The second line should say ports can be open, closed, or stealth. You know, the firewall and the router is one of your best defenses, even lots of clients I have, they have only one computer, and I said, get a router anyway just to have the firewall. Stealth is the best status for a port. Stealth is the bit bucket. Something comes in on port 1, 2, 3, 4, it's thrown away. Just completely ignored. Closed is not quite as good. Closed is like someone knocks on the door and you yell, go away. You haven't opened the door, but someone knows that there's someone home. And open, of course, is almost always a mistake on a home router. Open is only for people who are running servers. So anyone with a home router, see any open ports, you've got a problem. Now, how do you test the status? Oh, by the way, one of the things bad guys do, of course, is turn off the firewall in your router. So how do you test if the firewall is doing its job? How do you test if the firewall is even on at all? Shields Up from Steve Gisman has been around for 114 years. He hasn't really updated it, but at least he's an honest person. He's a trustworthy, reliable person, and he will do what the bad guys do. He will knock on the firewall for you and report on what he's found. You click on these gray buttons. The gray buttons say file sharing, common ports, and all service ports. We're coming to the big orange button about UPnP. That's a later topic. Wow, 340. This is what it looks if you get a good report from Shields Up. Okay, router software stinks. This is a big reason why if a router is sold at Best Buy, you don't want it. Perhaps router software is developed by amateurs. We will see if time allows a number of cases where it's pretty obvious that the software is developed by amateurs. Perhaps the software is developed with spying in mind. I have one example here where it's very obvious that the purpose of the flaw was really to spy on you. And perhaps it's both. The EFF, Friday, that was the first thing they said about their new firmware. They said all the firmwares really suck. And they're right, they do. In July 2013, there was a report from a company called Independent Security Evaluators. I think they looked at 13 different routers. Every single router, the guy who wrote the report was here yesterday. I don't know if he's here now. 13 popular consumer routers. Every single one of those routers could be hacked from the LAN side, and 11 of the 13 could be hacked from the outside, from the internet. It's just really disgraceful. I will skip a lot of these, but this ASUS password length bug shows you how amateur the people are who code this firmware, which is why, really, if you care about router security, you want a business class router. You don't want a consumer router. Brian Krebs, who writes Krebs on Security, probably most of you know about it. He was writing about some bug in ASUS router where if you stuck a USB device in there, all the files on that USB device could be accessed over the internet. And, you know, that's one of a billion bugs in routers. But he said he was helping his friend with an ASUS router, and he changed the password on the router. And the router reboots, and he types in the password, and he can't get in. What the heck? Anyone care to guess what that problem was? Excuse me? Yes, bingo. I mean, he's a security guy. He picked a long password. He picked a 25-character byte password. Turns out, long story short, that the ASUS router only supports 16-byte passwords. I mean, you know, you made 4 mistakes to get to that point where you will accept a 25-character password, truncate it, not say anything. I mean, that is a level of amateurishness that's just unbelievably disgraceful. And that was a high-end ASUS router. So I will let that substitute for all the millions of other stories I could tell you. Oh, this is the one. All right, I know I'm running out of time. This is the one that got me on this kick that consumer routers are absolutely to be avoided. This gray box that change you made. What is this message? I have no idea what this message means. This message came from this router, this ASUS router. That's why it's here now, and that's why it's not in service, because this came to someone who works at home. The internet access is important to them. I log on, I see this, I have no idea what it is. I cannot deal with software from amateurs. Those of us who really need our internet access, you need professionally done software, and ASUS is not on that list. I still have no idea. I Googled this up the wing. I have no idea what this means. What? No, I didn't change. I did not change the IP of the gateway. Nobody knows what this means in reality. So if anybody wants a miserable router, $20 takes it away. But I would not recommend using it. The Wirecutter. The Wirecutter reviews routers. This is a great website, the Wirecutter. They said the best router, so-and-so. This is a really interesting story. Of course, they judge routers like everyone else. They judge based on speed and features and price, and that's really not the way to judge a router. Security is the way to judge a router. And that's what's really interesting about this is this was their second choice for the best Wi-Fi router. Previously, they chose, actually, I think it's this, oh no, the next generation of this router. That was their best choice for router. And this further shows how miserable the software is on routers. I'm not picking on ASUS. This could be anyone. I guess they picked that ASUS router as the best router in the world January of this year, give or take. In March of this year, the Wirecutter had an update. These are the updates to their website. They say, update your firmware immediately to prevent attacks from accessing USB storage devices. All right, there was a bug in ASUS router. Great. They issued new firmware. The Wirecutter also said it's a good idea to download the firmware from the ASUS website. Why? Because the routers do a miserable job of reporting what the latest firmware is. I have seen that multiple times myself. The router says, oh, you're up to date. You go to the website of the vendor, and there's actually newer firmware. Then on tax day, April of this year, they said, we have determined that the router can have severe connectivity issues on the 2.4 gigahertz band, and we can't recommend it anymore. And then in June, they wrote about it again. All right, I'm late on time, but suffice it to say that consumer routers, the software is miserable. And then there are bugs that are put there in purpose. This is the whoops of whoops. This is one of my favorite stories. Oh, I can't believe I'm down to 10 minutes. By the way, this is slide 57, and I have 81 to go. Okay, Whoops was introduced by the Wi-Fi Alliance in 2007. The Wi-Fi Alliance is the same group that gave us WEP. I appreciate that, I really do. Whoops is actually being used. This is Wi-Fi Analyzer. This was taken in Midtown Manhattan a few months ago. It's on in a lot of routers. Basically, any router that has WPS on can be hacked into by anyone. Whoops is very complicated. It's amazing that this got so little coverage in the press. Whoops operates in like 4 different modes. This is one mode. It supports like this a little Wi-Fi thing, and you push a button on this device, you push a button on your router, and the thing gets onto the internet, gets onto your Wi-Fi network. That's not a security problem because the two things have to be near each other. You push a button. This is another mode of Whoops. It even stands for setup in S. So if you're on a Windows machine, it'll do the initial setup of your router. Then there's another mode of Whoops where you actually get a PIN number for some wireless device, and you enter that PIN number into the router. That's not a security problem either. Then we come to the 4th mode of Whoops. The 4th mode is every consumer router has a hard-coded WPS PIN code. It's on the little label here, 8 digits. And in the 4th mode, your wireless devices give the router that 8-digit number, and they're on your Wi-Fi network. And this is a huge expletive-deleted security problem. Absolutely huge. In fact, I would go so far as I would never use a router that has Whoops capability. Because even when you turn it off, how do you know it's really turned off? This got a lot of publicity in December of 2011. I don't know. Yes, I'm going to explain what the problem is. It's really simple and easy to understand. First of all, you have the problem that every router has an 8-digit number on it, and that 8-digit number will get you into the thing no matter what. So a plumber comes over to your house, turns your router over, takes a picture of the bottom of it, and he can now get on your network forever. This PIN code, it works for all Wi-Fi networks on a router, so guest networks offer you no protection. This PIN code trumps your WPA password. You have a 63-character long password. You change that password every day. Doesn't matter. I got the PIN code. I'm on your network. You change your SSID. Doesn't matter. Like Honey Badger, PIN codes don't care. PIN codes get into your router no matter what. Now, how does this happen? Because you think it's an 8-digit number. How could this be? It's actually not an 8-digit number. It's actually a 7-digit number. The last digit is a check code or a checksum. And it doesn't validate the 7 digits. Of course, with 8 digits, of course, you think 100 million possible PIN numbers, which is probably why this didn't get a lot of publicity. It actually doesn't validate a 7-digit number. It validates the first 4 digits as one thing, and then it validates the next 3 digits as another thing. What does that mean? That means there's 11,000 possible PIN codes. How long does it take a computer to make 11,000 guesses? Not very long. If Whoops is active, you can get into the router. You just need to make 11,000 guesses. If you guess 1 guess a second, it'll take you 3 minutes. Any router with Whoops you can get into in no more than 3 minutes. Why this never made a lot of news? I mean, it was in the tech press, but it never made it to the mainstream media. It's like, hack me, please. And this really annoying is back in April, They modified the H.O.P.E protocol and added NFC to it. And this is an article at PC World. This article says nothing about the security problems for WPS. This was covered in a couple other tech things. Nothing about this WPS. Run from the hills if you have WPS. No, absolutely no. And you'd also think that routers, after like 20, 30, 40, 100 bad pin numbers, maybe they would slow you down so you couldn't guess. But no, they don't slow you down. You can make all 11,000 guesses, no problem. That was the amateur stuff. Well, actually, I don't know. That H.O.P.E pin number thing, was that bad design, or was that done for spying? I mean, H.O.P.E came out in 2007, so maybe that was some spy agency's first generation way of getting in. Before there were 7 billion Android devices that would save your Wi-Fi password and give it to the US government. But this came out in December of last year. This is no doubt about it that your routers are spying on you. Absolutely no doubt about it. Eloy van der Boken wrote about this. Well, that's April. He first wrote about this in December. This was, Christmas of last year. He found that a router responded to commands sent to port 32764. In other words, anything that's unsolicited and comes in should get sent to the bit bucket. But he was playing around and noticed that one of his routers would respond to commands on port 32764. No password was needed. He seems to be a really smart guy, and he figured out that there were like a dozen different commands, and he could make the router do anything he wanted to do. This got some publicity around Christmas time. There were 24 routers. Other people started testing, and 24 routers were found to also have port 32764 open. I mean, this is a backdoor. This is like a glaring thing, a backdoor. The companies that shipped routers with port 32764 are guaranteed to be spying on you, and those routers were from Cisco, Linksys, Netgear, and Diamond. I would never employ a router from any one of those companies. Cisco, Linksys, Netgear, and Diamond. The original testing found that port open on the LAN side, but further people found it was open on the WAN side too. And of course, it got publicity and there was new firmware issued. And then in April, Mr. van der Boken tested that new firmware. And sure enough, that updated firmware blocked port 32764. So any security person who looked at it and said, okay, yeah, they fixed the firmware. But they did not fix the firmware. This is so obviously done by a spy agency, it's amazing. You can read his description there, that's the URL at the bottom. It turns out there's a secret password, a secret bunch of bits. And if you send those bunch of bits to one of these routers, it will reopen port 32764. They didn't even change the port number, and it accepts the exact same commands as always. And the really interesting thing is that secret bunch of bits is not a TCP/IP datagram. It's an Ethernet thing, which means that people in Russia are not going to get into my router in my apartment and open port 32764. You can't send it over TCP/IP. You can only send it as an Ethernet. Now, what does that mean? That means if you're already on my network, you can issue that command and open up the port. And of course, Google knows every Wi-Fi password in the world. And of course, you've got WPS, so you can easily get on my network. Well, the other thing it means, who else is Ethernet connected to your router? Your internet service provider. So your internet service provider can send an Ethernet broadcast and turn on port 32764 for all the routers that are vulnerable to it on your network. And as Mr. van der Boken says right here, it was deliberate, no doubt about it. I repeat those companies again. That was Cisco, Netgear, Linksys, and Diamond. So this was not an amateur thing, as the secret password is Ethernet only, and it's a kind of non-standard Ethernet datagram. Okay, UPnP, another huge security hole. I know I have 1 minute left. Okay, UPnP is a protocol to simplify the discovery. I'm on 69. All right, I got pretty much for it. UPnP is everywhere. It's on routers, printers, NAS devices. UPnP is not necessarily a bad thing. UPnP was designed for LANs, and as such, it has no security. In and of itself, that's not such a big deal. But CERT in 2011 warned about devices that are exposing UPnP on the internet. So having UPnP on the internet is like going in for surgery and having the doctor work on the wrong leg. UPnP is supposed to be LAN side only. Somehow, again, I don't know if this was for spying or just amateurness, but a lot of devices are opening UPnP to the internet where it doesn't belong. Security firm Rapid7 scanned the entire internet every week for 5 months in 2012. They found 80 million devices on the internet that would talk UPnP. There should be no devices. It was designed for LAN use only, period. Unbelievable. Why you do not want a consumer-grade router. Shields Up will test for UPnP if you're exposed on the internet. That's what that big orange button was earlier. Rapid7, the security company, they have 2 scans for whether UPnP is available. The one in the bottom left corner, the orange button, says scan my router is obvious. The other thing, download Scan Now. Scan Now is Windows software, free software from Rapid7, which you can scan, you can use to test other people's routers to see if they're exposing UPnP on the internet. Oh, VPN routers. Oh, this is such a great topic. I'm out of time, so I will say in 3 seconds, if you care about security, you may want to buy a second router. That second router will be a VPN router. When I say a VPN router, I mean a router that can be a VPN client. The term is also used for VPN servers. I don't think there's a big deal having a VPN server in your router, but you want a router that can be a VPN client. And then you sign up with some VPN company, and everything that you send through that router goes to the VPN company. This is a great way to hide what you're doing from your internet service provider. Thomas Drake noted the first day how the US government is in bed with all the internet service providers. So if you don't want them spying on you, you send everything through a VPN router, and I'm really sorry I'm out of time because this is such a sexy topic. But I do know we have to go, so thank you very much.
Yeah, because that was the thing we used to. We did speed, and I don't know if I should stop.
All right, thanks. I didn't know that the open source router is like DWR.
They're better, but they're not perfect. They were vulnerable to
Check, check, check. Oh, great. Yeah, we can get this guy out. Yeah.
Alrighty. Are you projecting? You're all set, right? Okay, we're going to get started in just a moment, folks. You might want to not stand right in the middle talking. Okay, well, we're getting towards the end of the program here. Very exciting day after a very exciting 3 days. Hope you're having as good a time as I am, or maybe even better. I hope you're as tired as I am, or maybe even tireder. And I hope you're as energized as I am, or maybe even energizeder, to continue on for the rest of the day. Got some closing ceremonies coming up in a couple hours. Got a couple talks between now and then. A reminder to please remove your trash from the rooms. We'll actually do a cleanup later on together, a group exercise as part of the community process here. Yeah, you probably want to close those doors. So, yeah, please do clean up your trash, and thanks for being here. Thanks for being a part of H.O.P.E. Thanks for being a part of history, and thanks for all your energy and involvement and participation. So let's proceed. This is John Huntington, and he's going to tell about a self-publishing success story.
Triple this thing. So one thing before we get started, by the end of this talk, I'm going to give away a copy of this book, which is what I'm going to talk about today. It's about use of networks on shows and control systems that we do for live shows. So if you're interested in that, I have this high-tech trip glasses box. I'm going to pass that around. Just put some I'll trust people here. This might be a mistake. But I'll trust people. Just put some name on there. It doesn't have to be your real name, but something that you can claim to me that it is. If you're interested at the end of the talk, I'll give this out. So I'll pass this around. Great. So I'm John Huntington. I'm a professor of entertainment technology at City Tech here in Brooklyn. So first I see it. I wrote this book, and I'm also a blogger at controlgeek.net, and I do some consulting work. And this is actually my sixth H.O.P.E. and the third one I've spoken at. The previous ones were one was on entertainment technology, and last time was on weather. And it's actually related to, weather's not related to this topic, but the H.O.P.E. is related to this book, as I'll mention in a minute. So I'm going to talk a little bit today about how the publishing industry works for trade books, not novels is sort of a different thing that I don't really know anything about, but trade publications like this. So it's a technical book, gets used as a textbook sometimes, but it's also just people are interested by it. I ended up self-publishing by necessity. I'll talk about that. Talk about should you self-publish, and if you're going to do that, how are you going to do it. So, and I put in, I realized when I finished this talk that it was all just boring bullet points, so I figured I'd throw some of my photos in just to give you some, wake people up a little bit of graphical stuff. So how did I get started with this? So the way a trade book gets written or gets published, the publisher gets a book proposal somehow. So in my case, they actually came around with a survey looking for reviewers, and I wrote in there, hey, I'd like to write a book about this. This was like 1992 or something. So they could ask for it, or you could suggest if you have a idea for a book, you can go to a publisher, propose it, and they might consider it. They might send it out for review to experts in that field if they don't really know it. If they see a market, they'll contract for the book, and usually that's pretty much it. There's not really agents involved in this. There's not that much money that makes it worth it. And usually most authors, say certainly in my case, are excited to have the exposure, and this is changing a little bit. But then, again, on a smaller book like this, I'll give you all the sales numbers here in a little bit. I never consult an agent, anything like that. I think I actually did run the thing by a friend of mine's agent. So how I can just speak from my own experience. So you get contracted for a book, how does it go from there? Sometimes they'll give you an advance against royalties, maybe $500, $1,000, something like that. You write the book. It always seems to take a year. Every time I've done this, it's like a year. I tried, the last time I wrote on a sabbatical, so I really tried to sit down and write like 40 hours a week, and I just couldn't do it. So I ended up about 20 hours a week is about what I could do. Always seems, again, takes a year. They might pay you for some production work. You should ask. You can negotiate things in these contracts. So you get all the graphics or make them, and you also have to get all the rights for all the graphics. They don't really do any of that stuff. Typically, and for the first edition of my book, you just submit a manuscript in Word or something like that, and then they lay it out, copy edit it first, lay it out, do the graphics layout and so on. And these people are very good at graphics layout, but they most likely know nothing about your topic. So if a graphic gets switched, which is obvious to you or anybody or your readers, they don't know. I mean, it's just that they don't get it. So the first time I had this come out in the 90s, that whole process took like a year from the time I submitted the manuscript until I actually had a printed book. That sped up in the last edition to like 3-4 months, which is still, as you'll see, is kind of ridiculous. Then the publisher handles marketing, printing, distribution, sales, and for all that, they give you 10% of their growth. So that means if it's not a $100 book, but just I can't do math in my head. So if you have a book that's $100, they sell it to Amazon or bookstore for about $60, you get $6 out of that. So my book, they price somewhere around $60, $70. Typically, I would get about $3 of that typically. So I did 3 editions of a book, the same, it's a lot of related content, but it was called Control Systems for Live Entertainment. One thing I always negotiated, just because it didn't seem right to me on the contract, is that I kept the copyright. So each time they would send me a contract saying they own the copyright, I would cross it out, and they accepted it. Again, you can negotiate some of this. They wouldn't negotiate any higher royalties, but that they would give up. So I proposed a 4th edition. The whole market, our market changes a lot, and a lot of networking stuff came in. I just went to this router talk. It was very interesting for that. And they were, yeah, great idea. So let's do it. I scheduled a sabbatical. I'm a college professor, so I was due for a sabbatical, scheduled it. Then we get a little closer to the time where I really need to start writing. They're like, well, we don't know, maybe not. And started giving me the runaround. So, and then they also complained about the sales, but on the 3rd edition, they really did nothing to market it. It had some momentum on its own, and they just kind of did nothing for it. So, which is a theme a lot, especially with this publisher. I try not to name them in the talk. So eventually, I just realized they weren't going to go for it. So I was depressed about this for like a day. I'm like, oh, they don't want my book. And then I realized, hey, with self-publishing, you can do all this stuff yourself now. So just a bunch of Googling around, I realized there was ways to do this. CreateSpace is the one I ended up using, owned by Amazon. And then I basically just asked them nicely, said, okay, if it took me a while to get them to say they're not going to do it, at least not now. And then once they said that, then I said, well, okay, will you give me the rights back? And they said, sure. So I had to wait a couple months for their lawyer to get around to it or whatever, but then I eventually got a letter back releasing it. So I was going to probably do something anyway, but I probably would have had to rewrite it in some way or something like that, but they just gave it back. Obviously, they're not interested in publishing it, so why just have a dead book sitting on their shelf? And they're very nice people. This whole thing is not just for them. It didn't seem worth it. So I said, okay, my process here is just to keep the book alive. I'd spent years working on this thing. I'd done 3 editions. The market had changed a lot. Excuse me. And I just want to make back whatever expenses I had and kind of keep the thing alive. That's all I was shooting for. And the whole process has really been great as I'll go through this whole thing. So the printed version was on July 3rd, 2012. So I got it like a couple days before the last H.O.P.E. conference. And I'll talk about that. That all happens very, very quickly when you get it going. I really wanted, and I'll talk more about this, but I really wanted to have a DRM-free PDF, digital rights management. I didn't want any of that, but I couldn't find out anybody that would do that as a service back in 2012. Googling around, researching for this talk, actually, there is a company now, so I'm probably going to look into that when I get some time. So instead, I did an ebook on Kindle. That came out in January. It took me a little while just to get caught up and figure out that whole process, which I'll talk about. So that's just sort of an overview of the whole process that we go through for them. So the way I started is I have a blog that, amazingly to me, gets about 28,000 unique visitors a year. I can't imagine why people are that interested in the stuff I write, but I write it because it's fun, it's interesting to me. and some of the things are targeted to the industry. Sometimes I'll just put storm chasing pictures up, stuff like that. But so I get a reasonable amount of readership on the blog. So I wrote a survey, just using SurveyMonkey, free tool, to find out how much people would pay, because I have an audience for the book. Each edition had sold a few thousand copies before, so I wanted to know how much people would pay, because obviously you want to set that, and also what format they wanted. So again, this is from 2012. Things might have changed a little bit, but I really don't think so, as I'll talk about in a minute. I publicized on a bunch of email lists and forums and so on, had 123 people respond, which is a decent sample size for what it is. And actually, I wrote a summary blog entry of this and sent it to Boing Boing and actually published it, which was pretty cool. So the results, in, again, 2012, only 13.9% preferred the ebook. I said, which would you rather? If you can only have one, which would you have? 14% said they wanted an ebook. And I agree with that myself for technical books, because if you look through this thing, every paragraph has a graphic, a picture, a diagram. Ebook formats just really don't work very well for that. I'll talk more about that a little bit. I thought, and so the old price under the publisher is like $68, something like that. It's funny, I actually have no record of that because I had nothing to do with setting it, they just set it. So about 77% of the respondents thought that they would pay about, the maximum they would pay would be about $50. So it's actually, I thought I was going to charge less than that, but I figured I'd charge $50 and that way I could discount it, which I did quite a bit of, as you'll see. And then it's interesting, there's like a perceived value thing with ebooks that they really didn't wanted to pay a lot less for an ebook. So like 45 or less. There's like a flip point, and I have a whole blog entry which I'll post on my website again if you're interested in this. Really pivoted right around that $50 mark, that above that people were willing to pay for print, and then below that ebook pricing they really wanted to drive it down. So I set it at $30 for that. And I also think the ebook is, it turned out okay, but it's a little bit, it's not as good of a layout and so on as the printed books. It's a little bit inferior with that. Let's talk about that. So production, so I wrote this in Adobe FrameMaker, which is a weird layout program. Has anybody ever used it, FrameMaker? Oh, like one person. I know that like the Ethernet standard used to be written in FrameMaker, which is like 800 pages. So it's InDesign is the product mostly used for layout of, shorter, if you're writing a pamphlet or if something is 10 or 15 pages, works pretty well. But FrameMaker is really meant to write big, heavy books. And it's been around forever. It's this oddball. Every few years they're going to kill it. And now actually there's a whole thing where you can use it to generate like dynamic documents and XML and all this stuff. So it's kind of had a resurgence in technical publishing. And if you have a sort of hacker programmer background at all, there's a lot of stuff. It's very logical to a programmer, and you can basically, this thing is one, it's I don't know, 30 files or whatever. But I can reflow the whole book. I can change the whole format of every heading in the book and reflow it in like a minute. And it's rock solid with that stuff. So once you learn it, like every time I go to the rewriting and I have to like relearn the software, but it works great. And I had negotiated because I didn't really like the layout that I almost said the publisher thing. Almost the publisher had done. It's not a secret. I just don't want to give them any press. I didn't really like the layout they had done anyway, so I started doing it myself, and it really wasn't that hard. And they paid me for that. They gave me like $1,500 that they would have given to a production person to do. So it didn't cost them any different. And then long, boring arguments about format. But in the end, when I was working with a publisher, I just sent them a PDF, and the final product, when I'm working with CreateSpace, I'm sending a PDF. It's the same thing. I hired an assistant, former student of mine, to help me with the graphics, actually draw the graphics, almost all of them in there. Hired a copy editor. In New York, I just put up on Facebook, like, hey, who do I know anybody who knows a copy editor? And of course, being New York, there's lots of publishing people. So a friend of a friend did it. She did a fantastic job. I also hired a cover designer, I think did a great job, and she actually is works in the book publishing industry in New York, and so she wanted to get some side work, and she took a bunch of pictures of mine and did a great job with it. Had to buy the ISBN number. That's a little confusing. You could do a whole talk on that. It'd be really boring. But in CreateSpace, there's like several options they give you depending on the type of distribution. But in the end, it's like $100. I'll go over all those costs. And then when I did all this, it was wasn't quite a year this time, but it was a long time, and meticulously go through it and all that. And I had to enter all the copy editing corrections myself, but that's actually not a bad process to go through it. Oh, it gets kind of demoralizing, like, oh, I really do screw up that comma every time. You have to enter that 300 times in the book. And then literally I sent the PDF in, and like within a week I had a printed copy, which is kind of amazing. So it's really much faster than being under the publisher. So ebooks, as I said, they really are terrible for graphics content. There was a bunch of proprietary formats around this a couple years ago, but right when I was making the decision, there was a whole brouhaha because Apple would not publish an ebook because it actually linked to Amazon, so they wouldn't do it. And I'm like, I don't want anybody telling me what to do with my content. So Amazon doesn't do that. They don't care. They just want the money, basically. Format conversions, I think I blocked it out because it was so complicated. I went through my notes to try to remember what the hell I did to get it out of FrameMaker and into the Kindle format, and I honestly have no recollection how it was so torturous. But in the end, it came out okay. I'm sure it's gotten better. It's been a couple years. These tools improve a lot. But yeah, you can get it. And the funny thing is, when I went on, I finally put it up on Amazon, and I accidentally bought it myself. So I cost myself $30 from the thing. So every time I go on the webpage now, you've already purchased this, I think. Talked about that. But yeah, again, it worked out pretty well. The great thing about the ebook format, it's searchable, and all the cross-references, I have lots of cross-references there where it says see chapter 12 or whatever. FrameMaker is amazing for that stuff. All are in there dynamically, which I actually don't have in the print version. So once you have the book finished in CreateSpace, we're back to the printed version, or actually all of it. There's several ways to distribute it. CreateSpace has what they just call an e-store, which is basically a link and a web page that you enter all the content in. I upload a picture of the book, and I wrote a little blurb. You have to kind of do some marketing stuff for yourself. It's hard to. Oh yeah, and if anybody else came in late, there's a white box over here that Aaron has. If you want to put in for the copy of the book at the end, just write your name on a piece of paper in there, or a business card or whatever, and we'll destroy all those at the end. So yeah, there's a e-store, so just link from my webpage. If you go up there, I just say click here to buy the book. It takes you to CreateSpace, and then it really works great because you click the link. They actually print the book on demand, so it's big. If you search around online, just search like CreateSpace Book Robot. There's some similar ones posted online. It's basically just a big laser printer. Everything's 8.5 by 11. They have a robot that shears it, and then a big laser printer for black and white, and they have a color printer for the cover, and then a binding machine. So literally, this thing goes, 5 minutes later, a book pops out. So there's no warehousing, there's nothing. And I think if you order like 1,000 copies or something, they'll call you up and say, hey, let's look at this. Maybe there's another technology for it. But if you buy 100, they're just going to line it up and go. So if you order the book from there, all I do is I get money a few weeks later. I don't have to ship it, warehouse it, do anything. They just print it. It comes out. They do a great job shipping it. And then I get royalties from them, which I'll actually go through in a minute. And again, all these distribution channels are open to you. You can figure this once you release the book into CreateSpace. So CreateSpace works great. One thing I forgot to mention is that there's no free shipping in that like there is in Amazon, but they give you tremendous ability to write discounts. So you can get a kind of alphanumeric code, and you can put that out to anybody. You can discount anything up to basically your cost of the book, or 10% off, or whatever. And I've used that a lot as I was explaining when we go forward. Amazon, you click a checkbox, it goes onto Amazon. They sell it. They set their own price. My friend Jim and I were talking about this the other night, and checked, and they don't actually. That doesn't come out of my royalties if they lower the price down. So they mess around with their end of it a little bit. Because they're now selling it lower than I can sell it on my. I mean, I could change it, but they're undercutting me through CreateSpace now, and they offer free shipping. So most sales, as I'll show in a few minutes, go through the Amazon channel. Kindle. It's bizarre to me. A lot of things suck about Kindle reporting, and the format works fine. I think it's a very solid platform, whatever security issues or whatever aside. But to get information back out of the system on my end is really awful. To collate, to find out how many ebook copies I've sold in the last 2 years, I had to go download individual spreadsheets for each month over the last 2 years and then add that myself. In CreateSpace, you just get whatever you want, download as a spreadsheet. So that back end of that's really weird. Then the other thing is they don't give you any ability to offer discounts except for 100%. So you get 0 discount or 100%. So I actually use that. I'll explain in a minute. But I can't say, hey, what I really wanted to do was all the people who had bought the print edition before the ebook was available, I wanted to give them a free ebook copy, and I really couldn't figure out a way to do that without manually, spending a week myself. I should mention too, there's one other channel in the CreateSpace, you can't see my mouse pointer, right? On the CreateSpace e-store, there's a thing called expanded distribution where they sell to bookstores and things like that. I initially didn't turn that on because I kind of wanted to funnel it all through the sort of more higher royalty possibilities, but eventually I turned that on. I think that's worked out pretty well. Again, those I can't tell where that's being sold to. If you buy the book, I never get your name or anything. I just get, a sale took place on this date. So the royalties, if I can read that all right. So you set the list price, and then there's a minimum cost based on the number of pages, whether it's color, black and white, that kind of stuff. And then the royalties are calculated out from that. So I set a $50 price. So on Amazon, if you buy through Amazon, I get $23.25. If you buy it on my CreateSpace e-store, they get $33.25. You buy it through that expanded distribution, like that would be like through Barnes & Noble or something, because they have to mark it up again, and Amazon wants to keep their chunk. That's $13.25. And in Europe, it's the equivalent in both pounds and euros there. So I'll do a comparison here back to what that costs under the publisher. Kindle has two royalty options. One is it's like 35%, and the other is 70%. The 70% one, as I discovered, is only for very low cost ebooks. So if you put up an ebook for $2, then you can get a 70% royalty, but you can't get one on a $30 thing. So actually, sorry, I can't read my screen here. It's probably bigger over there. Oh yeah, $10, about $10.50 for the ebook copy. So it's about 30% of that. So here's that 70% thing. So that's the basic thing. Once you upload a PDF to them, I ran a proof just to make sure before it's released publicly you can do that, because I wanted to look at it, actually change the cover and did a few things with that. And then you click the button and it's for sale. So I mean, literally, I got the proof copy a couple of days before the H.O.P.E. number 9, and then by H.O.P.E. number 9 you could order it online. So it's pretty cool. So marketing promotion, obviously you have to do this yourself. And I should mention too, CreateSpace does offer you the ability to have them do everything. They will do the copy editing, the cover layout, all that stuff, which means they're subcontracting somebody to do it, and obviously they charge you. It's really not, the fees were in line with what I paid independent friends of mine here in New York, so I don't know about the quality, and obviously you can't like go over and have lunch with them and work on it that way. So once the thing was released, I sent out about 100 copies to people who would help me, because there's a lot of information in here, and so every chapter I send to an expert in that area and make sure I'd rather look like an idiot to them than get it out published. Sorry. Yes. Yeah, I didn't have the ebook when I first released it, so. And then I actually bought a bunch of copies and shipped them myself, and then I realized that CreateSpace's shipping is so cheap, and it's easier. Now, if I want to send you a copy, I just order it myself on CreateSpace and ship it out. And I'll talk more about that for like academic copies and stuff like that. They had this discount structure, so a lot of people that were involved in some way but hadn't spent hours reading a chapter, I sent them a discount code so they could buy get a deal on it. I gave away a copy of my website. I think I did a promotion where you had to guess the number of words in the book, and the person who came closest I gave the copy to. It's like 100,000 words or something crazy. There's a podcast for our industry called AV Week, Audiovisual Week. I went on there and gave away a copy on that. Broadway Sound Masterclass we have here in New York. I have to be speaking at that. Last year I gave away a copy. Stage Lighting Suit, another event we do here in New York. So the thing is that if you're with the publisher, once the book's released, you can call them up or email them and say, hey, I'm speaking this event in 3 weeks. Could you maybe give me one copy for free to give out? And they'll think about it. Me, I just order it. It costs me $7, and then I give it away. So I keep a few copies around just for that reason. I'm in the Local 1 Stagehands Union here in New York, so to promote it in there, we have the email list, so I gave a promotion code for that. I don't remember how much it was anymore, but it was below, it would have given you free shipping basically, plus a little bit off. And so any of those things just end up, comes out, it reduces the royalties obviously. So I took a few ads out in some trade publications. And I put a QR code on it so you can scan it and link back to it. I just put a web page on my blog that's not publicly displayed, and that way you could see it. I could see it if somebody scanned the QR code and it landed on my website. So I have some metrics. It's not very sophisticated, but we have the Audio Engineering Society show, which is a big target market for the book here in New York. So I put an ad like this in the daily. They give out a free newspaper every day. There's, I don't know, 30,000 people with that thing. I got 2 clicks. So I don't know if it was worth it. Lightning Sound America is a trade magazine that's very good in our industry. I put a couple ads in there, 28 views off of that. So again, I don't know who saw it, but these are the people that actually, read the QR code. So, but it gives me some idea. Pro Sound News, another one, I got 18 clicks off of that. I don't know that if it led to any sales, it was a small amount, but I think, again, I needed to get the word out that the book was, the new edition of the book was out. It's really a new book in a lot of ways. And then I was self-publishing it, so this was all about just sort of making an impact. And I'll talk more about that. So I think it helped establish the book in the market to get it out. I got some reviews. Some of these happen spontaneously. Most of them, though, like everything else in that industry, you just need to submit it. So we have a trade organization called USITT. They have a journal, and I just submitted to them. Again, cost me $10 to have it shipped to them, and it's shipped out. And the guy, it turned out it was a friend of mine. He never talked to me, and he gave a great review. But it was one of those really cool moments where I'm literally like sitting on the subway, flipping through the magazine. I'm like, oh, it's my book. And it was. I'm glad he gave me a good review. But it was really that was a really fun time. Stage Directions, another magazine. Lightning Sound America also reviewed it. And those things, there's in the trade press, there's a pretty good wall between editorial and advertising, but it certainly helps to get in their agenda if you buy an ad. So I think it was like $900 worth of ads that I bought. So it certainly helped to get me on their radar. Academic copies. So another rule of a publisher is that if you're a professor like me and you want to evaluate a book like this for your class, you can ask the publisher to send you a copy for free. I just actually did this for a book for one of my sound classes, and they are now sending like time-limited ebook instead of a print copy. So that's a new development that I just experienced recently. But for me, so I just set up a form on my website. I use a little SurveyMonkey form so you can type in all the data, and then I just cut and paste that into CreateSpace, and then it costs me $10, maybe 12 to ship it internationally. That's very slow, but it does go out. And I've sent out 26 copies so far for that. So, and the nice thing about this is I have all their email addresses, so I can follow up with them and say, hey, how did that book work out? Did you end up using it in class? Was there anything that would be better? Do you need something different? And again, with the publisher, they know exactly where all the academic copies are going, but they don't tell you. So they really just, that's not your job. You just write it and they handle the marketing. And obviously, these are small markets that I know the business better than the publisher does. So they don't really offer me much anymore. Oh, that's one thing. I did have a few requests from England and some other places. And so sending that out through CreateSpace, the print-on-demand people, was great because they handle all the duty, everything. You just give them the address and it arrives. The cheap shipping they do is very slow, but it's so much better than having to deal with all the duty stuff. If you ever tried to ship stuff internationally, it's always a nightmare with that, unless you do it all the time, which I don't. Google Books search. So turns out you can join Google Books as a Google Books partner, and then basically I just made a PDF, special for them, uploaded it, and that was it. Then it took them there's some rigmarole. It took them a while to get to it, to get it publicly released, but it's up there now. And I link back from there. There's the way that you can link back to a sales site. So I link back to my CreateSpace site, actually to my blog, I think that went to that. And Google, of course, is really good at analytics, as we've been hearing all weekend here. So since I put it up February 14th, I've had 15 buy clicks. So I don't know if that means 15 people bought it, but that means 15 people searched for something, found it in there, and then clicked on the buy link and at least thought about it. So, and that cost me nothing. So that's what's so great about all this stuff. It was kind of a fun experiment. I took out some Google ads just on some search terms, like show control is a thing we do a lot, or show networks, these type of things who are using networking on shows. And I'd spent like $100. I had one of those used to get these promotions from Google, like, hey, we'll give you $100. So I tried that. I give another 100. It's pretty amazing when you take one of these campaigns out. I would just see this spike in traffic on my website, but it's traffic all over the place, not just to the link page that I was advertising. So it's kind of, I had a paid direct link to my book, but you just see this sort of noise would pop up the minute that campaign went live, and then when it died out, it would drop off again. So it's kind of fascinating with that. I think there must be some, it's got to be, when the ads come up, I think somebody must be scraping it and looking back at it and just going to some robot or something, but it was interesting. Again, I don't really have a good way to track that metrics, but I don't think there's any I couldn't see any results. I mean, if you really wanted to spend a lot more time on this, you could figure this out, but to me, it was just kind of a fun thing to do. We have a great charity in our industry called Behind the Scenes that gives money directly to people who are injured. A lot of people in our field, work freelance, they don't have insurance or whatever, so they will just, if you have like a chronic illness or you're taken out of the industry, they'll just give you cash, which is great, and it's official foundation, all that. So I did a promotion with them where if you bought it, again, using a specific CreateSpace code just so I could track it, then I gave you a $10 discount, and then I would give $10 of the royalties to Behind the Scenes. So sold about 50 copies, and then I rounded it up and gave them $1,000, which was fun. So the royalties end up a little, I don't know, it was around, I actually couldn't find the exact details, but the number that I sold, I had all this, so I just didn't get it. But so I rounded up a little bit to give them $1,000. So again, it's a nice thing. It's a great charity, but also obviously it's good promotion for me because that email went out all over the place. Off the Hook, the radio show done by the people from 2600 who organized this conference. They are, if you listen to the show, they're like an internal pledge drive. They're pretty much in pledge drive like 50 weeks out of the year, it seems now, with all the problems with WBAI. But I emailed Bernie and Emmanuel and said, hey, just got this book. I'd love to come on the show and talk about it, and I'll give away as many people want to buy at some promotional level. So I don't remember. I think it was about, if you donated about $100 to BAI, then you would get the book on that particular promo. So 12 people did that, and then so to me, it cost me about $100, a little less than that. Actually, it's less because it was sort of bulk packaging to BAI, and they, I hope, handled the distribution. If you've been listening to the show lately, there's a lot of problems with that, but I think this went out. So that's a charitable donation for me, and I got to be on the radio and talk about this thing, which is really fun. The other thing I did, and it was really kind of, I got this idea because of that bizarre thing with Kindle not being able to offer a discount. It's either 0 or 100%. So, and like I said, I really wanted to give the ebook copy to the people who bought the print copy before the ebook was available. And I was thinking, this actually has like a serial number in the back, print code, so I was thinking, I'll have them rip that page out and send it in. I'm like, the hell with it. So I did this thing, pay what you will promotion. So I promoted this for like 10 days in advance. Again, I posted a lot of industry email lists, put up on my website, of course. And then what I did is I just set the discount to 100% for 48 hours. You can do all that in Amazon, in the Kindle management page. It's a little, I remember being unclear whether it was Eastern or Pacific time, but so I just opened it up for 48 hours. Anybody could download it, and then I just gave a PayPal address that if you want to donate something, send some money to this PayPal thing. So the coolest thing, so I had 420 people downloaded it in 48 hours. 14% of those people donated. So one thing, I really have no metrics on what the other people are, because it might just be, if you're looking for free Kindle books, you just happen to stumble across this, no cost to you, maybe you download it. But the really great thing for me is I got a lot of comments with people would comment when they gave the PayPal, or they would just email me, whatever, and I had a bunch of people say, hey, I just got laid off from my job. I'm trying to learn about this stuff. This is really great. I can't afford to give you anything, but I really appreciate it, which is it's really nice for me. And a lot of students, again, I just started school, I don't have money, so here's $5, So that was pretty cool. So 39% so out of the 14% of the 420 donated, so 59 people donated, 39% of them gave $10, 20% gave $20, 7% gave $30, which is the full price. 14% gave $5, and 2 people gave me $1. which was, to me, was 33 cents after PayPal time. So I don't really know what I don't know. I don't know how to feel if they think it's worth $1. So, but again, a lot of the other people gave $5, said, look, you know, I haven't really been out of work for a while, these types of these things. So it was kind of fun to get that kind of feedback. Amazingly, though, I got like $900 out of that. So the per copy royalty for that, given the number that were downloaded, is about $2 per copy, but still is $900. So the other thing I did that I don't think I could ever do this with a publisher is I made lecture videos for my class at City Tech. And I actually have some City Tech students here working today. They're volunteering, which is great. So I made these lecture videos where I literally just take my PDF of the book, put it on the screen, run this Camtasia, you know, capturing software, and do the lectures I used to do at City Tech in person. I made videos for them, and I just put them online for free. And then I restructured my class so that the lecture portion we don't meet anymore, and then the meeting part of the class we start with a lab. We clear up anything that's confusing, discuss anything, and jump into a lab. And that's been 2 years of that, and it's really worked out great. Could ask some of the students if they thought it was good, but. I don't know. I haven't tried this. I really doubt that a publisher is going to let you take a clear PDF and put it on the screen. I mean, I'm not uploading the PDF, but you certainly could. You could basically, you don't need to read it if you watch the video. But though people learn differently. Some people are better read-write learners. Some people are better hearing it. Some people are better watching it. And then I also put a lot of supplemental stuff in there. I would say that this will probably end up making it get taken down. But one thing, it's all on Vimeo. So sometimes I actually went on the screen and I actually run YouTube videos of things related to the content, captured that, put it on Vimeo, and I've never gotten a DMCA takedown notice or anything for it. I mean, it's legitimate fair use. I mean, it's literally a class lecture. I link back to the original video. If I could embed the link in the Vimeo video, I would. Again, I can't imagine. I don't know. Maybe I'm wrong, but I don't imagine my old publisher would have allowed that. And they control the distribution rights, so I would not be allowed to do it legally without asking them. So some of the videos have hundreds of plays. I haven't had hundreds of students come through since we've done this, so that means there's some people watching it, other chapters that were not students. So it's definitely getting around a little bit. So the results. So I debated whether to just tell the number of copies or whatever. So how the hell would I just put I'll just put exactly what I made up there. So first edition, 1994 to 2000, sold 2,700 copies, about 2,700 copies. It's about $6,000 in royalties spread over 6 years. So get a check for $600-800 every year. Royalty for that, about $2.35 per copy. And then what I did is I figured it took about 400 hours to do each edition of the book. I honestly, back when I wrote this, I intentionally did not track my time because I didn't want to know, because I really didn't think it was going to be worth it financially. So about $16 an hour to do the first edition, which really isn't worth it. I can go work as a local one stagehand, even in 1994, make better money than that. But that's not the reason you do it. I mean, obviously the money is nice, it covers things, but it's really about this. Definitely I got other value in terms of being asked to speak at conferences. I wouldn't be speaking here if it wasn't for that. This is not going to make me any money, but it gets a lot of exposure, and it helped in my academic career having a book published, certainly. Second edition, 2,500, 2,600 copies, about $21 an hour for that, $3 copy royalties. Third edition, about 2,200 copies. So the sales were kind of declining there in that way. But again, this third edition, I think the publisher really didn't, they did virtually nothing to market it. Royalties about $8,500. Reading all these numbers in case people are listening just on audio here. About $4 a copy for royalties and about $21 an hour. So over the life of that 3 editions of that book, it was between $16 and $21 per hour, given inflation and all that, is about rough calculation what I was making to write the book. So again, it's fun. I enjoy it. I like the process and I like the result, and it's really fun to do it. Financially, it's probably not. If you're trying to make a living that way, it's pretty hard. Interesting. So the total royalties over 3 editions was about $23,000. But of course, that's 10%, so that means over that time, the publisher took in about $233,000 during that time. And obviously, I'm not paying for warehousing and all that kind of stuff. I'm sorry, I couldn't. Yeah. Well, the advance, it basically just, it's a good question, actually. If you get $1,000 advance and you make $6,000 in royalties, it just means it's literally an advance. So you get that $1,000 and you won't even get royalties for like the first year or whatever, and then you'll get $5,300 later. That's the whole scam with the record companies, where they would advance these artists, to make a record, and then they charge all these expenses against it, and they'd never get any more money. But in this case, it's just per copy royalties. So the royalties are just, the advance would just be rolled into that number. So for self-published sales, and it was really kind of interesting because I just added all these numbers up last week. So I sold on about 1,030 copies of the print edition. 700 of those were on Amazon. My e-store was 237, and then this expanded distribution is 90, so that's about whatever number went to the bookstore. That gave me $25,000 in royalties, which is kind of amazing because this money just keeps coming in. I'm like, wow, it's just direct deposit to my account. It's pretty cool. So the royalty per copy on average there is about $24, and so comparing that to publisher royalty, so it's about $2-3 per copy under the publisher and $24 per copy under self-publishing. So I'm sorry. Let's see. And eventually when they get I guess they're going to talk streaming. I don't know if they're going to archive it, but if not, I'll put all these slides up against the audio. So I did some wholesale print sales because there's some small sort of online booksellers in our market that really kind of curate books, and they want to sell it, or Union in Los Angeles wanted to buy a bunch of copies, things like that. So with that, I can buy the copies from CreateSpace at $6.75 a piece plus shipping, and I can do whatever I want with them. I can give them away, like today. I can sell them to them. So I sell them to them at 40% off, which is that standard sort of wholesale price. And then they can resell it, or they can give it to their union members or whatever. So I sold 150 copies that way. It's interesting, when I calculated all the shipping expense and all the other things involved in that, the average royalty for that was about $23 again, so it's in that same ballpark. So again, that first number, $23.92, is an average between, if you buy it from the e-store, I get more. If you buy from Amazon, you get less. If you buy from expanded distribution, I get even less. So that's the average altogether. So Kindle copies, this was kind of interesting because I just get these reports and I never totaled it up. Like I said, it was a pain in the ass. 144 copies. So maybe I undersold it in terms of hey, it's not as good as the print version or whatever. But I also just think that we're just not there yet in terms of the ebooks. I mean, I read. If it's like a novel, I'm happy to read on an ebook. If it's a technical book, I still want to read it in print. So I'm going to look into this PDF. What I want is individually watermarked PDFs, and it looks like that's possible now. So I'll look at that, and I might, if that works, I might just kill the Kindle edition on. So that Pay What You Will version promotion was 420 copies, made about $894, and the royalty for that is $2.13 because obviously 80-some% of people didn't pay anything. So, and I literally didn't know this number until like Friday. 1,744 copies since the H.O.P.E. number 9 until now, because just coincidentally have to be released on that. So in 2 years, it sold 1,744 copies, about over $30,000 in total royalties. And because it's been coming in every month, I honestly never totaled this up. And I'll show you the expenses in a minute. But so that's on track. So 1,700 copies over 2 years is actually on track with the sales under the publisher. And I'll talk about this. I'm in a unique situation in terms of I already had an existing product and so on, but let me get through some of this before I run out of time. So expenses for me, so out of pocket, so I'm not including office expense, things like that, because it just would get crazy. But this was the same as when I was writing the book for the publisher. So I would need a desk and a computer and that kind of stuff. I needed that then. I need that now, so I'm not really counting that. So the expenses between copy editing, all that kind of stuff, ISBN, there's a few setup charges, a couple $100 of setup charges, which is really pretty minimal. You have to pay for a few things here and there. So, and the advertisements and some new business cards and stuff like that, promotional copies, roughly about $6,000, sort of the promotional costs and the sort of production and promotional costs. So you take about $31,000 and subtract of total income, subtract $6,000 off of that. total gross profit's about $25,000. And so the hourly wage based on that, comparing again the same sort of structure to the publisher, is about $49 an hour. So now you're talking about it is worth it to do it if you can get these kind of sales numbers. It's a lot better than 15, 20, things like that. That's actually well below my consulting rate, so if you hire me to consult on a sound system or something, I'm going to charge more than that. But if you guaranteed me 500 hours worth of work, I might negotiate that down. Oh, and I increased the number here because all that promotional marketing stuff, you have to factor that in. So that's not including taxes, home office expense. I took a 20% pay cut to take a half a year sabbatical for my school, so that's all lost, and I'm not factoring all that in, but it's sort of to try to compare apples and apples. So the self-published is about $49, and of course, this rate, if I don't do a big update, this rate just keeps going up as more sales come in, so 2 more years, actually the effective rate would go up. But about $50 an hour to self-publish, and roughly $20 an hour under the publisher. So, and yeah, we'll talk about that in a minute. Okay, to summarize that, the benefits to me, so my situation is unique. I already had 3 editions of a book in the market. That's not going to translate necessarily to a lot of other people starting out. That's not us speeding back. But on this 1 edition, I made more than all 3 copies previous combined under the publisher. That's, again, and I really wasn't my goal or anything really. I mean, of course, I like making money, but that wasn't the objective. All I started out to do was cover my expenses and keep the thing going, and I went way better than that. Talked about that. And the greatest thing, though, is just that to me, I have a lot more engagement with the readers, which is really great, rather than just somebody, you screwed this up, or some typo that I get. The other very cool thing with CreateSpace is if I wanted to spend the time right now, there's a few typos in there that people have found. I have an errata page on my website. But if I wanted to add a chapter today, I could go write it. I just upload a new PDF to CreateSpace, and then the next one that's ordered would be printed with the new edition. So that's pretty cool. So you don't have to wait and go talk to the publisher. And then so far there hasn't been anything sort of dramatic changes in terms of that. I kind of anticipated most of the things. But there's a few typos, there's some tables that didn't set right and things like that. So I might update that at some point. That would probably be version 1.01. But if a new technology came out today and I want to add a chapter, I can just go add a chapter. And then I have to get the word out, and I would probably just post that chapter PDF on my website for people who already have the book and stuff like that. But so far that hasn't come up yet. And the biggest thing I think it's really been fun, the whole process. I mean, it's a lot of work. Writing a book, a huge amount of work. But the marketing and promotion and that kind of stuff was, for me, was made it a lot more fun because you get that feedback about it, because a lot of times you just stare at the computer, send it to the publisher, a year later it gets printed, then somebody tells you they saw it, and then, so that way you're interacting with these like contests and promotional stuff, and the pay what you will promotion and so on was really, I had a lot more engagement with the readers, which is really great. So is it right for you? So I would say the role of a good publisher today would be, first, they really need to find, develop, and service a market, right? They need to understand a market, and they need to have credibility in that market. They need to have a strong identity. So I always think of O'Reilly as a good example of this. If you buy an O'Reilly book, obviously things can get through the system, but for the most part, you know that it's a quality book on a topic that's relevant and so on. Credibility, I've mentioned that before, again, O'Reilly. And a very interesting thing from the academic side is I'm already full professor, so the self-published edition of this, I didn't have to go argue with people about promotion and tenure with that. That's going to be very interesting to see how that works out, because I know in my school, they already look at us entertainment people weird because we don't have peer-reviewed journals and so on. So I don't know how you can, I think I could make a good case. I've sold X copies, was on Off the Hook, whatever, things like that. But it'd be interesting. So if somebody does that with a self-published book, I'd love to hear how that went. Because one thing, it's a publisher. If it's a known publisher, then that gives you sort of a stamp of approval. External, acclamation that's really important. So the other thing a publisher really should do is make it easy for authors. And I really think they should engage the authors in sales and marketing. And my publisher never did that. They just sort of you send in this, I was sending in a PDF, comes out, and then you get a check once a year. That's one other thing with the self-publishing and through CreateSpace, you get a monthly royalty, where with the publisher, you get 1 check a year in about March, and you get this really terse statement with all these returns and all this crap. So with this, the money comes in as it's sold. So I think the publishers that aren't doing these things aren't really having a strong identity, really developing the market. They really should see self-publishing as a threat, because honestly, the last edition of my publisher, the CreateSpace, actually offered me more, and I made a lot more money from that. So I certainly wouldn't go backwards. In fact, I have friends with the same publisher now that are thinking about new editions, and I've been telling them, like, hey, you should just do that. Because we do all the work anyway. So if you're willing to do the promotional part, then why not? So problems with my publisher, as I said, they complain about the sales, but the marketing is terrible. The academic policy cut me out of the loop. Royalties are confusing. One other thing that's really awful is they lost, I sent them a PDF that has print marks on it and all that stuff. They lost a copy of that, and they would actually distribute ebooks as just raw, clean PDF. So they're all over the web. So you go up, if you search for the previous edition of my book, you'll find 12 illicit copies up there, and of course you have to download some Romanian porn spam to get to that page, but it's up there. So I've had students bring those things in before, and I'm like, really? Thanks, and that, I didn't lose that. That was them. So on this edition, I know where it went. There's three clean PDF copies released. Anybody I would send it to review or whatever, it was watermarked. I sent one to CreateSpace, clean, because obviously you have to print it without a watermark. One to Kindle, which is actually EPUB format, and one to Google. That's it for the book search. And I honestly don't search anymore because it just gets too upsetting. But as far as I know, I haven't seen any versions pop up. Obviously, any DRM can be broken, anything like that. But generally, you just don't want. If you have a clean PDF, that's what my publisher did. And as far as I know, they're still doing that. And then what really pissed me off, I had to find the pirated copies. I had a Google search just set up for the title of my book, and it would come up, download Control System Reliable Entertainment for free. And I'm like, God. So I would go look at it, and then I would have to send it. So at first one, I actually issued a DMCA to the people, and then the next one, I emailed the publisher. I'm like, what are you guys doing? And it turns out they have a whole division that will go after these people, but they don't search for anything. So I had to send them. So what the hell good are they? People don't understand the content. That was a big problem with the layout. I mean, again, graphics, they're doing a great job on the graphics layout. They're just not their topic. And then the funny thing is they agreed to stop publishing it June 30th or whatever in 2012. They kept publishing it. So, and I just got a check this year for ebook royalties of some package they sold to a library, whatever. I'm like, you gotta be kidding me. So the first time though, they kept selling the old edition, which is really obsolete, through the royalty period of 2013. And so I had to call them up and say, what the hell are you doing? Why is this still out there? I have a contract from you that says you will stop selling it June 30th. So it just gets lost in the bureaucracy. Publisher got sold. And the other thing, dealing with the publisher, with 3 editions of this book over since 1994, I don't think I sent an email to the same person more than 2 years in a row. So every time it's like a revolving door. Because these are people interested in publishing, and like publishing weird technical books, it's not what was their dream. So they're not going to stay there very long. Great people, but again, it's just every time, what, who are you? And then the funny thing is actually that publisher just sent me a book proposal to review, and then started out, I'm not sure if you're familiar with this publishing company. I emailed back, yes, and you actually published my book, 3 editions of that. So to do this for yourself today, CreateSpace, I really had a great experience with them. They're part of Amazon. We have issues with Amazon, but they really did a great job. And they print the books in South Carolina, and they ship them out. They have another printer somewhere in Europe once you enable that, so they don't have to ship it over there. Usually they beat whatever deadline. If they say it's going to be here next Thursday, it comes on Tuesday. They've really been great with that. The upfront cost, I had some more because it's a big book. It's 400 pages and lots of words, so copy editing costs a little bit more and stuff like that. But the actual setup costs in CreateSpace are really low. It's probably a couple $100 total. You could get something out there. Again, if you lay out and all that, would be more. I had as far as I know, there's no interference with Create. They don't care what the content is. I don't know if I publish something really, racist or horrible or whatever, if they have complaints or something like that. But I never had a word from them about the content of the book. So if you want to publish something, I certainly wouldn't be anonymous. But if you had a self-publishing book you wanted to do, you can just do it. That's actually, in some ways, writing obviously is hard. getting it onto their system's pretty easy. Then the hardest part is getting the word out. Because when you look around on there are hundreds of, thousands of $2 ebooks up there, fan fiction, whatever stuff. So getting your content, out of the noise is the hard part. But they'll do everything for you. You just got to pay for it if you want it. The other thing, it's a little hard to get experience because you're the first time through the process is when you're releasing it. So if you make a mistake, you're kind of in it at that point. But we're hackers, right? So we're good at figuring these things out. I think almost every step of the way, I had an ability to test whatever it was before it went out for real. So even the final copy, like I said, I got a proof copy before I clicked the release button on there. And don't have to do that, but it was good to do. So what I would do today, if I was starting from scratch, I would start a blog, which I already have, because, and then keep control of it, even, whatever, Tumblr, Facebook, whatever, I still would put it on my own thing that I own and keep linking back to it. I still read a lot of blogs. Every year there's another opinion piece about how blogs are dead, but like I said, I still have like 28,000 people coming to mind for various reasons. But I actually did work out new material for this edition on the blog, which is great. I got some feedback from that. And I'm just able to go through that process and have a deadline and all that stuff was very helpful for me. Build the audience. You know your audience pretty well for these things. Here, this is an audience, if you're writing computer books or whatever, right here, there's a good, not going to say that's easy, but you probably know more about it than the publisher. And you're going to be up there on Amazon the same way any book from any publisher is. So if you can get, it's in the system. Talked about that. Okay, questions? Go ahead.
You gave away the 12 books to WBAI for $100 donation. I would guess there were some people who may have bought your book at lower cost. So did you find that by giving out 12 copies that your books became, that you sold more around that period of time?
Yeah, that's a good question. The question was, did the sales increase? Because obviously, whatever the listenership of the radio show is listening to it. Nothing dramatic. I should actually go back and look because you can plot all that out. But it's kind of a niche book, and it's a more general audience, so I would doubt it. But I could check it out.
Second question, if you don't mind. So last May, I was at Book Expo at Javits. I'm a self-publisher up there, and I'm coming out with an ebook. And I'm claiming to do it via Kindle, right? But then I started to talk to some of the digital guys who were saying I could put on my website a download thing for people, and then I would make more money.
Yeah.
But then some people said to me that's not a good idea because it's very complicated. It's better let Kindle have that and you make your 70%. What would you suggest?
Maybe 30%. Oh, if it's under $2, yeah. That's a good question. Probably have to talk to you more about what your market is, because it's if you can reach the audience, then you can cut everybody out. But there's certainly a convenience with Kindle where it gets into they manage that, they make that very easy. So if you want to talk to me afterwards, I have to talk about that in the back there.
Great presentation.
Oh, thank you.
Very much. Last question about the PDF watermark. Exactly how do you use that and what the watermark is?
Yeah, I forgot to put it in the presentation, but I have a link from my webpage. If you email me, I can send you the link. I'm drawing a total blank on the name of the company right now, but there's a company now that will take a PDF that you upload, and they will sell it, handle the credit card transaction, blah, 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 and then each time they will generate a code and put some name on there. Supposedly, and I literally just found this like last week. Yeah, it's not the one that I had, but yeah, it's quite possible. So if you email me, I can send you the link. I just forgot to put it in here, so sure. Oh, yeah. Oh, this is a good question. The question was the Amazon and the Kindle stuff. It's a really complicated thing. Everything in Kindle was complicated. The printed thing was so much easier. But in Kindle, there's an exclusive pricing arrangement. You're not allowed to undersell it anywhere else. But I'm only selling electronically on Kindle, so I don't have that problem. But yeah, paper is separate. Yeah. Right. I probably could charge $20. I don't think they could do anything about it yet. That's a good question. Yeah, that's it. Yeah, Kindle Direct it's called. Yeah, so right now I'm on that, but if I figure out this PDF thing, I would probably just kill the Kindle edition altogether and just sell it directly on my website, probably for less money, and it would just go directly. So. Yeah, I just had it on my webpage. Well, no, I never said it was free. It's pay what you will. So if you want to pay $0, that's up to you. No, because it's the Amazon promotion. It's a like time limited thing where it's $0. It's very complicated when you're allowed to do that and all that. But so that was through Amazon was to have the price set to $0 for 48 hours. Yeah, I never didn't ask. So that's a good question. Yeah, it's possible that might. I don't know. It's a good question. I didn't ask, and they didn't say anything. So I think we're out of time, but we'll draw this book. Okay, I ran that one. I'm not looking here. That seems good. Let's see. Oh, SRR Swami Steve. Who's that? Oh, great. Great. Well, Shri, I'm sorry. Great. Thank you very much. Sure. Let me.
Before you start on this research interview, okay.
It's gotten a little bit better initially when design came out. Sorry? I had several as my copies.
Okay.
Oh, good evening.
How you doing? I know. Thank you. I'm Bill Horn. If the face doesn't match what you've seen online, sorry. It's the one I'm stuck with. I know it's late. We're all tired. Thanks for hanging in to hear me. I got a warm beer and a cold shower waiting, so let's get started. I've been the moderator of the Telecom Digest since roughly 2007. First thing up is the door prize. Does anybody know how many stops there are on 53rd Street for the E train? How many times the E train stops on 53rd Street? Who can tell me that? How many stations? Well, there's two. I found that out the hard way. I got off 2 feet from the Hudson River and walked all the way to the East River, or thereabouts, because it stops twice on 53rd Street. Who uses the subway in New York? This is for whoever needs it. You, sir, you take it. I think there's one ride left on it. Now, Bernie asked me to do this, and I thought I'd give you a linear history of the Telecom Digest from one end to the other, and highlights from every year and so forth. But, you know, I started looking through the archives, and it occurred to me all the interesting stuff, as far as this goes, was right at the front. When the archive was founded in 1981, the telephone industry was just about to go through the biggest change in its entire history. And I've concentrated mostly on that time when people were still new to the internet and still new to ARPANET, in fact, and there was no such thing as Usenet until poli-sci and telecom became part of the first Usenet groups. The history of the Telecom Digest is parallels to my history. In 1981, I was slogging my way toward the end of my college degree, and I was working on the radio board at Franklin Street in Boston. I was punching cards on IBM 029s at Northeastern University and learning to program Fortran and dreaming of my bright future as a computing professional. You know, I have a theory. I don't think anybody ever sees it coming when it's their ox that's going to get gored. I wish I could say I was an exception to the rule. As I look back, I realized I was present at the end of the electromechanical age in the telephone network in North America. When I started at New England Telephone and Telegraph, we were still using EMX1 and EMX2 signaling units that had been designed for use on telegraphs, literal telegraphs. They had been in service for, I don't know, maybe 100 years without much redesign. And we still used them. We'd hook them up to the T-carrier channel units and use them for private line, and just generally had a great time drawing a wage and working swing shift in Back Bay in Boston. The T-carriers were new channel units in the old N-carrier bays. That, by the way, is why T-carrier has 24 channels in it. And we try to figure out the Wheatstone bridges that we were never trained to use. They were no longer needed for the Varley measurements because the T-carriers had freed up so many trunk pairs that nobody ever needed to bother to work on trunks anymore. The changes brought about by digital voice transmission and the computer revolution, they're old news now. But I witnessed many of them firsthand. Coaxial cables and microwave gave way to fiber. L5 carrier waves to DACs, local test ports to MLT, and toll test to SARTs. And during the same time, the once proud craft workforce, where senior technicians took examinations to earn the privilege of wearing a tie at work, saw an influx of people whose definition of success was not getting caught smoking a joint on the roof. The craft workforce decreased in quality and experience to the point where it became obvious that the job was going to be dumbed down to the point where semi-skilled workers could do it. And I decided to get out and went into other things. I became a computer programmer at NYNEX, which was what New York Telephone and New England Telephone became after the Bell System breakup. And I witnessed the revolution in computer programming too. The methodology and practice I saw as a systems analyst. I got promoted a couple of times. Well, they were just constantly pivoting to partake in the latest fad, optimizing compilers and case tools and vendors who promised us the world on a string, but whose primary job skill turned out to be lying through their teeth. In roughly 1994, I saw pretty quickly that the computer programming was going to go away, at least in the United States. I was asked to put in a work-at-home arrangement for a girl who was one of the key players on an important team, and she was going out on pregnancy leave, so I, having been in the craft, was asked to help out. I knew who to call and what equipment we needed. And she sent me an email on an old system called Profs that we were still using then, and saying, this is great, you know, I'm in my house, it's just like being at work. And I sat there at my desk in, I think it was 125 High Street in Boston, and I said to myself, if they can move this job 10 miles, they can move it 10,000. I knew it was going away. I knew it was gone. As it happened, I was lucky enough to get another position in the engineering department at Verizon. I've forgotten whether we were Bell Atlantic at that time. And but anyway, I got a job in engineering. And a month before I left the programming groups, we were told that COBOL maintenance was going to a firm in India. So if I do say so myself, I saw it coming. I finished my telephone career in engineering, which is a part of the business where things actually had to work right. It was a welcome change from the programming groups that had been filled a lot with buzzword babies and other people. Well, the less said about them, the better. And I know it's sad. I have a slideshow on it. I'll comment on it as we go along, but before I start, I'll just paraphrase Jackson Browne. It seems to have gone by in the wink of an eye. No, I don't want that one. I want that one. Those are my phone numbers. They are real dialable phone numbers. And you wouldn't believe how hard it was to get those. Yeah, sure. Rugrats was the best I could do with 784. The other one, well, that's a Google Voice number, and they just happened to offer the 364 exchange code, and I said, that one's for me. Obviously, the email address is my name, bill@horn.net. I'm Bill Horn. That's pretty easy to remember. The first moderator of the digest was Jonathan Solomon, and it started in 1981. He was at Rutgers at the time. He went for about 6 years roughly, and had to do other things for a while. Two guys helped him out, Elliot Moore and Jim Dixon. They were helping out, and I don't know if they ever had official status. Late in 1988, Pat Townsend took over the digest as the official moderator, and Jay Saul went on to other things. Pat had a stroke in, I think it was 2007, and I was on the phone, wishing him well and stuff, and he asked me to help out while he got back on his feet. I said, yeah, sure, I guess I can learn how to be a moderator. And I started doing it and just kept doing it. It's funny, though, because I found out later Pat had never worked in the industry. I don't know about Jonathan. He was an academician, but I never had any more input about him or his background. It just wasn't available. I think I'm the first guy who actually worked in the phone company to moderate the digest. And many of the readers have told me it's much more technical now. I'm not so sure that's a good thing, because it seems to me we're going more and more toward a realm where regulations count for more than technology, but time will tell. The locations, they're not really very important, but Jonathan started out at Rutgers, and then for a time the digest lived at MIT and was moved to Boston University. Jonathan made a big point of starting Volume 7 to celebrate the move. And then in 1988, when Pat took over, it's moved back to MIT. It's pretty much been there ever since. And a sincere thank you, by the way, to the Computer Science and Artificial Intelligence Lab at MIT, because they give us a free PC, PowerPipe, and Ping. And I will acknowledge also Garrett Wallman, who's the sysadmin there, who just found us a new machine when the old one threw a RAID array element and one of the disks in the RAID array failed. We were limping along while he got a new machine going for us. So thanks to Garrett. Anybody know what ARPANET was? I'm surprised. That was a pretty rare beast. I helped to put in maybe the first lines from MIT to the first ISP in roughly 1979 or thereabouts. You know what bank path addressing is? Well, if you look here on the slide, you can see where the address was a series of bang paths. You had an address, UT-zoo, exclamation point, et cetera, and it was the major node down to the minor, separated by exclamation points, which are called bang elements in the trade. That form of addressing went for all the time when ARPANET was being used. And this is one of the very first messages sent out to the digest, obviously just a test. I want to show you the second post on the digest, and then much later we'll get to the first one. I think you'll like the reason why. There's just, some administrivia and a guy asking about alternatives for AT&T and a problem with the dimension. And as Jonathan put out there, J. Saul at Rutgers was his email. Spin-off from the human nets, which was just the place they put these sorts of things on ARPANET. At the time when we were putting in those lines I mentioned between MIT and BBN, we had all kinds of trouble with them. We equalized them to 50,000 hertz, which was a very, very high quality broadcast equalization. Even FM stations lines were only equalized to 15. These were set up at 50. And specially made paradigm modems that delivered, wait for it, 50,000 bits per second. That was blazingly fast in 1979, expensively blazingly fast. But here you see J. Saul's first "How you doing" message. The San Jose Mercury, this was the second post. It was a copy of, somebody sent in a copy of an editorial from the San Jose Mercury. They were pioneers in electronic broadcasting or publishing. But it felt as if I were writing it myself, because I tend to be a curmudgeon about the lack of utility and lack of usefulness of many of the electronic toys people bring to work these days. The guy said, this new dimension system was unnerving, and, well, are we the servants or the masters? I have a cell phone, which, for practical purposes, is an electronic leash held by my employer, and I'd just rather turn the thing off and do without it and go back to the old hand crank Ma and Pa kettle used. I imagine there's others in the same boat, but I don't know why. I think these things have been hyped and publicized to the point where I start to ask just exactly what we got in this trade-off. The guy that wrote the editorial talked about a dimension that had a dial tone Morse code where you had to know a certain number of beep combinations and so forth, and long before SMS, of course. But the complaints received, and I can attest to them because I was, as I say, in the business, from new features from ESS that required people to adapt to new ways of doing things. If you ever try to explain how to flash a telephone hook switch and get somebody who understands you on the first try, please tell me how, because I never could. It was just a nightmare to get people to use the 1A, but I suppose we all adapted without quite realizing it. Somebody at Bell Labs didn't think that was a very good editorial. And that was a phrase I'd heard before, and when I read this and I was preparing this, I said, isn't that the truth? Before we'll have complete adoption of these little gadgets, all the old people will have to die. There's a cheery thought for you. I was surprised to find how many posts there were about modems. Everybody wanted to know how about a modem worked, and there were tips on how to get the maximum performance and so forth. But there was a lot of interest in data transmission on the phone network in the early years of the digest. One of the first things the 1A did, and I started in an office which had panel operating in service when I started with it and was converted to 1A ESS. International direct distance dialing was a very big feature of the 1A, one of the big sellers. And although it wasn't advertised, the 800 numbers in use at the time were mostly rerouted into 1A switches because having capability to use SS7, in some cases still SS6, they obviated the use of blue boxes for 800 number fraud. So all of the 800 numbers were rehomed into 1As and served from there so that the phone company didn't have to worry about blue boxes anymore. Who remembers Western Union? Has anyone in this room actually ever sent a telegram? I haven't. I never had the occasion. The funny thing was, in roughly 1976, I was working nights at a driving cab when I was first in school. And we used to deliver telegrams. There was a Model 28 teletype right in the cab office, and we'd pick them up and put them in yellow envelopes and drive them out to where they were supposed to go. The first couple issues of the digest bore news that Western Union was going to invest in Airphone. And I had maintained the Airphone system. And when I was on the radio board, long before it was hired, Twix had been sold to Western Union. There was some sort of court order. But it was always near and dear to my heart because I had been trained to maintain Model 33 teletypes. And if you ever want to get an earful about Model 33s, just buy me a drink and sit me down and I'll tell you everything you wanted to know about them. There were a lot of posts about new features, not only of the 1A, but things as you see here, picture phone, TSPS and tops, the singing clock, etc. And it wasn't until 1982 that AT&T did sign the consent decree, which ultimately broke up the Bell system in 1984. There was a lot of pushback. A lot of readers started in the denial phase of accepting it, and were saying this won't be any different, and so forth and so on. But the majority were very interested in what the future would bring and how the new paradigm would change the phone network they knew and loved. There was a lot of information about how to get past the frontline trouble desk or the clerks at the phone company if you had a problem with your modem. That got to be such a severe problem in later years, especially for high-price circuits like T1s, that many companies would routinely demand to talk to a third liner on their first call. And they'd want the guy's phone number and his home phone number, too. And given that T1 lines could bill out at several thousands of dollars a month, back when that was serious money, they would usually get very good service on those. And surprisingly enough, what I noted was that there were always a fair number of questions about basic telephone stuff, the old tip and ring questions, and whether I want to use the red wire or the green wire or the yellow wire in my house, and things of that sort. Some people just couldn't accept it. MCI and Sprint were coming in, and some of the guys that wrote into the digest were saying, "Oh, this won't happen, this won't change anything," et cetera, et cetera. The general opinion of the regulators was, no, nothing will change, and everybody will be fine, and ignore that man behind the curtain. And that was pretty much what happened. We all know that MCI and Sprint didn't go away, but at the time, the first reaction of many writers, many posters in the digest was obviously hope that it would. One of the big complaints that I was surprised to hear of, I hadn't read before, was that many of the readers were complaining that MCI and Sprint representatives would just lie to their face and tell them that things were perfect and perfectly usable when it was obviously not the case. I wondered if that was in contrast to the Bell Systems' old policy, the first case of a relatively major telecom company just lying to people just because they could. And we've seen some of the results in customer relations departments ever since. Pretty much the old days when you could depend on somebody to tell you the truth when you talk to the phone company are gone, and gone forever. There were a lot of questions about REN. Who knows what REN is? Yeah, there you go. I think my line totals up about 10. The FCC specifications for telephones you could buy in the store included a ringer equivalence number. One meant one standard 500 set Western Electric phone. And if you had a ringer equivalence much above 3 or 4, you had to have special equipment to deal with it. Most people were just had the usual 2 or 3 phones and worked fine. There was a lot of confusion in the early digests about our J11 and other interconnect kind of standards and how do they get wired and whether you should put the wires on pin whatever. I don't think people were actually wiring RJ11 jacks. They just wanted to be reassured that the phone network that they knew and loved wouldn't change all that much. The Notes on Distance Dialing, which was a publication from Bell Labs along about 65 or so, predicted area code exhaust in the classic area code allocation set, those with only 1 or 0 in the second position and never a 1 or a 0 in the first. Predicted exhaust in, I believe, 1987. The statisticians at Bell Labs are pretty good at their job. And there were the first posts about possible exhaust and people predicting it in roughly 1982. So I think the new competitors that were allowed into the markets were speeding up what had been an inevitable trend. I'm not sure fax machines were, the question is fax machines too, I'm not sure they were such a factor. Group 2 fax was a factor in that it did increase demand for numbers, but by their very nature, you'd never have more than one for a company, you see, and that was never, I think, a big draw in the area, because what really speeded up area code exhaust was that at the time, new competitors were being allocated 10,000 number blocks. They would get an entire exchange code in each area code, at least one. And of course, if they did business in 3 or 4 cities, they'd be getting 3 or 4 exchange codes. It took several years for the companies all to sit down and say, we're killing ourselves here, we better work out a plan. And they went to a system where they would split across thousands of groups for assignments in different companies. But when the independent carriers came in and were actually able to compete in the dial tone market, they reached assigned entire exchange codes, which did exhaust the area codes fairly quickly. And as I say, a lot of posts about, well, this isn't going to happen, or people being crabby and complaining about MCI or Sprint and so forth. There's always somebody who wants to turn the clock back. There's times when I include myself in that group, but we all know that that never works. There was mention, and this surprised me because I've been saying for years that I wanted to have one of these. There was mention of a company that was going to sell an electronic butler, which people would have to call twice or once or let it ring twice or something, and then they could call back because now the machine was armed and it would actually let the ringing through to your phone. And somebody else wrote in saying, well, you can't do that. First of all, it's illegal because you're defrauding the phone company of revenue by using their signaling system without fee. And secondly, at that time, one of the big features of SS7, which the network was rapidly being converted to, was that it divorced audible ringing, the one a caller hears, from physical ringing, which is the one the called party hears. That was done deliberately to avoid exactly this kind of scheme where you would count the rings and 3 means I landed okay, and et cetera, so that people couldn't use dialing and ringing codes to avoid long distance charges. As you can see here, the second phase of the adjustment to the new paradigm was a lot of people got mad and started sending in flames and other troll bait that said AT&T was doing them wrong and so forth and so on. Again, I don't think it was serious, just people felt out of balance and uncertain about how much the companies were changing and how quickly. This one surprised me. This was in February of '82. I noticed about a new phone system called cellular, and the FCC's decision to allow serious investments in the new cellular system. I hadn't realized it had gone back that fast or that far. The first cell phones that were available in the Boston area came about roughly in the 1992-3 or so range. $480 for a 1200 baud modem. 1200 baud was pretty hot stuff in 1982. And this guy was saying, is this real? Can I really pay only $480 for a 1200 baud modem? As it happened, I was in school in 1982. I happened to have a 1200 baud modem, a genuine Western Electric 212A, which had fallen off the back of a telephone truck. Well, I had a reason to have it. As I said, I was in school, and we were still using punch cards, believe it or not. I have a stack of them in a drawer someplace that I found just a couple of weeks ago. And at the end of each quarter at Northeastern University, the punch room would be totally busy. The line would be around the block. And I told my professor, hey, I'm holding down a full-time job and doing this other stuff. Give me some help here. And he gave me an account on the dial-in system, which it turned out would take a 1200 baud modem. So I managed to obtain one. It made quite a difference. It was saving me a world's worth of time, waiting for those key punch machines. Anybody who's ever dealt with a key punch machine knows those ancient behemoths had 10,000-pound test keys. You could pound on them with a sledgehammer and they wouldn't be bothered. And I speak as a guy who learned to type on a Model 19. Yep, some things don't ever change. Crank callers. And there was something, as you see, about San Francisco and how this new device could read or reread or delete messages sent to it through some electronic connection. It's probably the forerunner of the digital pager, but again, I was very surprised that it had happened that early. And just as an aside, see if you like this one, I was living with my brother-in-law, and he came home. He was just out of Worcester Polytech in 1983, as I recall, and he came home one day with a big old Motorola brick pager on his belt, the ones that had the tuned reads in them and the batteries that would last 3 or 4 hours or whatever. And I said to him, "You must be an important person. You got a pager now." Don't ever forget this, because it's true, as true now as when he said it. He looked at me and he said, "Bill, the important people do the paging." Telegrams, as I say, they were gone. They were just fading away, and there was a story in March of '82 about a guy who wound up in the London airport and had a flight delayed and wanted to send a telegram, but they told him point blank, it'll be 2 or 3 days before it gets delivered, but if you send flowers by telegram, it'll be delivered today. So you can bribe them and pay extra. And because the flowers might spoil, they'll deliver it today. It was a shame. Telegrams were an essential part of our economy, and I never thought many businessmen used them at all well after fax machines became available. C'est la vie. One of the first things that came about in the data revolution was that savvy system administrators and computer planners would rent what were called burglar alarm circuits. It's just a dry pair. It's a tip and ring from one place to another. And they were supposedly used for DC signaling. At the time, the phone company still sold circuits for burglar alarm use. And they would attach line drivers to them made by various companies and use them as digital circuits so that they could get a lot higher rates than even at the time. The premier standard for data transmission was the T1 line, which was, depending on how it was arranged and used, either 1.544 or 1.536 megabits per second. But you could get up to 10 or even 15 if you had a short haul and just a couple of burglar alarm circuits between two buildings. It's not the proudest part of my life. We made it our business to frustrate those who tried to do that. The attitude among the craft workforce was if they wanted high-speed data, they should damn well pay for it. And one of my favorite tricks was to repair burglar alarm circuits by finding two defective pairs, one with the tip open, one with the ring open, and so forth, and connect the burglar alarm circuit to those. There was no specification for audio quality, of course. It was a DC line, and all it needed to be able to do was close the burglar alarm relay. But, of course, the people that were using it for other things would call in and complain tremendously about noise, and we tell them, well, sounds like you want an audio line, go talk to sales. And as I say, not the proudest phase of my life, but then again, when you're on the swing shift at Back Bay and making really good money and you even have a car, I mean, you know, that was high living for a Vietnam vet in his 20s. And I look back on it and I say, well, I understand why I did it, but I guess I really did drink the Kool-Aid on that one. Lease lines, and there were a lot of them at the time when the digest first started out, roughly the 1980 to 85 time period, it was very common for companies with PBXs to connect them with leased lines to avoid dialing expense. Most PBXs were provided by the phone company at the time, and they were manufactured and installed so that it was impossible to use them as tandem offices. If you were in Boston and you wanted to call Framingham, you'd pay for a toll call to Framingham, even if you had a PBX in Framingham and a leased line between your PBX and Framingham. They wouldn't let you jump across a tie line to get out into Framingham and complete a call that way. You had to pay the toll cost into Framingham. And since good old Ma Bell supplied all the PBXs, well, businessmen had very few choices. It wasn't until there was substantial competition in the PBX market and all the competitors offered tandem dial-out service and Watts boxes and things of that sort that Ma Bell learned to loosen up a little bit. There were a lot of problems with linemen and the old tip and ring guys. They'd click a Budinsky set on a pair, the lineman's handset, of course. And if they didn't hear anything, they didn't get dial tone, they'd say, well, this is spare. Well, we'll use this one. Got a bad pair, I need a pair, we'll use this one. And, of course, they were stealing it from some audio circuit or some data circuit or whatever. The special service crews who had to go out and fix what the lineman left behind started putting resistors on them so that the local test board, when it looked at them, would see a resistor out at the subscriber location, called a sub in the trade, and wouldn't try to steal the pair. even in 1982, there were devices available to allow what are now called nanny cams. Except there was no camera, you could just listen in, but I assume people would call home and trip this device that I wrote about here and see if there was a vacuum cleaner going or a party going, and go from there. The funny thing was that it turned out that the device this company was selling was a version of a black box. It would trip ringing but not supervise the line, so people could call home and listen to the nanny without actually paying for the call. And needless to say, that wasn't a successful paradigm. There were many follow-ups. People talked about wiretapping, and there was an entire thread that ran for a better part of a month about some kind of indicator to show whether your line was being tapped, and basically at some point cooler heads prevailed and said, you can't, it's utterly impossible, don't even pay the money for these things. The first point is that, under $500 modems for $1,200, and we'll put up a 300 baud until then. Yes, these were real people who really thought that having a 1,200 baud modem for less than $500 would be a great advance. At the time, they were right. And as you can see, my feelings about VI, well, I use the one true editor. I don't know. What do you think? Could it have been the Clunk system? If his name had been Alexander Graham Clunk, we would have the Clunk system. Mm-hmm. And if his name had been Siren, would phones ring or would they wail? Well, that's a pass for humor in 1982. Oh, yes. Yeah. I know. He eliminated all the jobs in broadcasting. His people at the FCC made my expertise and that of a lot of other guys useless. I don't know who Frankston at Frankston.softars was, but... Say again? Ah. Well, he didn't like the fact that the phone company wasn't being as responsive, as you can see. This struck me as funny. There was a thread on the Minitel system that was being installed at the time in France, and a lot of people questioning whether they could get it to work on regular telephone lines. If the Minitel system was a character-based replacement for information operators, and France made it work, made it successfully work. And as you see here, it was recently retired. There were a lot of the farmers that used it during those, 30 years? It didn't want to do without it anymore. They just were content with the character-based terminals and being able to get phone numbers and what they were used to. Phil Karn, who was one of the savviest guys ever in cellular design, was also a ham operator, still is, and designed a software package that would allow ham operators to hook up their radios and do TCP/IP. In fact, each ham station became a router on a packet radio network. The internet had nothing to fear. The hams, just because of technical reasons, were pretty much limited to 1200 baud, and if you wanted to go higher, you had to modify your radio. And I once spent, right around 1993, I once spent the better part of a year, in my spare time, trying to find paths, microwave paths between various ham stations to get faster data transport rates. It didn't work out. I found out the hard way. New England has all kinds of hills, and everybody who owned the top of one wanted to be paid. the elimination of the Morse code was a hot topic in ham radio, and I think it was good that the debate sort of died out, at least on the Telecom Digest, because on the ham radio news groups and so forth, it continued for years. I, as it turns out, am what is called an old law extra, and I passed the same code test as a commercial operator would, and having climbed the mountaintop, I'm entitled to say that the view was not worth the climb. The Morse code it's gone for a reason, and good riddance to it. Mm-hmm. If you've ever been in a panel office that was in service, you know what I mean when I talk about the ordeal of burnt burl cream. Because Rube Goldberg found a home in a panel office. They were these incredibly long stretches of rotating, motor-driven clutches and drive shafts, and clutches which would raise rods under electric command and so forth and so on. It was a mechanical engineer's either his best home or his worst wet dream, I'm not sure which. But I started out in an office that had panel, and you never forget that panel office smell. There was some debate about where the last panel office was going to be, or was at the time, but it was already on the way out. The funny thing was, after we cut the panel office, for a better part of a year, you'd be going by and one of the rods would just start to raise on its own, as if there was still somebody out there with a phone connected to a panel office desperately trying to get through. And we never did quite figure out why, but every so often you'd get a ghost call in the old panel office until they finally did just pull the fuses and turn the motors off. It all went for scrap, but quite frankly, I saw some of the old switchmen crying. It was, they'd given their life to that machine. You'd be amazed how attached they had gotten to it. Charles Luff was interviewed in an old switchman, and as you see, it was sort of a steam engine. They have panel offices in museums here and there, and if you ever do get a chance to see one at work, I recommend it. It's unforgettable. I don't choose to comment on the dress code. Poodle skirts, or whatever they call them, and starched white blouses were the norm. And because they had to keep the panel offices so hot, they would bring in ice and swamp coolers, basically, try to cool down the operators. There was really a magneto office in Bryant Pont, Maine. If you wanted the operator, you had to turn the crank on the phone. And residents were told, great news, we're going to give you dial phones and you're going to be joining the 20th century. And a lot of people in town said, no, we don't want to. They didn't get to stop it. It did come about. But I can understand how they felt. They figured the old system worked fine. And there was always an unwritten contract in those small systems, which sociologists have written about, better minds than mine, frankly, about how the operator was expected to be not only a switcher, not only someone who completed the call to a desired number, but also a local information store. She had a call from Mr. Jones to Mrs. Jones. He might be told, well, she's not at home, she's over at the hairdresser's, I'll ring there for you. And people could be found and get along quite a bit more easily because the operator knew who everybody was and where they were, most times of the day. Mm. Yeah. Well, the story goes, and it's one of those stories which has to be true even if it's apocryphal, that the guy who invented the first step-by-step switch, the Stroger switch, was a mortician named Stroger, who was mad that the operator in town, who was married to his competitor, was giving his business to his competition. So he decided to invent an automatic telephone switch. And if it isn't true, it should be, but that's where the automatic telephone switch came about. Stiff competition. Oh, come on, I couldn't resist. The ASCII twist network. Somebody had written in, there was something about a MASH program where one of the actors said, I've got a Twix for you, and somebody was criticizing that as being an anachronism. And someone else sent in, no, it's not true. Twix was invented in 1931, which surprised even me because I had been so involved with the teletype operations. Although, as I say, Twix had been sold to Western Union before I was hired at Mother Bell. There was a 60-speed Twix network using the old Model 15 and 19 machines. Way back when, it had manual operating cord boards, and the operators, of course, had teletype machines of their own. They would address requests for numbers or connections or whatever by using a teletype. And it was one of the odd things how my career in Ma Bell spanned so many different groups that I picked up pieces of knowledge here and there. One of the pioneering studies in how to prevent hearing loss among telephone personnel revealed that Twix operators didn't suffer from the same degree of hearing loss as their voice counterparts. And it turned out that the operators who wore the headsets were having a lot more problems because, first of all, they were getting differentially imbalanced hearing. Having had the headset on for 12 years, I suffer from that myself, which tends to deprive them of stereoscopic hearing and introduces a lot of errors in what they hear. But the Twix operators, although in a noisy environment, so to speak, didn't have that problem, and they were able to make some very good changes in not only in the designs of the headsets, but in the addition of click prevention circuits to stop the old headsets from lessening the hearing of the operators. As I say, I learned to type on a Model 19, and those things were indestructible. They really were. The Twix network was okay, but then the Model 33, excuse me while I digress, got a bad reputation because DEC put them on all of their VACs and other small computer systems they sold to schools. The 33 was available, it was cheap, but it wasn't designed for what they were using it for. It was only designed to be a Twix machine, so it got a bad reputation I never thought it deserved. The first commands for the Hayes modem. I almost titled this ATS0V1, but I didn't know how many of you would get the joke. The rest is history. The greatest changes in the phone network were at the end of the electromechanical age, and that's when, as I say, the stuff that we had all used for so long. They had coaxial cables on the center strips of the interstates, and some of them still there. They've just been abandoned in place, but they were the head ends. The head ends for those cables, the L5 centers, strangely enough, were all located near major military bases. And the coaxial cables were buried at a depth which was adequate to prevent electronic spiking, what would be called electromagnetic pulse now, and so that the military, if nobody else, could still enjoy communications. I knew an installer who complained at great length about how when he was installing new equipment in one of those centers, he had to take each frame down individually through the air vent, which was literally shaped like a civil defense warning sign, and that was a symbol of an air vent that you could close. And he had to take stuff down. You know, none of the vanes lined up, so he had to go down, and they'd have to move the thing, and then he'd have to go down another one, and so forth and so on. They were quite labor intensive, but the coaxial cables were gone. They were replaced by fiber, needless to say, and well, I don't think much has changed since then. Electronics became digital. There were some early transistor drives designed which gave way to integrated circuits. Who cares? The biggest change was right there, right at the start when I was in the thick of it. Telegraph signaling and private lines gave way to shared arrangements, and now it's unthinkable for a guy with a PBX to pay for a tie line. He wouldn't do it. He'll just have either a VoIP line on the internet if he has the traffic to justify it, or he'll suffer the message units and not pay for the tie lines. And last but not least, I thought I would show you the first official post of the Telecom Digest. Where a guy complained about the high cost of AT&T service. Yep. In 1981. Well, I don't blame him. Of course, AT&T was morphed into what used to be Southwestern Bell, but now and then I think, yep, there's a whole story there too. I could write several books about the high cost of AT&T services and the ways people tried to get around them, and I sympathize with the guy, I really do. Thank you for your time. I appreciate it. Hope I haven't bored you to tears and provided more light than heat. But the Telecom Digest remains the oldest continuously published e-zine on the internet, and feel free to come on by comp.decom.telecom and take a look and contribute what you will. Appreciate it.
Oh, sure, yeah.
You know that one, okay.
Yeah, of course, yes.
You know, it's funny because it's like, you listen to it now, it's like, hey, he's all.
going on over here? No tracking in Flushhead. That's incredibly disappointing.
Is this your orange extension card too? Yeah, I think so. Okay, I'll just put it with that.
Anyway, so I'm going to go back to this Washington Post page we saw a moment ago, and let's see whether anything has changed when we reloaded that giant pile of domains that we saw before. Actually, a lot of this is still green. A few things getting blocked. Let's do a few more pages then. Amazon's not very tracky. It's like YouTube. The big online companies tend not to have these giant piles of third parties because they run them themselves. Whereas the news sites and what was our BuzzFeed? I guess. Also, what you tend to find is when you click through an article, you get a lot more tracking.
Just further into the screen. Somebody did cell phone here? Go right to the wall. Just let me go black right It's right here.
Go back to the Washington Post. What you'll also notice is that the ads are starting to actually start. Now, Privacy Badger doesn't explicitly target ads at all. It actually just treats them the same as everything else. It just happens. So we're starting to see that even these trackers that were green before are actually being marked as things that are not respecting the do not track request. And as I said, it's not targeting ads specifically. It just happens that ads don't respect the track they put you. When you see an ad on the web, it's actually seeing you and seeing the page you're on and writing that down in a database or in 10 databases. So let's go back to the slideshow.
They're like one of the
premier. And one more thing I want to show you. So all of this you would have seen if you read the beta version of Privacy Badger. And there are a couple of cool things we've added in the
shiny time card.
Sorry, all of this was in the alpha. We've got this beta that's launching. You can actually get it on the site right now, even though it's not labeled as such. So, this is
not worth living with the hell you do that.
If you're blocking a domain, this will happen by default. This is not fully implemented yet. It doesn't. We're getting success with one of these widgets here. Privacy Badger is starting to incorporate code to recognize these widgets that are things we see everywhere. And of course, widgets like ads see you when you see them. They track you. When Privacy Badger would block a widget in the alpha version, they just disappear. You just lose the widget from the page. What we're starting to do is drop in little Privacy Badger versions of the widget. So this is, instead of making the Google Plus widget disappear, if you want to interact with it, it turns it into this little button, and if you click that button, it turns into the real Google Plus button. Or with the tweet version, it'll just go to Twitter and open a tweet button. So in cases where the functionality and the tracking have been really woven together and it's really widespread, we're starting to deploy a mechanism to let you still have that functionality and turn off the tracking at the same time. But going back to the slides here. I just want to talk a little bit more philosophically about the state of the web. It's sort of an open question about whether we're willing to live with advertising. I think let's ask this room. How many of you, and maybe it's unfair to do this after this talk, how many of you guys think, well, advertising sucks a bit, but actually it's worth keeping, it's a respectable and honorable way ultimately to pay for stuff that we can give away for free? Can you see hands for that? About a quarter of the room. How many of you say, like, let's just get rid of it? Actually, about a quarter of the room, and the other, I think the other half of you are like me, somewhat conflicted on this question, or you're not paying attention, one or the other. And so I don't think we have a good answer to whether we want advertising or not. I think we want to let users block it completely if they want to do that. But as a society, we're going to be living with it's not going anywhere. It's a necessary funding mechanism for a lot of stuff we value. And so in that situation, I think it's non-negotiable that it has to stop violating people's privacy without consent. This is and that's something we think we can deliver with this project. And you guys can help, actually, by installing it yourselves, helping your friends and relatives to install it, and coders on GitHub, if there are things that break, come and tell us about it, help us build new features. And so I think we're going to get this piece done, one way or another. The other question, and this is a question I want to hear people coming back and giving talks about at H.O.P.E. next year, saying, I built this thing, it's a new business model for the web, go out and use it. Because you guys have the skills to make this happen, whether it's better versions of donations, whether it's, if you're European, actually the Europeans have all sorts of traditions of using public funding to pay for authorship and artistry. Maybe someone in Europe should go and figure out how to get their government to pay for awesome websites. There's a lot more that we can explore. Maybe it's those cryptocurrencies that by their nature pay artists as they use. Let's investigate this stuff, let's make the web better, and remember to install Privacy Badger, and I'll take some questions.
Hi, so as far as the ad revenue that a lot of sites use, there are plenty of sites like webcomics and blogs that the owners wouldn't be able to have those up without the ad revenue. How does Privacy Badger affect the ad revenue that they gain when you visit their site if there's tracking in those ads?
So what we hope the answer is going to be in a month or two is not very much, if at all. What this is going to take is one advertiser that complies with the do not track policy. And then as soon as there's one advertiser that does that, we can go to all those webcomics and online small businesses and say, hey, you were using like advertiser A yesterday, and they were tracking your users around the web in a completely creepy fashion. Here is your alternative B. Either switch to them, or just switch if you see a user who's sending a do not track request. You don't have to do it for everyone. You see a do not track request, don't load the JavaScript from the first advertising network, load it from the second one. And so that's what I mean by we want to create incentives for this industry to behave better. And so we're actually in the process of sitting down with some advertising companies that we think are more progressive on these issues and trying to figure out whether any of them are willing to be that pilot for doing it.
Can Privacy Badger work as a fallback for NoScript, or how does it respond to a pre-lockdown browser, a browser with cookies disabled for certain sites, etc.?
Yes, so that's a great question. So with NoScript, it actually plays pretty nicely. I think that as a NoScript user, at least some of the time myself, I feel like I always want to have an extension that just looks at requests my browser is making and says this subset of requests tracking requests I don't want my browser to be making, throw those away, and then what's left, I want to be able to manually line script JavaScript for those. And so I think that NoScript plus Privacy Badger is a pretty good power user experience. And then in terms of blocking cookies, we had some issues with this in the alpha because the way we were detecting the tracking was instrumented around API calls that cookie blocking settings in your browser would prevent from happening. We've gotten a little better about that by starting to look at, we can't catch all of the cases, but when you have an incoming HTTP response with a set cookie header, you can inspect that. And even though it's never going to set the cookies, you can say, well, it would have set this cookie, that would have been a tracking mechanism, so this third-party domain is trying to do that, I'll keep a record of that.
Hey, I just like to say this is my first H.O.P.E. ever. It's like the best.
Welcome. Actually,
I've never seen a room filled with so many intelligent people that desire for the truth.
Thanks, everyone.
I mean, this is my question. You know, I'm somewhat of a noob, so to speak, but you know, that's kind of besides the point. What I want to know is, how did you establish and formulate and build your brick road, your yellow brick road, to your, I don't know, your affiliation with what it is that you do? How did you build that brick road? And can you give me 3 functions that you threw into the concoction of the mix of how you formulated of what you're doing now?
Okay, sure. I mean, there are 2 answers to that question. One is, how did I wind up being a technologist at EFF? The short answer to that question was, I think I was, there were 2 moments. One was, I'll skip to the second one. I was a computer science student working on my honors thesis, which is like an American senior thesis back in Australia. And I was, as probably everyone trying to finish a thesis or dissertation of any sort does, I was reloading web pages, and I was reloading Slashdot. And I came across the article about a guy named John Leif Johansson, who had written a video player for Linux, and he had done this awesome, a DVD player for Linux. He'd been arrested by the Norwegian government at the behest of the MPAA, these guys we had on the slide before, for having done that. And I got really angry, and I said, well, actually, rather than writing code, what I really want to be doing is defending the internet against clowns like Mickey Mouse. So that was how I ended up, on the road to studying copyright policy and get that slide. Studying copyright policy and working at EFF. The question is, how did I end up working on this design for Privacy Badger? And actually, that came from running NoScript and live HTTP headers and other tools for understanding what my browser was doing. And then I kept looking at what they were doing, what the browser was doing. What the hell? Why is my browser sending information about the page I'm on to a dozen other companies I've never heard of and have no relationship with? And I started to unpack that.
George Soros.
Yeah. I started to unpack that and wrote a blog post or 3 about it for EFF, and then that started, the press responded to that, and that put us on the yellow brick road, if you like, to Privacy Badger. Anyway, thanks for the question.
Thank you for Privacy Badger. We all appreciate it. My question is, invasive marketing, these people, they don't regard us as people. They see us as dollar signs. They just don't give a damn about who we are. Okay, so why should we give a damn about them? Why not have, instead of Privacy Badger, grow some fangs and have Privacy Beast? Privacy Beast basically tinsels them with chaff and fills their databases with garbage and short circuits their profit model.
So Privacy Badger is GPL, it's free software. You can...
Excited to see what this goes into yours. I'm sure that you've heard of the Epic privacy browser.
Yep.
Yeah. My question is, how does Privacy Badger compare to the features that Epic has in terms of tracking?
So I haven't audited it to compare. The versions of this question that I can answer are Grocery, AdBlock Plus, and Disconnect. In our experience of those 3, Grocery doesn't block much stuff by default. In fact, it's Grocery is produced by a company that works with the advertising industry. So their first function is to figure out what trackers are out there on the web so that they can sell that analytics service to those trackers themselves. And often sites don't know what trackers they have inside them. because some web developer included a JavaScript embed, and that included 5 other JavaScript embeds, and no one ever figured out what was going on. So Ghostery's primary function in life is to provide that data to the advertising industry, and its secondary function is to, people who care about privacy can manually go in and make Ghostery start blocking things. But people who use it a lot tell me that when you really go in and drill down and try and make it block everything, it winds up being too aggressive and breaks a lot of stuff. AdBlock Plus, by default, doesn't block any invisible JavaScript. So it'll take out all the ads from the page, but unless you go and manually subscribe to a different block list than the default, you're going to get protection against that kind of tracking. And so we wanted something that would just, by default, single-click install, get you that result. Disconnect, we actually probably like the best of those systems. It's pretty good, and we've been talking about collaborating with them on the technical pieces of maintaining versions for all the different platforms that are out there, because there's quite a lot of engineering work to being on mobile, being on Chrome, being on Firefox, etc. By default, it doesn't block any invisible trackers. So if the page contains like a 1x1 GIF is the classic version of an invisible tracker, these days that's largely being replaced with JavaScript that's fetched and does XHR posts back to report information about you. That stuff, by default, doesn't block.
Well, when you all get the chance, I'd love to hear a comparison about this versus Epic. I use Epic, but it's unwieldy for certain things. I'd love to see how this stacks up.
All right, we'll do that.
Hello, thank you again. I'm a little confused about the way you retroactively handle cookies. So let's say that a service gives you a cookie, and at first, Privacy Badger says, nothing fishy about this, that's okay, you can put the cookie there. But then later it starts doing stuff that starts to get blocked. Does Privacy Badger do anything to the pre-existing cookies? Does it stop them from being edited? Does it delete those cookies, or does it leave that functionality there for the already okay sites?
So there are, this is a great question.
Would the ability to control the way that Privacy Badger handles those be in the settings?
Yeah. So what Privacy Badger does, when it sees a third-party domain, it shows up in that little drop-down. And then every time it sees a third-party domain, the first question it asks is, in this context, does that domain look like it's tracking you? And so it goes and looks at all the cookies that are in the cookie store for the domain, all being set over the HTTP headers, and it says, is this cookie, not obviously kosher? And an obviously kosher cookie is something like cookie whose value is 1 or 0, true, false, lang equals en, or some other common language code. Those cookies, if there are cookies like that, it actually does a little entropy calculation for the total set of all of those cookies, and if it's below a threshold, it'll say, that's maybe not tracking. But if the cookie is a long random string, like an identifier, a session token, whatever, that looks like tracking. And so, sometimes these third-party domains are not really tracking domains. They're just an isolated subdomain that's part of a first-party experience. So it keeps a record of how many first-party domains it's seen that third-party and its cookies on. And if it sees it across more than 3 origins, then it says, oh, wait a minute, this thing keeps showing up in different places, and it's in a position to know my rating habits, not just on one site, but on 3 or more. Okay, it's tracking. So that's what causes the slider to move out of the green state in the browser. Whether it goes to red or yellow, usually by default it'll go to red, unless we've graylisted it and said, actually we start documented instances of this domain being necessary for functionality the user wants. In which case, we put it into the yellow state. That means cookie blocked. In that state, we just do the third-party cookie blocking operation. We try to prevent the domain from getting access to its cookies when it's a third party. But if you go back to that site as a first party, you'll have the cookie again. So an example where you want that is Google.com. When you go back to Google.com, you may want to be logged in to read your mail or have a logged in experience. So you'll get that, but on the third party context, you'll be logged out of it. And then if you want to manually change how Privacy Badger is behaving, you can just grab those sliders in the drop-down at any time and manually set them to any of those three states. Green is allowed, yellow is cookie blocked, red is completely blocked. And so you can choose how you want it to act.
Okay, so if there was one, so we all know that do not track is, how should we say, hard to enforce, and great job making software that actually does that. If there's one thing that we could do to fix the current mess over cookies and tracking, technically do, perhaps as a technical cross-browser standard, because I do work at W3C, what would that one thing be?
Okay, the question is, what one change to the web would we want to make as a cross-browser standard to make the web better? And I think, we tried that at the W3C. What we would have said was, here's a strong policy document that sites have to comply with when they see a DNT line header. Because and that thus far has failed with the W3C. We'll see whether we can one day, a few years down the track, if Privacy Badger and other things like it get enough momentum, maybe we can go back and have that conversation again. But the problem is, if I can't have that policy solution, I'm stuck with, okay, I have to deal with referrers, cookies, super cookies, fingerprinting, all these different tracking mechanisms, and I can't give you a single answer that solves all of those manifold problems at once. Yes?
Oh, hi. What does respect for DNP entail? If somebody's tracker wants to be acceptable to...
That's another great question. So unfortunately, I didn't have the slide on this. I have 1 minute. If you go to eff.org/DNT-policy, you can read the answer to that question. The 1 minute version is, if the user's not logged in, you need to throw away all your unique identifiers for them completely. No cookies that are unique, no super cookies. If they are logged in, then you need to not keep those past the time when you've served the HTTP response. And then there's a lot of compromising with reality that are in the document. So it says, yeah, but if you have an explicit transaction that the user is engaged in, like they're about to post a comment, you can keep the data associated with making that comment happen for as long as you need to. And if you have evidence that the user is attacking you, they're launching a security attack or they're engaged in a fraud or whatever, then in specific instances where your systems believe that, you can keep that data without complying with the policy. Oh, but you can't just launder violation of this through a third and fourth party, so you're obligated to make sure that if you embed other stuff, it also complies with this policy. So basically it's about a 2 to 3 page document that tries to navigate all of those things in a way that we think is seriously privacy preserving, but also something that a large-scale website could realistically do. We've been going around and talking to people and hearing, yeah, this is a hard ask for us, but we think we can do it. Actually, we have, maybe I don't want to say, there are actually some significant websites that you guys use that are now doing this. So we'll be saying more about who they are and doing a big, a big press release about it when we have maybe a dozen of them.
In the orange cookie block state, is it just HTTP cookies that are blocked or not sent, or are there other strong identifiers that are prevented?
So that's a move. At the moment we do HTTP cookies and maybe DOM super cookies. We aim to do all of them, but it's development work, and we could use pull requests for some of that stuff. Especially anyone who's a really good Flash hacker, we could probably use your help dealing with Flash because it's such a hard thing to control from the browser. All right. I don't think we have more questions. I just want to, I think this is on my slides, but I also want to just shout out, I know a number of you are in the audience, people who actually helped to write the code for this project. I only did a minority of that. Yansu and Cooper Quinton, Franzi Rusna, Garrett Robinson, Jonathan May, and Dan Alba. Thank you all for your help. closing ceremony. Thank you, H.O.P.E, for being awesome.
And just a reminder, if anybody wants DVDs, please place your orders early so we can get caught up on that. We should be almost caught up before the closing. Thank you. And if anybody's interested, I will be here until like 6 a.m. running discs, so you can always stay around.
This morning I was taking my stuff down and I found this step down here and I thought I don't recognise this one I asked you about. And I realised that it's full, so I put it here. It's a mini with a little white strip around it.
What does it step down?
It's just a pad cable, you know.
You got the disc out of here?
Good evening.
And I tried it in a loop, so it's like a thin cable. Anyway,
Ladies and gentlemen, welcome to closing ceremonies for H.O.P.E.
I kind of dumped it on top of your.
This is the 10th H.O.P.E. 20th year. doing okay, huh? Before we get fully underway with the closing ceremonies, I was approached earlier by an elderly gentleman. He asked to say a few words.
And happy. So, a little bit about myself. I am a psychiatrist. Yeah. I'm a psychiatrist. I used to study social outcasts. The last thing I did was in the 1980s. I did research on live action role playing, and I took an arrow to the knee. So that pretty much ended my career as a professional. Ever since I'm interested in things like 9/11 was an inside job and stuff like that, the connection of various things, I can hardly stand. I'm a God-fearing person. That's what I want to show with this slideshow here. And I'm very open to certain groups like Black and stuff. Yeah. Okay. So this is my grandson. Yeah. Today I'm here to talk about internet culture. Yeah. What do I mean with internet culture? So, for example, puppies and goatsy. Yeah. Yeah. I'm very interested in the strange subculture of hackers, and I want to present it to you, my dear friends here at the Retirees Club. So let's go on. We are all as citizens of the United States of America, which I proudly am. I helped the space program and stuff. It's all okay. We are all targets of mass surveillance. Yeah? Mass surveillance is targeting us like NSA. The no such agency and stuff, and so what I want to do today is address the problem of talking to hackers, because I think we need to talk to hackers to get rid of this mass surveillance, especially because I don't want that so many things of my past come out. Yeah, so we want to talk to hackers, but the main problem with hackers is they are targeting the huge data masses. They are targeting what they think is wrong, like surveillance and stuff like that. We have to convince them in a different direction, and that's what I want to tell you today. So, fuck. So it is actually a song. I do not have any instrument. I cannot play an instrument. I also couldn't find anyone to play an instrument for me. So except my other grandson who is in the basement. Okay, so let's try it. This is the song, okay? It's based on an old Viennese folk song. People, the world is a dismal place. They monitor every step. They're online and offline and in your face. The Freemasons are just a hip. On forwarding, forthright and straightly our facts to the Illuminati. They hide in the cookies as internet cache. Golly gosh, that is fresh. So, I have 10 more. So, chorus. When I see everywhere. I shatter it with my cane. And if they replace it because they are not aware, I'll shatter it with my cane. And if then at some point they grasp it, all these electronics are fast, shit. We want the police back and guard and in charge. Nobody does it like such. This is basically my message. We have to replace all security technology by police officers. You know? Because we can't trust humans, we cannot trust machines. You know, that's what I learned in the Third Reich. So, okay. So, there. Yeah, more. You lack Olive Garden's Alfredo sauce. Well, the NSA already knew. They collect all our data just there because with electric machines, yes, it's true. For the data retention principle, you need honest guys. It's that simple. The NSA is the new KGB. This doesn't sound funny to me. I mean, let me summarize. Policemen need fresh. They need to patrol and they get out of the cathode ray tubes. No circuitry, no cybernetics. We claim situational ethics. I am looking for freedom, but not like the H.O.P.E. These cameras turn me off. I like that very much. It doesn't end. What have I created? Atari PC had 2000. These hackers are hacking with every brand. They want you to stand with your back in the wall. That's why we should shatter them all. So, thank you. Thank you, my wife, my dog, Michel Foucault, and the Rotary Club in Sleepy Hollow. Bye-bye.
Well then. I'm told that discounted airfares to Austria are very popular these days, and Johannes is one of the saner people over there, so it's a very interesting place to go. Well, we did it. We're at the end, and this has been the most awesome one yet, right? We'll have more people speaking about particular things, but I want to definitely recognize the efforts of AV in this particular conference. It has been phenomenal. Maya, Adam, all of you. I'm blown away. Just for what you guys accomplished yesterday, getting Edward Snowden, getting the connection going. We heard from people at South by Southwest who had done this, that we did so much better as far as getting it to work, which is always good to hear. And of course, there are so many efforts. People here to say a few words about various things that have gone on. One of the things I really want to recognize is the network itself, because the network is something unprecedented here. We had 50 megabit in 2012, and we weren't sure. A few weeks ago, you heard about the whole thing with the distributor. We were having all kinds of financial issues, and we weren't even sure we were going to be able to get the same net connectivity. We were thinking, we were having conversations. It's not really about the network, right? People can come here and just watch the talks. That'll be fine, right? No one's going to complain. And, yeah, well, And just, when things were at their darkest, Kyle here, who set up the network, decided that he was going to go out and get an even better network than we had before. And that's how we wound up with a network 200 times faster, just when we thought we couldn't do it at all. And that's the hacker spirit, right? This is the guy to thank for this. This is Kyle, and he's got some people to thank.
Hi there. I could tell a lot of really amazing long stories. We were kind of up and down. I wanted to do this from the start, bring in our own line, and we've had a standing offer with Hurricane for a while, but we've never been able to make it happen. And it was getting really close. We had some problems getting permission with the hotel, and obviously the management situation has been changing a lot here lately. Anyway, fast forward, the contracts, nothing was really happening. People weren't talking, and we weren't getting permission to do the microwave fast enough. And I got really frustrated with how long that was taking, because we had like a month to go. So I made an inquiry to the people at RCN, and then I reported back to my network team, which is freaking amazing. You're going to meet pretty much the core guys and a lot of them in a minute. Anyway, and we'll discuss in detail exactly how that went down. So basically, in the last month, we got the right people together, and it was a really interesting coincidence of certain people getting involved and getting the right people talking. I'm really just interested. People have asked me, so what is your interest in leaving the NOC? What is your interest in doing this? And I've said, well, I'm a hacker. I'm really interested in this stuff, and I'm not really doing this regularly, but I know enough about it, and I'm interested enough to think of an idea and push it forward. So that was really my goal, but I knew I needed a ton of help to do it. Anyway, I'm not going to get into absolutely all the details of how those communications went and what it took. So, because I think that guys are going to lay it out pretty clearly what we ended up with. But we eventually worked with RCN and got a patch, and then it was weeks of uncertainty about permission and exactly what the hotel would allow us to do. Anyway, again, it took a long time, and I was really uncertain and frankly scared to death that I was going to disappoint. And well, we have a whole new core in the NOC, and it's a whole new team, and that itself was really odd, because I was creating teams with people that I hadn't met and that probably hadn't met each other. So that additionally made it kind of really nerve-wracking. So. Without further ado, I'm just going to thank everybody I could think of in the last couple days in between doing other stuff, and then the rest of the story I think we're going to share with you during our presentation. So first off, I'd like to thank Emmanuel for believing in me and letting me kind of run with the ball and see what we could do. I'd also like to thank McFly. He couldn't be here, but he helped set up a lot of other connections. I'd also like to people connections to get talking to the right people and get us moving. Winnie also helped a lot with the design. It's not necessarily network stuff, but he was very involved remotely from Germany. And on a related note, Niels from the CCC and the C3 NOC in general, good friend of mine put out an inquiry over Twitter and stuff like that, and they actually talked about it and came up with, what they could do. And to that end, Attila, who you'll meet in a second, was able to communicate with me and sort out stuff with wireless and a lot of other core stuff that we put together. I'd also like to thank Draghorn, who was our previous NOC lead. He did a fantastic job doing a write-up of what he'd done in the past, and we were able to use that as a template and take the good from it and then improve on what we thought was feasible. Let's see, Nick God helped a lot, and there's another whole batch of people from our group that I just didn't have time to add. I'd also like to thank Roach and Dragos and Jacob and a lot of his friends and some of the other guys that just showed up as volunteers. Also the knock pool, they helped us out a lot as far as coordinating another set of access points. We got half from Cisco, and then we got the other half from knock pool. And Nick Farr helped out with that. He helped fund a little bit of the deposit for that. That was good. Also, I'd like to thank Fernando and the staff here at the hotel. They gave us a tip about there being dark fiber in the building, and that was installed here for a fucking Super Bowl party or press room or some stupid shit like that. And they don't even know what the fuck they have, and they don't even know the difference between single mode and multi-mode. But I really appreciate their help. Building on that, I'll mention Cisco again, RCN, Zach at Yellow Fiber Networks, Jim at NAC.net, and a lot of others. Also, our unnamed wireless provider for pissing me off and being sort of incompetent and being a good backup. Also, everyone who listened to me talk about network shit for a year, I'm sorry. I really wanted to get this right. So thank you very, very much for that. Emmanuel's definitely in that crew. All the volunteers who showed up and helped, especially Lindsay, she directed people to me based on their interests, and that helped me build out the teams. Also, and lastly, every single one of you who attended and politely had your fun and otherwise misbehaved. So thank you. As I said, I could go on, we could talk about the future, we could talk about what we're going to do, but I'd really like to relish the moment and be, well, really thrilled at the precedent we've set because, well, I think it can only improve from here. And I'm really honored to have been able to lead and have met a lot of new people that I think are going to stick around, especially, and including the providers. I'd also like to thank, well, Daily Dot and Mandrill helped out financially too. Mandrill, big time, because we eventually got the cost of patching it and connecting it paid for. So that's pretty cool because it was essentially free. So, those are all the people I could think of. I know there's a ton more people. I'm really, really sorry. I had a lot of shipping to do. We had a pallet stacked up in the warehouse. You know, it was a really busy time. You know, we had all the equipment coming in. It was really, we had Amazon. We had all these packages. Shut up, Louis. So anyway, with that, I would like to introduce our current NOC team and do a really cool presentation on what the fuck actually happened.
Hi everybody. So I first got to say the intro was fantastic. Covered a lot of the bases. I'm going to go through really quick just some of the background of what exactly we did here, how we were able to pull off bringing 10 gig to you, and help you push more bandwidth. So our start, as Kyle was saying, we were asked, he asked the CCC or C3 NOC a month prior to H.O.P.E. if they could assist with running the network this year. Attila and FICO reached out to myself 2 weeks prior to the conference to get help with the core and connectivity issues that they were facing. In less than 2 weeks, 7 business days to be exact, we managed to get 10 gigs of connectivity established to the Hotel Pennsylvania. So I would definitely call that a miracle. I've never seen telcos work so fast. The coordination that took place in order for that to occur, we got 10 gig of transport connectivity from RCN to 111 8th Avenue, which is the Google data center, and Equinix. We got a cross connect between RCN and H.O.P.E. We got 10 gig transit sponsored by Hurricane Electric. We had to get LOAs in from 2 different service providers in order to get the IP space that we needed to run the network. And we had to get an IPv6 allocation from Hurricane Electric. Special thanks to Reed at Hurricane and Peter at RCN for really pulling the strings to make the telcos move quick.
Thank you!
This is quite possibly the most exciting piece. So this is our very own dark fiber. It's scalable up to 100 gig in the future, if you can use it. So the hardware requirements to pull this off. Our core router and distribution were received last minute due to the sudden change of requirements and actually going to 10 gig on such short notice. Literally, we received the last of the equipment the morning before the conference, thanks to Cisco and Yellow Fiber. Core router, distribution, and optics were provided by Yellow Fiber. The wireless controller, optics, and access points were provided by Cisco and Knockpool. In terms of our IP space, we got a /19 from Wright through Falco Networks, and we got a /23 in the Erin region from Sleekwa. We also got a 48 of V6 with some Easter eggs hidden in, if any of you picked up on it. So the hex to ASCII for our uplink interface to Hurricane says 2014 H.O.P.E. And the actual allocation has 2600 in it as well. The network core, we had a Brocade XMR 4000 backbone router, which is capable of up to 960 gigabits, populated with 80 gig of optics ready for consumption. We turned up 5 of those 8 ports this weekend. The distribution switches on MES and 18 were connected at 10 gig. The distribution switch on 6 was unfortunately connected at 1 gig because we ran out of hardware.
Well, to be fair, we were supposed to have a 10 gig switch and it was not.
Yes, that is true.
It was 10 gig, but we didn't have the right adapter.
Yeah. So this was during the Snowden talk. We had to put a fan directly next to the core. We got a little crazy. This is our distribution up on the 18th floor. So we have three switches up here. The buildup of the network, fiber service was completed on Wednesday night. Attila, Fleco, myself all came out and we tested with a light meter, which revolved some silliness because where it was delivered was like right in the middle of a ballroom, and they had an event going on the next day. So we literally had to hide the fiber up in the crown molding to go down the hallway.
Oh God, that was horrible.
The rest of the network was actually completed in one night. So I have some pictures of the equipment that was involved with actually making this happen and how it came in. So a couple of pallets from 2600's warehouse.
That was Louis.
We had free Cat 5.
It's all gone.
Yep, all gone. And the core and distribution were actually delivered with Radio Stabler on Wednesday. We needed a couple of bellhops to help us. I think it cost us like $50 just to get it to our hotel room for the night. So that was fun. That's actually our tag for the RCN circuit. It actually says H.O.P.E on it. Pretty cool. This is fiber dangling from the D-Mart. Advertising the connectivity. Hooking up a light meter. You can kind of see the fiber over here. This is when we were initially running it down the hallway, and then we were advised that there was going to actually be an event the next day. So at the very top there, there's some crown molding. We had to move it further up and actually like tape it into there. So when it was all said and done, it looked like nothing was there. This is Attila picking up the WAPs from Cisco. This was actually the morning of setup. This is about half of the WAPs that we have. Tilla with some much needed coffee. We were up for around 24 hours at this point. Yeah, coffee was not enough. We actually had to get some club mate as well. It was a rough night. Need I say more?
I think there was ethanol involved as well.
Maybe some.
All I can say is that we got the core network online, and we got 18.4 online, 20 minutes before the conference started. And I was still there fucking punching cable.
So obviously, this is a very interesting hotel from a cabling perspective. The only patch panels happen to be on the mezzanine, and that cabinet is locked. So we had to have some lock pickers open it for us. So we were able to connect the lobby, mezzanine, 3rd floor, 6th floor, and 18th floor.
That's never been done before. We've never had connectivity on our network on the 6th floor as well. So this is an expansion as far as where in the hotel we had service. So that's excellent.
So we ran, in order to make this happen, 850 meters of fiber. 7,000 feet of copper with another 7,000 to spare. And we had to rerun the connectivity from the mezzanine to the 18th floor 3 times. It was even approved by the Australian government. If you don't believe me, ask security. So, just to put the amount of fiber in perspective, 850 meters of fiber is 2788 feet. And just how tall is that? Unfortunately, last night at 3:08 a.m., the fiber from the mezzanine to 18th floor was cut maliciously. A handful of the NOC team spent 4 hours rerunning it. Unfortunately, it wasn't on spindles, so they literally had to just drag fiber down and it all got caught up. It took about 2 hours to untangle. So that was the 3rd time that cable was rerun.
I believe that's like a compound fracture.
Yep. Yeah, it looks like a key.
That or a gerbil.
So in terms of wireless access points, we had 49 access points on site. 34 of them were deployed. We would have deployed more, but we were looking for hotspots, and you guys didn't use enough bandwidth. So some interesting stats. 39.5% were on encrypted Wi-Fi. I don't know what to say to that.
How long for string?
42% were on 2.4 gigahertz, which according to Attila is actually pretty good.
It's better than on the CCC, so if you have a device that doesn't support 5 gigahertz, try to buy one. It might work better on conferences.
We had 2,785 unique wireless clients. We had Chris Pringle actually attend H.O.P.E. this year, as did the quote-unquote government. 2 users found themselves as awesome. And we found 1 fuck NOC user, but we didn't catch that one in time. Breakdown by manufacturers on the wireless.
You're not talking about the pioneers.
Top 10 usernames. By the way, you could have used any username and password combination, so. Users on the network, we had 3,000 or so attendees, speakers, etc. 6,921 unique DHCP requests, so about 2 times the number of users. And the most traffic utilization occurred as a result of people actually using the network during the Snowden talk for streaming. And you can actually see that on the graphs, and you can see that it will continue. So we about doubled the amount of traffic we did post-Snowden talk as a result of that. Our peak was 1.5 gig out of 10.
One thing is we really wanted a lot of resources. I'd spoken about wanting to expand and grow, and I knew the seriousness of a lot of what was going on would make it important to have resources, but the way we were doing streaming and the way we were, basically crowded and needing to have simulcast, we really wouldn't have been as successful as we were if we hadn't had the bandwidth we did, because a lot of that stream was coming from the internet. So it was really, really useful that we had this, and, well, you can see it there.
Actually, I want to do big props to Cisco, because they're one of all the access points we had that made it for all everyone who was on the wireless. They allowed us like 4 different access points.
Yeah, we covered that.
So just to give you an idea of the power of the NOC staff and how many of us were watching the Snowden talk, making sure that stuff was continuing to operate. This is a small picture. Hurricane Electric engineers were on site during the live stream to ensure that nothing would interrupt it. Again, thanks to Reed and his crew. One of our last-minute NOC projects was a bandwidth utilization meter, which you might have seen in the mezzanine level. This is it when it was actually spiking and into the red. It's pretty cool. So it was designed to promote the Push More Bandwidth campaign that we were trying to put out there, if you didn't see it. Created by Eat Berries and Now. Yep, it was a blinky tape. It was actually tied into our network monitoring system. So some interesting use cases that we saw. Mirroring of all of Slackware. Port scanning the entire internet.
I'm so frustrated the entire net again. It's still going on.
So we actually had 2 different pieces of software scanning the internet from 2 different IP spaces, which was pretty cool, because we actually had Netherlands IPs and we also had US IPs. And so they were actually split across the 2. So it'd be interesting to see what the difference of the results is. Trace routing of unique paths to various endpoints on the internet. Honeypots. And we actually had someone reach out to us on Twitter and ask if they could put a server in with a 10 gig uplink. We actually gave them a feed directly to the core. For the next NOC, you can actually host servers with us. So some observations. At a security conference, attendees failed to realize that they were on public IP addresses and frequently asked us why. No NAT for you. It doesn't scale. Even with signs up to promote the Use More Bandwidth initiative, you failed to saturate the network. In fact, the peak usage was only 15% of the capacity, but Attila won his bet. Nick from Radio Statler bet $50 that we wouldn't push more than 700 meg. We hit 1.5 gig. So in terms of abuse notifications,
We only got 1 DMCA notice.
I was
only
amazed.
one.
Only one. I'm sure we'll get a flood of them tomorrow.
We only got 1 for the entire weekend.
The interesting thing about this notification, first it's PGP signed. Good for them.
Wait, really? It was signed?
To the user that this was directed to, please follow the instructions here. Stop downloading or uploading without authorization. And please permanently delete from your computers the unauthorized copies of Spider-Man 2.
I'm sorry. Does unauthorized computers mean what we're seeing?
So They were even nice enough to include an XML version of the DMCA in case we wanted to speed up the process of handling it for them. And your IP address, user that downloaded Spider-Man 2, is 199.58.206.163. So if you could just follow up with them, that would be fantastic. An extra special shout out to the rest of the H.O.P.E. NOC team. You can follow us on Twitter at H.O.P.E. NOC. And also to the C3 NOC, Niels and AK-47. They actually saved us the morning of the conference after myself and Attila had been configuring for over 30 hours. We actually ended up getting to sleep, I don't know, maybe around 2:30, 3 o'clock in the afternoon. And they were willing to assist us from across the pond. That was fantastic. And it definitely wouldn't have been possible without the sponsors listed here. We really appreciate everything that they did, especially so last minute. What we still need, we need help tearing down the network. Please meet us in the NOC after this talk. What we look forward to next, we want users to expect decent bandwidth at these conferences. We want you to show up with your servers and wired connections to connect to the network and push more bandwidth. Thank you.
Please, we only push 1.5 gig over a 10 gig connection. We want you to max out it. You got no aim. Hey, the NOC's still open. We still have 1 gig drops. Come there, get some internet.
There will be no dying just before con ends. All right, guys. Sorry, just give me 1 second to get hooked up. And my name's Tech Jarko. I run Radio Statler along with a couple of people. And this year I wound up helping out with running the Snowden talk from a technical aspect, and along with the AV guys who, again, did an absolutely incredible job with it. So let's just give them a quick round of applause for the amazing work they did. And I also was helping coordinate streaming, which I'll get to in just a minute. No, I don't need to say. LibreOffice, but there we go. Okay, so, yeah, hold on. All right, so, this year, remote speakers. H.O.P.E. this year had currently one of the most prominent people in the field of hacktivism and everything, Edward Snowden. And because obviously he can't set foot back in the country, we had to do it remotely. He had done South by Southwest, but there had been a lot of, issues. So we wanted to make sure that for our event, when we had 2 people who were absolutely incredible in this area, in this field, everything would go without a hitch. And thankfully, as we all know, it did. That said, it was not that easy. There was a significant amount of planning. Step 1 was to not use 7 proxies. You can boo me all you want, but we also went through and we were planning because, as we all know, things go wrong. And sometimes it's not a bad thing, but when we have the keynote speaker and the conversation with someone who is going to get watched from around the world, we don't want stuff to just not work. So we had multiple things. We actually had several fallbacks involving calling him in Russia and having using the phone line back there. That's also used for social engineering. We had another fallback which involved having someone sit up on stage with a laptop and type messages back and forth with him, have someone read them, and then type what was ever being said by Ellsberg. And the absolute last fallback was that we would, by any means necessary, use anything from text messaging to secure messaging to whatever we could make work at the last minute. So we actually wound up using Google Hangouts to do the entire thing. Yay, Google. Although, anybody from Google in the audience, particularly anybody that works with Google Hangouts, if you could make it so I can mute things like chat messages that happen in the background. I'm assuming a lot of you heard that little during the chat. We had to send them a message, and yes, we could do something like that, and also if we could make it so we can permanently hide the friggin' icons, because anytime we move the mouse, they would come up on screen. We used Google Hangouts to chat with him, and we connected him a little early, and it was actually pretty amazing how well it worked. This time, we had a bunch of people who were here who watched the talk at South by Southwest or were there at South by Southwest. And one of the complaints that we have heard was that when last time he did a remote session, it was less a video and more, I'm going to quote actually Mitch here, a series of still images stuttering together. This time we were able to pull it off without a hitch, and with our first plan actually worked. And there's a couple of people in particular that need to be thanked for that. Emmanuel for working to set it all up, Kyle, Fred Newby for making sure and recording everything before the conference. Our AV folks who managed to, I will say, we had a whole bunch of stuff wired together. So our AV folks were actually hooking everything up at the last minute and making sure everything worked, which was a little interesting. We actually had 3 MacBook Pros running back there. So it looks a little bit like an Apple store, but it works, so I can't complain. Well, the way we were pulling it was actually the same way we're doing it right now. We pull from the display port, use VGA. We also learned another little interesting about Google Hangouts for the Google people here. Can you please make it so that when I plug in a USB sound device, it can send and receive audio to it at the same time? We discovered the hard way that Google Hangouts does not like that. So we had to use 2 USB audio devices, professional USB audio interfaces to send and receive audio. The Snowden talk was important for us, and we knew that there were a lot of people who weren't here that wanted to watch it. As such, we did remote streaming this time, and I'm going to talk a little bit about how we did, and then I'm going to bring up the folks from Internet Society who handled the entire thing for us this time. Sorry, just stuff last minute. So, this map. Hold on, sorry. Freaking. Anyone remember on Fedora how to make it switch over to mirror display? Since it's not working. Huh? Seriously, anybody know? I apologize, this is actually the first presentation I'm doing with this, so it's my fault for not really preparing in advance. Nailed it! There we go. So, this map here is where we were streaming to. Any country that is not in white was watching the H.O.P.E. conference remotely. We were actually trying to see if there's somebody who knew someone who worked in Antarctica. We were trying to see if we could get all 7 continents, but unfortunately we weren't able to reach them. That said, we were 6 countries, just about 6 countries from getting all of Asia, Middle East, and Oceania. We had people watching in every country in Europe. We had people watching in every country in North America, from the majority of South America, and from parts of Africa. All of the 6 major continents were watching this talk and were watching this conference. These are our analytics just from the embedded web players. Just from the embedded web players, and we know for a fact that a lot of people were also watching the live stream, and we also know that there were several organizations mirroring our stream that other people were watching. Just on the embedded web page, we had over 15,000 unique viewers. If you combine that with the another 1,100 from Radio Statler listening to the audio-only feed, to the viewers on the live stream, that alone brings us to significantly over 20,000 people watching this conference. We had people watching from over 140 countries. This is significantly more than most other conferences can ever claim. So thankfully it was for H.O.P.E 10. I'm going to take 1 second and bring up the Internet Society. I want to thank Joanne McPhee and Paul Breaker for their incredible hard work. We had some issues with communication, so the streaming actually got agreed to and the serious planning started on Tuesday. Thankfully, these guys were able to pull everything together and do such an incredible job. I mean, we had HD feeds from every room out to the entire world. We had, and everything is worked wonderfully. So if I can just get Paul to come up for a second and say a few words about the Internet Society, who sponsored the whole thing for us.
Thanks, Darko. Thank you. So one of the key reasons I'm here is to make sure you know about the Internet Society. This is Jolly McPhee. He's a member of the New York chapter of the Internet Society. I represent the Internet Society Global Organization. But if you don't know about them, we were set up 22 years ago by a couple of hackers named Bob Kahn and Ben Cerf, who did something really special. They created the Internet. So we were set up by them to continue to make the Internet better. We do many things to make the Internet better around the world. We're a global organization of 65,000 members. We want you to be members. We want you to join a chapter. And we were so thrilled to bring this content to all of our members, but to the Internet at large. We hope to be here in 2 years to do it again. This is great stuff. So I think the introduction is made. You know, Internet Society, we know you. We want to keep this relationship close, and thank you for the opportunity to allow us to do it. I also want to say the live stream platform served us very well. I have to give some props to them. We used, for the technical issues, the technical infrastructure, I should say, we used the HD 500 streamer, broadcast streamers from live stream. It was great stuff, so good stuff. Thank you.
I just want to say that the slogan or the motto of the Internet Society is that the Internet is for everybody, and I'd like especially to thank the H.O.P.E Knob for bringing the Internet to us as well as everybody else.
Speaking of live stream, one thing to note is that the H.O.P.E conference was one of the top watched live stream for the entire weekend, and we were the #1 featured stream throughout the start of the conference until now. So that's pretty impressive. For the first time we're doing real streaming. Sorry, I should I'm kind of an asshole for that. So Radio Statler also is a project I run, and it's a streaming audio station that runs out of the mezzanine throughout the duration of the conference. We streamed a couple of talks this time. We do interviews with speakers, including we were the only organization, I believe, to have Daniel Ellsberg come talk to us after, and he told all the press like him to go shove. Yes, thank you. We also had Drake and many others of the speakers, people who are here from organizations, Hackerspaces, EFF ACLU, and our goal is to bring the comm to people who can't make it, to improve what they get from remote. As part of that, there's a few people I just really want to thank, because I got bumped to core staff this year and had a crap ton of stuff to do, so I really want to thank the 3 guys who really picked everything up for me at Radio Statler, which is Stopegg, who takes care of all of our web dev, Nick God, who takes care of all of our engineering, and Beaches, who takes care of all of our program and direction and everything. And so just give those 3 guys a round of a hand. They've all been amazing.
part of that, this year Radio Statler broke, we had a total number of listeners of 1,057. So we had 1,000, and granted, that sounds pretty insignificant compared to the 20+ thousand people watching the streams, but for something that was pretty much unique content and not people coming to watch a Snowden talk, we pulled off a pretty amazing thing this time. So, and we will be back next time to do even more. As part of that, we got some free shirts we want to give out, so Bunny's going to come up and throw stuff at you. And Johnny Xmas. So a few of the things we just want to talk about with Statler. Johnny Xmas, Bunny actually used to be our program director and has decided to start enjoying the conference again, which if any of you have ever volunteered at a conference, you'll understand. Johnny and his girlfriend Babs also stepped up and really helped us out and helped out with Twitter and our outreach. And we also want to thank Aesthetics and Naomi and Andy with the press group for helping us make sure that we were able to get access to the speakers and that the speakers were advised that we were there. Thank you guys for everything. I mean, we did the conference did some amazing stuff this year. And hopefully in 2 years, we're going to blow all those records right out of the water.
Kind of like breaking glass backstage. Thanks for coming. We did some new things this year that we hadn't done before, which is like a whole series of movies, which turned out to be really successful. Some people were out here till like 3 o'clock last night watching Algorithm, a new thriller film, which is online, available for free. I want to thank a few movie directors who came and showed us brought their films, traveled across the country from California. Jonathan Schiefer of Algorithm, Brian Knoppenberger for The Internet's Own Boy, the story of Aaron Swartz. Very compelling film. Robert Greenwald, no relation to a journalist by the same last name, who introduced War on Whistleblowers. Johannes, with his film I can't pronounce the name of. The Investigation Discovery Channel, who screened the world premiere of Nowhere to Hide, starring our biennial speaker, Steve Rombaum. So that was all entertaining. Did you enjoy the movie series? Should we do that again? All right. Maybe we'll do even more next time. On the radio front, there's Radio Statler, but we actually had an actual radio station here with antennas broadcast.